All right, good morning. So here we are at CRX 2021, and it's the last day. Boo. Um, I'm your host, Jim Drew, and we've had a pretty spectacular event so far. We're happy to be doing this in the trying times that we're in, and hopefully next year that won't be something that we have to do. We like to have some kind of a virtual component to CRX if we can always, but obviously it's better if we can all meet live in person in Las Vegas, so everybody can have face-to-face meets and have some fun. So I'm actually doing a presentation today, and we're going to do a lot of screen sharing. So you're going to have to bear with me as I share screens and such. And so my presentation today is on something not related directly to Commodore stuff, but certainly is used for Commodore stuff. And that is the creation software we use for making things. So in the Commodore realm, we do things like making cartridge cases. So yesterday, David Yao did a presentation on the Runic Commodore 64 keyboard, and he actually made a Runic keycap set. He also made a Runic cartridge, and those are things that he actually was able to make. But David went the extreme route and did all kinds of interesting things like SCAD and such. So what I'd like to talk to you about today is the premier software for 3D modeling has always been by default, and they have a program called CATIA, which is used by people like General Motors, automobile manufacturers. It's really expensive software. I mean, way outside the price range of even most regular commercial developers. So they have a product that's called Solidworks as well. And Solidworks is the basically the dumbed down version of CATIA, which is hard to believe because Solidworks is incredibly powerful. And so Solidworks has been something that's been out of the price range of makers because it's expensive software. So you have to have a reason to want to use SolidWorks or need to use SolidWorks in order to justify buying a license for it. And so last year, the Autodesk people made a maker version called Fusion 360. And so Fusion 360 is software somewhat like SolidWorks. It's a 3D modeling program. It's quite a bit different in the way that the interface works and such. Dassault has a variety of patents on how the SolidWorks operates, so they're duplicating some of that because of that reason. To me, I got a license for Fusion 360 because of the keycap campaign, actually, because it has some really good importation of mesh models, which mesh models are like STL files. So you can convert the mesh into a solid body. And that's something you have to do when you're trying to convert one thing to another. It's kind of like the ever-ending battle of converting video formats with different types of codecs from one format to the next. There's different types of 3D modeling and different types of models themselves, or it's a mesh model or a solid model, or maybe even a combination of the two. So Fusion 360 had some good import capability for that. So I got a license for it and used it. And it's okay. I mean, there's some features about it I like over SolidWorks actually, but for the most part, SolidWorks is just a lot more intuitive and a lot easier to use. But you have to be justify as a commercial developer to even have a license for it until now. So after a lot of crying of all the makers out there, Dassault makes now a SolidWorks for makers, and it's called 3D Experience for makers. And let me share my screen here. If I can pop up, if I can figure out which Zoom meeting I'm in. Okay, let's share that screen. And there we go. So if you go to their website, and it's up here, I don't know if you can read it or not. It's discover.solidworks.com/makers, and you can take a look at their website. Now, by the way, they have no idea I'm doing this at all. I have not any kind of contact with Dassault. It's just something that it's so amazing this is available to makers now at an affordable price. It's something that I really thought that everybody should know in our communities, because this is how you can create something really easy for, basically nothing compared to what SolidWorks normally costs. So the SolidWorks for Makers experience, you'll see information about it. It's in here. Who can use it and such, and what it costs. Now, the thing that was astounding to me when I first heard this is I thought it was a joke, because you can get the SolidWorks and all the different little apps for it. So they have an online, there's like multiple different pieces of software. It's online, cloud-based, and they have a sculptor and a creator and some other little goodies for it. And so it's browser-based as well for those apps. So you can run it on any browser and any platform. It's integrated into your browser. And it's a little bit different than the traditional SolidWorks for working with it, but the gist is the same. Because of some limitations in a browser, you don't have some of the nice like right-click functions and stuff, but it's very usable. But the reality on the pricing wise, it's $99 a year for the license. Fusion 360, I paid $360 for the year. So this is quite the bargain for it. And you can also do a month-to-month subscription, and it's $9.95 a month. But if you do a whole year, it's $99 for the whole year. So it's cheaper for that. So let me see if I can get one of these to actually work. Let's see, I should be sharing. Bear with me here for a second as I go through 50 different screens. There's the screen I'm looking for that I cannot find. Huh. All right, let's see if this will share. Well, it shares. Hmm. So for whatever reason, the audio did not play through this, but you get the gist of what this is. Let's see if I can actually redefine this. So basically you can see you can create like whatever you want with it. Let me try another one of these here with this on the sharing. Let's do a new share. There we go. So we'll share this optimized. This might actually work a little better here. There. Yep. Okay.
With 3D Creator, part of the brand new 3D Experience SolidWorks for Makers offer, you get the precision you need with parametric modeling tools. You can seamlessly switch between 3D Creator and the sub-D modeling capabilities of 3D Sculptor with just one keystroke. You can also import and export models directly into 3D Experience SOLIDWORKS. With 3D Experience SOLIDWORKS for makers, you'll get to experience the best CAD software on the planet and save big.
Okay, so you can see that's the creator version for makers. There's also a sculptor version for makers. Now, remember, all of these come together in the same package. So you get all three of these in the same package. So let's take a look at sculptor. So sculpting is interesting because in the past, SolidWorks has been not known to be a sculpting program. It's a parametric modeler. And there are other CAD software that are designed for what they call NURBS modeling for doing contours and such, like Rhino and such like that. And so this was kind of new for me. I was surprised to see this. So let's take a look at this.
With 3D Sculptor, part of the brand new 3D Experience SOLIDWORKS for Makers offer, you get to mold digital clay to create organic shapes and surfaces with powerful and fun sub-D modeling tools. You can use images and sketches as templates for designs, and import and export directly into 3D Experience SOLIDWORKS. You can also switch between the parametric modeling tools in 3D Creator with the push of a button. With 3D Experience SOLIDWORKS for Makers, you'll get to experience the best CAD software on the planet and save big.
So that's a video on the sculptor, and there's quite a few really known, well-known YouTube people and engineers and stuff. So they have some neat videos in here. I want to share these with you as well because it really kind of showcases what SolidWorks can do in practical applications. And it kind of it plays into what we do in our community because these are things that people could use, you know, for building a Halloween costume or, you know, Commodore 64 controlled whatever. So let's take a look at this.
What's up guys, my name is Brad and I run a YouTube channel called Impact Props where I make awesome things, helmets, replica costumes from your favorite movies, video games, whatever. And then we go do crazy stuff with those characters. But first and foremost, I am a maker, which is why I am so absolutely amped to be talking in front of you today. So I've been using SolidWorks for the past probably 6 years professionally to create and design. SolidWorks is an incredible design software that I love. I wouldn't pick a different one. SolidWorks is my go-to software when designing and creating. But as a maker, the price tag has notoriously been way out of my price range. And I've been asking and asking and begging and begging and begging for SolidWorks to make a version of SolidWorks for makers that is more affordable and would allow people like me to create incredible things using this software. And I'm so excited to be telling you this today because as a maker, SolidWorks has answered our prayers. SolidWorks is the industry standard for 3D modeling, and today, if you're a maker, you can get it for $9.99 a month. Woo!
Woo is right. Okay, so there's another one as well that I'd like to share with you. It's another video from another maker.
Hello, my name is Rob, and I'm a maker and mechanical engineer. You may know me as that guy who creates 3D models every single day and posts them through the CAD Model of the Day project. I use SolidWorks every day to solve my problems, explore engineering, and bring concepts to life from the textbook. And I believe it's overall the best tool to generate 3D CAD data for 3D printing, rendering, and motion simulations, just to name a few. Anyone who follows my live design streams on the Virtual Flat CAD YouTube channel knows how powerful this software is, and I am astonished that it's being offered along with XDesign and XShape for about the same price as a streaming service. This makes me so excited because I can't wait for people to take advantage of this offer and start following along in all the fun. I can't wait to see what you come up with.
Okay, so that's enough of the promotional material. Like I said, I'm not getting anything out of this from Salt at all. I just wanted to share this with you. And so questions, of course, everybody has about this. Who is eligible to purchase a 3D Experience SolidWorks for makers? Well, 3D Experience SolidWorks for makers is meant for personal projects and for non-commercial use. Since per our terms and conditions, you may sell items that you make for a profit up to but not exceeding $2,000 a year. If you're interested in building your business with SolidWorks tools, check out the startup program or the commercial offers. You can click on the links for those as well. So what it means is for makers, and that's most people, in our community for the Commodore realm. If you want to make, a bracket to mount your 64s on the wall, or if you want to make, like today, we're going to make a couple different things that are useful for our community. Then there's no cost, you don't have to get the upgraded license. If you are a developer, if you are a commercial entity, like I do stuff, you have to use the full version of SolidWorks if you were going to go that route. But I would say for 99.99% of people watching this, this is what you basically you're going to want this, and it's really inexpensive, and it's not so dumbed down. I was a little bit surprised because there's, like I said, there's the online version, which is the was it XDesign and the with the Sculptor, or XShape, which is the Sculptor. And so those are the browser-based ones, and literally you can use them anywhere in the world wherever you had, and it's all cloud-based. So they talk about in their information about what's the difference between the 3D desktop version, which is the full version, and the 3D Experience SolidWorks. It's basically the same version. The version that's included with it is the SolidWorks Connect, and that is actually a native app that runs on your PC. I don't know if they've got a Mac version or not. I think they do now, but I run it on a PC. It's a native app, and it is SolidWorks 2021. It looks identical to the regular software. It's missing a few things, and all your storage is going to the cloud, which is fine. So let me show you, they've got the maker community, which you can see here. And so there's a ton of communities that you can join. And so this is quickly becoming like the GitHub for makers. And so you can, come in here and you can share experiences. And your project that you develop, you can actually link with other developers, and you can co-work on things. You can share things back and forth. So that's how it all works online. It's actually superb how they did the integration for this. So let's get into what it really is. So parametric modeling is software that you can optically see and stretch and manipulate yourself. So it's a physics thing. It's something you can, tangibly grab an object and move it around. And so that's what's called parametric modeling. So let's go take a look at the interface here. So when you pop up, when you license it, you can see my name's licensed up here for it. You get this window. This is actually in a browser. And you've got, I've already set this up for my two favorite apps, which is the SolidWorks Connected, which is the native app. And then there's SolidWorks Visualize Connected. We'll talk about that in a bit. This is how you do the 3D rendering to get the nice pictures of your project you're going to be releasing. And so if you click on my apps, you're going to see a ton of things in here. So all this is actually included with the license for this. And at the bottom here are, it's alphabetical. I'm pretty sure it is. I maybe can move things around. X Design and X Shape. And these are the browser-based versions of it. And I'm not thrilled with the browser version only because I like the regular interface for SolidWorks. It looks pretty much the same, but it's a little bit different in functionality. The right click of your mouse you can't do because that's a browser feature, you know, so there's some limitations there. So when I run this, I actually run the standard native app, and I will pop that up here. Oh, it says, please remove this window to be shared. Okay, I guess we will do a new share, and we will share this screen, and ta-da. Okay, so you can see the background here. When we pop it up, it says SolidWorks Makers, and so this is let you know you're using the Maker Edition. And in the upper corner you've got your account information up here and stuff. And so one thing that people look at the modeling, especially when you see things whipping around the screen really fast, and it's a little intimidating at first. And I know that I was the same way, but I like to try to learn something new. And what I found, it's really not that intimidating once you understand some basics about modeling software. So what we're going to do is we're going to create a new part. So you can do a drawing, a 2D drawing, you can do a part, or you can do an assembly. And I will talk about the part and the assembly. I don't do too much in the way of drawing. It's strictly just modeling for this. So what we're going to do is open this up, and you can see it pops up. So the thing about SolidWorks that makes the most sense to me, as opposed to like Fusion 360 and other programs, is the fact that we deal with planes, and the planes are named front, top, and right. And you can see as I go through here, you can see exactly where the plane is located. And so if you know what a plane is, it's a front view, it's a top view, or it's a right view. So that's pretty obvious and pretty easy to understand on that. This is called a tree over here. So as you build your part, or as you build your sketches, this will come here. If you're using Fusion 360, there's a timeline that's on the bottom of the screen down here. So that's the difference between those two packages. But to me, it's pretty intuitive to do it this way. So if we're going to design something where, let's say it's just a cube, that'd be a good starting point. So we want to start from the front of the cube, and they have what's called a normalize, normal to. You click this little symbol here, it's normal to, it straightens out your image. So now you're going to be sketching on the front of this. Now a sketch is exactly what it sounds like. It's a sketch. And so you're actually going to be drawing something. And when you see this, it's pretty easy. And when I saw this being done by another engineer, I was like, okay, I can do that pretty easy. It's not that hard. So what you want to do is you want to pick your surface you're going to be using, like your front, and then you can, I always do that. You can say sketch, because you want to sketch on that plane. You're going to sketch on the front plane. And let's say we're just going to build a corner rectangle box. So neat thing about this new version with the makers is that they have all these little neat pop-ups, and they have help. And so it tells you when you hover over top of the function, what that function does with a neat little, mini GIF basically of how it functions. So like the line drawing, it does the same thing. If you're doing a circle, it shows you the same thing. So it gives you a little help over each one of these, which is neat. So let's just go make a box. So the front you saw here, we'll just do this real quick. The the front plane here, this is just a reference for you. You can move this anywhere you want to. You don't have to include your model inside of this. This is just saying this is where this particular plane in the space is located. And so the center section here with this little arrows, this is called the origin. And you'll notice it gets highlighted over here when you do it, when you click on it. So the origin is the center of the universe. So basically you want to think about your front plane, your top plane, and your right plane. You can see that these are all centered on the origin itself. So if I do this and I move this, you can see that this actually changes the origin. And if I show you the top and the right planes, you can see that they're actually centered around that axis. So this is the center of the world right here. And you want to make sure you try to center all of your models on the origin. And there's a huge reason for that. You'll learn later on working with Solidworks that if you want to go scale something, scaling proportionally only works correctly from something that's been modeled on the origin. So it is proportional correctly. Sometimes you don't want to do that on purpose. So what I like to do with this, if I want to make a box and I want to center it on here, then we use what's called a center line function. And the center line lets you do exactly what it sounds like. You draw a center line. So you can do this. Now, you notice I'm going to the pull down menu for each one of these. There are hotkeys for everything and it's programmable. So you can set it however you like. So if you want to move this, you can just drag this to the origin. You see it's going to stretch because we haven't defined any of these sizes yet. Let's do that first. So one thing about SolidWorks is nice is that they've got this thing called Smart Dimension, and it talks about it here in the little pop-up, what it does. If you click on it and you click on a piece, you can see that we're set for metric, by the way. I switch back and forth between metric and US depending on what I'm doing. So let's say if we want to make a cube, let's do our cube that is going to be 60 millimeters. And we're going to do it by 60 millimeters. And so now that we have it defined for our size, we can grab the centerpiece and you notice that it will actually slide around. And so if we want to move it to the origin, we can do that and it'll actually snap to the origin, and which is pretty handy. But you can also do a deliberate placement by clicking on it, the center of your box, and clicking on the origin. On the left-hand side here is your relationships. So you can either make it horizontally aligned, and you'll see that it actually made it perfectly aligned horizontally here. Or you can do a vertical alignment, which you can see it does vertical. Let me move this so it's a little more obvious. So now vertical will snap to the vertical. Or if you want to do coincident, which is what you want to do here, you say coincident and it snaps to wherever you've got it set to, which was the origin. So now we've got our sketch of this. So, and that's it. I mean, this is the whole way to make a cube right here. So we've got this basically one flat plane. So in order to make a cube, we need to extrude that. And so what an extrusion does is it takes this and then makes the surface however tall you want. And in SolidWorks, so you've got the ability to, you click on your sketch you want to extrude. And at the top here, you have all these options, and you can highlight or hover over top of any of these functions, and it's going to show you what the function does. So this is super handy, and this was not been here. I mean, I've got an old version of SolidWorks now, but this is new to me. I think it's great. I mean, I already knew about it, but so if you want to do like a boss extrude, there's a bunch of different things that you can do. So we'll click on this extrude, and you can see that it pops out. And so if we rotate this, we can see exactly how far this is actually extruded. And we can look over here in our menu on the left-hand side, and it's kind of hard to read, I guess, on here. It says 10 millimeters. So you can either enter a value here, or you can grab the tip of this, and it actually highlights itself in orange, and then you can just drag it. And when you drag it, the value of the distance actually changes in the box up here. So you can select your size of a variety of different ways. So this is going to be a cube. We can set this on purpose to be 60 millimeters. So now we've got a cube, and if we say OK, which is a little check mark, well, we created a cube. And so that's how easy it is to make an actual solid model for something. Now, if you were to save this and export it as an STL file, you could take this to your 3D printer and you could print a 60 by 60 by 60 cube. Probably not very functional, other than maybe measuring the cube itself, or for your printer, how accurate your printer is. So this isn't too useful for us, but let's talk about 3D modeling in general. So you're doing a cube like this. Let's say you wanted to have a hole in the cube. Like on this side, you want to have a 10 millimeter hole. So what you want to do is you want to pick the side that you want to have a hole in. So if you want to have a hole that passes straight through, you just pick your plane. You can pick either this side or this side if that's where you want it to pass through. And everything in SolidWorks is based on the surface you want to manipulate. So if you want to put a hole through here to the other side, you need to select the surface as the surface you're going to be using for, and that's what you're going to sketch on. So we're going to click on that, and then we're going to say on the little pop-up menu here, sketch. It'll normal to. So now our sketch is going to be drawn on this physical surface itself, not on one of the planes, because we've got planes over here that we can select. We want to put our sketch on a plane, but now we're putting it actually on the surface itself. So let's go and sketch a hole, and we grab the little hole, or the round, I'm sorry, the round we'll do here. And then we click, and then we simply drag, and you can see that we can select however big we want this way. And it gives you an idea of how big it is. It shows you like R equals, and which is the radius. And it shows you in here that the radius is 1/2 of the diameter. And if you know back in the geometry class, and then you can adjust your angle, you can see here. So we'll just click here, and then we'll say okay. And once we're clicked on here, we can go back to the smart dimension, and we can click on our object, and we can set the size. And you can, it's kind of nice, you can do it this kind of a way of looking at it, or you can go off the side like this, or move it out of the way. So they're really good about moving the text away from your drawing, so it's a lot easier to view later on, especially when you've got a lot of different measurements in your drawing. So we're going to set this to be like 10 millimeters like we wanted for our hole. And that's it. So now we've got a sketch. So let's take a look at what this looks like. If we manipulate this, we have put a circle on a surface. So and you can see it's not doing anything other than it's drawing a sketch. So if we had a cube in our hand and we had a pencil, we simply draw a little circle. That's basically what we've created here. Now, in our workshop, if we had a cube, like if master woodworker Joeri were to make a cube like this, he would draw with a pencil on it and probably take the little center punch here and punch it, and then walk over to the drill press and pop it in, and then drill the hole all the way through. Well, with SolidWorks, it's kind of the same thing. You basically are going to select your sketch. Let's get out of the sketch here. We'll select our sketch, and then we're going to do a extrude cut. So we're going to cut into the unit. So our cutting, excuse me, is, you can see it's going to show you where it's going to go through. And we have the option to pick how far it's going to be going in. So for example, once again, we can grab the tip of this, and we could say it's only going to go this far inside for it. So let's say we wanted to do for whatever reason, a 20 millimeter hole. We select 20 millimeters, and now you can look inside and you can see we have a hole that goes inside, and it's not going all the way through, which is pretty nifty. But it's not very functional for us. So what we want to do is we want to go and edit this particular feature. And I will say, get in the habit, if you use any kind of CAD program, of going and in your little tree or in like solid or the Fusion 360, the timeline of naming what these are. So this is really important, especially when you come back a year later and try to figure out what you were doing. So I named this as main. And then this cut, we're going to say 10 millimeters hole. And so now we know that's what that is. So we can select this. You can see it gets highlighted here. And then we can say, right click on here, edit the feature, which pulls that same menu up that we saw on the left-hand side. And now we can say, all the way through by dragging this. So you can see that we're actually extruding or cutting way further than the cube, which is fine. You can do that. It doesn't really matter until you start adding other pieces to here. So you probably don't want to do that. So there's a couple of ways to limit how far you cut in here. Either physically here, we know that's a 60 millimeter cube, so we can put 60 in here. Or we could go up to this other menu above here, and we can say how it's actually done through all, which means through all that's on the display as far as your model goes now, which again can be dangerous depending on what you're doing. So if you add something to this later on, it's going to go through that too. So you don't want to do that. You can say up to next, which is the next feature part. I usually say up to surface, and then you select the surface. So I'm going to say, I'm going to go all the way through until this other side. And you can see that it highlights that wall in the pink, and then the yellow color is where it's going to pass through. And so you say, that's it. And now magically, when you turn this, you can see through it. So there's a million ways to do a CAD project. And there's a million right ways to do it and a million wrong ways to do it. And really, there's really no wrong way to do it. It's just, you can make yourself a lot more work later on as you progress through your model, depending on how you do certain things. So for example, there's times when you want to put your holes in last, and there's times you want to put your holes in first. So if we know in our model, because we've got typically a good idea what we're developing, or maybe we're copying something that exists already, which we're going to be doing a bit here. And after I finish this little part of the presentation, we're actually going to make something that's usable that we can use in the Commodore realm, which is pretty cool. So we have, our design that we want to make in our head, or we've got something we're going to copy. So we have to really lay out the path that we're going to be doing. So in our case here, if we know we're going to be putting a pen through this later on with another piece, this might pivot or something, and we know that there's nothing else going to be associated with this particular hole, there's a neat way of actually doing this at the same time. So let me suppress this hole, which is a neat feature Solidworks lets you do. It's you can see that it actually ghosts out. So it suppressed that particular function in your tree. And we can go back into our main sketch. We'll say edit sketch. Okay, and now we have our sketch back. So when you do a extrusion, anything that you have inside of your extrusion will be excluded. And you have the option, advanced people know that you can actually use this center part and exclude the rest of it as well. But for most people, what we're going to do is, let's do that 10 millimeter hole again. We're going to go up to the circle, and we're going to put that 10 millimeter hole in here to start with. And we're going to say, okay. And we're going to smart dimension this as 10 millimeters. So now we got our 10 millimeter hole. Okay, so that's fantastic. We got a hole here, and let's say that it's supposed to be located here. We didn't actually specify where this is supposed to be located in the grand scheme of things, but we don't care, just for this demo. So now when we exit out of this, through the magic of SolidWorks, the hole's already through there. So you don't have to do a second operation to do it. Like I said, there's times that when you're going to want to do the hole after the fact, because if you start adding things and need to have the hole pass through, let's say you add a wall to this, or like some kind of a structure that gets installed inside of this, like recessed into it, that will actually poke through your hole when you do it this way. So it's an order of operations. Basically in the tree over here, this is the operational order of your functions that you're doing, whether it's a extrusion or a cut or a loft or a fillet or anything else. This is how it's actually done in the order. And you can suppress an item and you can actually roll and roll back. So if you need to, you find you've got this kind of a problem like this, you've got this long tree of stuff and it's a mess because you want to insert something in here, you can actually roll backwards and then insert something and then roll forward. And it may affect other parts of your operation for doing mating and such, and we'll chat about mating as well here in a bit. But so like I said, if you think about your design in advance and you know that you're going to have something like a hole that's not going to affect you, then you can go ahead and do a quick way of doing with a sketch this way, because it does make things easier. You have one less item in your tree over here. Honestly, if you're a newbie at this, make the separate holes, because inevitably you're going to find, oh man, I wish I wouldn't have done it that way. And I've done that many a time myself. So a lot of times I actually will, if I'm uncertain about something, I'll go ahead and stick, do the hole over here, and I'll unsuppress this. And then I'll have two holes now, obviously, because we've got one here. So I can go back to this and I'll simply hit the delete key, and it's going to ask about replacing it with another entity if I want to. I'm going to say no, just replace it, just delete it. And so we're back to our original cube here. Okay, so let's talk about a few other features here that we use for 3D modeling. I mentioned fillets, and so fillets should be done last. Like I said, there's a really important that you understand that if you're going to be referencing something like an edge, let's say from here to here, you're going to be referencing it in your model for some reason. Let's say, well, let's do this real quick. Let's go do another sketch. So you can see this example, and I'm going to say I'm going to build a little box here. Okay, so in our smart dimension, I'm going to say I want to reference the top of this box to the top of our cube, and it's going to be 10 millimeters from here. And I'm going to do the side the same thing, and I'm going to make this 10 millimeters from here. Okay, so this is now our reference for this box, and then our box itself has no dimensions yet. Let's make this a 6 by let's do 8, 6 by 8. So now we made a little channel slot in here. So referencing something from here is critical. In order to be able to reference it, you have to be able to grab the edge. You've got to be able to highlight the particular edge. And so now we've got this nifty little box here, and we'll exit out of here. And let's extrude this. Let's make this an extrusion instead of a cut. So you can see I've got it poking out of the box. And you can actually select which way it's going to go by clicking on the direction arrow here. And again, you can do just by grabbing this, you can adjust the length of it. So let's leave it random right there. Okay, so this is sticking out of our thing, and it's referenced to the edges here, and that's how that works. So it's really important that to remember this of anything in any CAD program. When you're going to reference something, it has to be a line that can be referenced. So if we want to make this box pretty, we're going to add some fillets. And a fillet is, as you can see, is something that will make it rounded, so it's more attractive. So it squares, or from a square edge becomes a nice rounded edge. And obviously that's too big of an edge. Let's go with like a 1 millimeter. So you can see, let's go back to edit that so you can see it a little easier. So this is a 1 millimeter fillet, and it gives you a preview of what it's going to look like. It's kind of small. Let's do a 2 millimeter. And you can select your units over here. I'll talk about that too, about unit selection and such. So that's your 2 millimeter fillet. So it's nice and round. And neat thing about the SolidWorks, of course, is that you've got multi-select for everything. If you hold down the shift key while you're doing this, you're clicking on your hard edges, like I was talking about, then you can select all of your different corners of your cube, or edges of your cube, I mean. So we'll select, if you select a face, it'll select the whole thing. I was trying not to select the face, but I did by accident, because sometimes you may not want to do, like, if you don't want to do the bottom of this, then you don't want to select it, but we can actually use the control key to get rid of anything we don't want to select. So let's say the bottom of our cube is going to be flat. We don't need it rounded at all, like that. Let's do this one as well. Okay, so you can see on the preview, this is exactly what it would look like. And then we can say, okay, and that's what we get. So we get these nice little rounded corners of our cube. And notice if you see the lines that are hard lines in here, you can change that view in here. If you don't like it, you can make it a wireframe view. You can make a view like this where it looks all nice and smooth, kind of like a rendered version of it. It's a little harder to see the lines. You can see that it actually selects in orange as you move over something. So I prefer the view of, basically it's a combination of hard edges you can see in black as well as there. So it makes it easy to see. So what do you think is going to happen if we try to reference this edge now? Well, the edge is gone. So you can reference either this side of it or this side of it. And so if it was critical in your design that the top of this to this is 10 millimeters, and there's a convenient way of measuring in SolidWorks. You can go to the measuring tool after selecting your surfaces, and you can see, in fact, that it is 10 millimeters tall, and there's a lot of different ways that you can measure different distances, like from here to here, here to here, all these different types of angles. It'll actually give you the correct angle. So if you want to know from here at this diagonal, it's 10.2, millimeters. So it's incredibly accurate, obviously, because it knows. But there's no way to use this edge anymore as a reference, because that edge is gone because you actually made a fillet there. So think about that when you're doing your design. You always make it pretty last. That's how you should look at it. So you don't want to make something that is pretty up front. It's hard to get out of that habit at first, because you're like, oh, I want to see how it's going to look when it's done. Some kind of a premature thing. For example, like if this hole here, you're like, oh, this should be a recess into it, or a chamfer, which is this, like this, and we'll make this a 4 millimeter chamfer. And we say, okay, that'd be like for a recess for a screw head. The problem is if you need to reference any part of the screw now of the hole, it makes it very difficult to try to grab something because you've altered the shape of it. So you're better off doing stuff, like pretty stuff later. Chamfers not so much, but the fillets are definitely something you end up doing later on when you're doing your design. So I'm hoping I haven't lost anybody yet on this. It's I think you understand it's pretty simple. And like I said, there's a million ways to build something. So if you wanted to have this little piece poking out, it could actually be a separate part you could build as a separate model, and then you could attach it to this one. So if this needs to change for some reason, so it's different links or whatever, you need to be looking at, then, or this has to slide in and out of here, it would have to be a separate part completely. But there's a million ways to do things. You just try to think about in the future as you're building your model, what do you not want to do that's wrong? And so let me close this out, and it's going to ask if I want to save it or not. And you save it to the cloud, and I'm going to say don't save. And we're going to actually make a usable part, and I need to find my actual parts here. Bear with me. SolidWorks. Okay, so what we're going to do, I'm going to have to share another screen, yet another screen. Okay, a new share, and we're going to share this screen. Okay, so if anybody knows what this is, raise your hand. This is the side of the handle on the Commodore SX64, and it's missing the cap. And so the cap is something that we're going to make today. So if you're not familiar with what the cap looks like, I will show you. Except I have to share this one too. Oh, the trials of Zoom. Okay, so this is an original cap off of an SX64. In fact, it's off the same machine off the other side. I just pulled it off because this one's missing the cap. And so this is what we're going to build today. This is a very simple project to build. Yeah, a couple complex things in it, which is neat. So this is the cap, and you can see on the left-hand side, the little tab that sticks out here. This is actually part of the release for the tree. So when something gets made in a mold, there's probably 8 or 10 or 12 of these, and they're actually stuck to a tree where the plastic's injected, and that snaps off. So that's actually the snap piece, and it wasn't cleaned very well from the factory. So let me flip this over, and again, it's gonna, I'm back to me real quick. Oh, well, I'm here. So this is the cap, and you can see this is a cap, the other side of it. But let me go back to the actual good picture of the cap. And so this is the back side of the cap. And it's hard to tell, but over here, there's like a little piece of plastic. It's actually it's a key. It's kind of squished. I'm not sure why it got squished from the factory, but this is a pretty simple part. Literally, the most creative thing I've seen for reproducing this is that somebody went and took a 1-gallon milk jug like we have in the United States, and the lid for the milk jug, especially the blue ones, they're the exact right size. And so if you trim it down with a belt sander or an X-Acto blade, don't cut your fingers off, it actually can be substituted for the SX64 cap. So if you don't want to do this little project, you can go raid your refrigerator later and steal the cap of it. And you'll need 2 gallons of milk to go through to get the cap. So this is the cap that we're going to do. And let me exit out of this. It's closed. Okay, we're back to me, which is good. And so I can pull up my reference for me. Okay, we're gonna go reshare Solidworks. If I can get. Okay, so we're back on the Solidworks thing. So I measured this all out in advance and made an idea of exactly what we're going to be doing. So I figured I was going to make a cartridge. So last year we did this hardware build project. And so this year I thought, it'd be great to make a cartridge. And so I started looking at how complex a cartridge actually is for doing like the ribbing and stuff. And I thought, yeah, let's do this first. And then I can talk about doing a cartridge after the fact. This is a lot easier project for people to do. So let's say we're going to start from the top view. It doesn't much really matter what plane you use because in the grand scheme of things, it's going to be rotated and put into an STL file, which will be rotated on your build plate of your printer anyway. If you know which plane this ends up being on your printer, and I can tell you it's going to be a top plane, then you can do that if you want to, but it doesn't really matter. You can rotate it in your slicer or whatever. So let's do on the top, and we're going to say sketch, and we're going to sketch the top. So the first thing we want to do is build a circle, because guess what? It's a circle. And so we're just going to do a circle. And then we're going to use our smart dimension. And in the SX64, the circle is exactly 30 millimeters. And so that's it. That's our whole entire cap right there. So again, if you click on the origin of the circle and you hold the shift and do origin of the origin itself, we'll make it coincident and it goes to the center. And like I said, if you're going to ever scale this ever up or down, you want to make sure that you put everything on the center plane, because it makes the scaling proportionally correct. Otherwise, you're going to run into some pretty obscure things that you have to fix later on. Okay, so that's our entire sketch. And so we select the sketch and we want to extrude this like we did the cube. And so you can see here's how you can do that. You can see it, here you can drag it however we want. So we measure this out with our micrometer, and this ends up being it's a 3.5 millimeter height. That's how tall it is. Now, so now we've got a disc, and we've got a small problem though, because this is recessed. And remember, we saw inside of it, it's got a lip around it. So this is back to one of those things where you need to think in advance of how you want to design this and what the best course of action might be. Because what you could do is you could, we'll actually name this to main, so we don't forget. We could go back to our sketch, actually back to our extrude, and we could make this 2.3 millimeters, or actually, well, actually, this is a neat thing. So we know that the inside plate thickness is 1.2 millimeters, and we know that the overall thickness is 3.5 millimeters. So SolidWorks has some nifty capability built into it. So if I know that I need 3.5 millimeters of height, but I want to only make this 1.2 millimeters, and what's going to be the difference? You can actually do add, subtract, and formulas over here if you want to. So I could say 3.5 minus 1.2, and so it's going to automatically make it 2.3. Or I can make this 1.2 to start with, which I probably should do right now, because I was going to show you this. Okay, so I made it 1.2, which is the thickness of the inside of the plate. So again, let me stop the share real quick, and I want to show you what I'm talking about here. So this plate is that thick this way. If I can get this to focus, there we go. So it's this thick, but the inside is actually, if I focus in the camera, you can see how thick the actual plate is itself inside. So the thickness of the border around this and the plate are identical. So let's go back to the share here. So there's two ways you could build this, and there's an easy way and a not as easy way. So you could build this as 1.2 millimeters thick, and then build up this perimeter around the whole thing for our the wall is on the outside. And so you're looking at this part, we know we've got a notch in here. So if we do a notch, we're going to have to actually build a partial perimeter, which means we're going to have to do some pretty complex things in order to do that, typically. But there's an easier, faster way of doing this. So let's do this actually 3.5 millimeters. And so we're back to the original thickness. So when we talked about the cube with the holes, we know that one of the things that we can do is that we can deliberately put another sketch inside of here if we want to, and we could cut out the center section. Unfortunately, that's going to cut a hole all the way through the thing. So that's not going to help us. So what we can do to make this easier for us, instead of having to build this perimeter wall, we'll do another sketch on top of this surface. So we're going to sketch on top of this surface, and we're going to do another circle, and we're going to start from the center origin. So you can pick where you want to start, which actually snaps to it, and then we're going to make another circle, and we will set this radius. Now, we don't know what the actual what we're trying to achieve here is this outside border wall is our little perimeter that stands up. And so we can either provide the measurement here, which is not something that's ideal, or we can do in the smart dimension, we can say from this edge to this edge is a distance. And we know from measuring with our micrometer that this one is 1.15 millimeters.
So now we have built a wall, and of course, it hasn't done anything yet. That's going to be 1.5 millimeters. So why did we do this? Well, instead of building this wall after the fact, now we can do an extrude cut, and you can see that it's going to cut onto this side. So this is where we know the handy dandy. We know that this thickness of this plate in the bottom is actually 1.2 millimeters instead of being 1.15. It's a little different. But we know the total height is 3.5 millimeters. So we could say 3.5 minus 1.2, because that's the thickness that we want to keep. And it automatically calculates that the cut depth is going to be 2.3. And we say, okay, and presto. So now we've built our entire perimeter wall easily without having to go and construct the wall on purpose and all that. So we also can do, we need to do a slot because there's a gap in here at the edge. Let me switch back to my regular camera here. So we'll go over that again. So you can see in the SX64, this little notch is here that actually is inserted into the indicator. So those three little dots you see, that's an indicator for the position of the lock for the handle. And so that little notch is required for this to slide in place. So we'll go back to share this. So we're going to want to make that notch. And we know it's a straight cut through notch. And we know that the notch is 9 millimeters wide because we measured it with our mic. So, well, how do we do that? Well, we're going to be working on cutting the surface down. And so the surface you need to cut down is this one, because that's the surface we have to cut down on. So again, it's a very simple process. You select your surface and you select sketch, and we're going to be drawing on that surface, not the center part here that we cut out, only what is actually highlighted you're going to be drawing on. And so we're going to do a rectangle, and I like to do these off-site because it makes it a whole lot easier. Again, we'll just do a little rectangle, and I'll do my center line because it makes it easy to grab. And we don't really need a X and Y center line here, but I'll put it in here anyway. And you can see SolidWorks actually highlights the center of each segment. So it's highlighted in yellow, and then I can draw it. And these snap to place, so when it gets close to it, it snaps, and also snaps to anything that's close on line you can select. So it makes it easy to manipulate. And you hit the escape key to stop the thing. So we want to make this 9 millimeters wide because that's going to be our notch width. And we don't really care what the height of this is, as long as it's something that's going to work. And it's just a nifty trick that I do a lot. So let's just make this 15 millimeters high. That's fine. So I'm going to take this, and what I need to do, we'll say exit. Exit sketch will give you an idea of how this works. And then I'll go back into the sketch real quick. So I grab this and I can move this around however I want. So what we want to do is that we're going to want to cut this section out here. That's 9 millimeters wide. So this whole section here is going to be gone. Since we know that this is already cut out here, we don't care what happens in here. So this thing can be over, lengthwise this way and this way. A lot of cases you can't do that. You're going to have to actually do the contour of this sketch here, which you can do. There's contouring capabilities in here. It's a lot more advanced features, but this is a quick, easy, simple, dirty way of doing it. And it works perfect for it. So we've got our sketch, and so how do we know where it's going to be? Well, if you drag this, and once you get used to working SolidWorks, you'll notice like this, there's a little yellow pixel that appears down here. So if I move this over close to it, it actually will start lighting up when you get close to it. So you can see there. And then when you get close, it actually snaps to it. We know that that's dead center of the circle. Like I said, you could also do a reference where this line is reference to the origin, and we can say it's on a coincident. So now that's dead center of the circle, and you're still going to have to drag this down so that what we're basically going to be doing is cutting out this little section right here. And I will show you how that's done here. It's pretty simple.
Okay, let me actually get out of here and I will show you this way. So our plan here is to extrude cut this down so it matches this floor. And so what we do is we select our sketch and we say extrude cut. And now you can see what it's going, where it highlights what we're going to do. If you want to cut only part way down, you can do that, and you're going to have basically a notch that's a section above here that's not cut all the way to the floor. So what I like to do again is over here in the direction, I like to say up to surface. This is my surface I want to cut to, and I say okay. And magically, we have our little slot in here. And this is, like I said, it's a lot easier to do it this way than it is to try to build this perimeter wall with this exact angle on the cut. You can do it, but it requires a lot more work to do it. It's a lot easier to say, okay, I just need to cut this part out. So we've got this built for our cap. And so we know based on our picture that there's a little stem over here. So again, we're going to be creating, we can either go from this point up. So we're going to build from the floor to the top of this, or we can build from this down to the floor. In our case here, it doesn't really matter, but there are some cases maybe in your design later on where you're going to have to go one way or the other. I try to build from the major floor to the minor. So this is going to be here. So I'm going to say we're going to sketch on here, and we know that it's going to be here. Again, we're going to build a little rectangle for our little tab, and we measure this with our micrometer, and we're going to go build a center line here to here. And then if you're a hotkey guy like me, I just do here to here. And like I said, it's not necessary that you actually build center lines, but it sure makes it easier to be able to drag things around. And so we need to dimension this. We measure with our mic, and this is 1.25 millimeters wide. And the peg sticks out 2.5 millimeters. Actually, yeah, that's where, okay. So that's what we built, is this little thing out, outer space out here. Now we need to put it over here. So we go back into our sketch and we can drag this. Again, we can like go over here until it snaps into place if we want to. You can see it actually goes snap, or up here, you can see it actually will snap in place and do it. I prefer really to use the this to do a coincident or a midpoint, whatever you're doing. And so we're running into a little issue here where we've got a curvature, and we know that this peg is 2.5 millimeters from the edge of the circle to the edge of the peg. So I made this 2.5 millimeters here. So you can either do this, so that's here and it sticks out, but that's not really good because you're going to have like extra material sticking here. So this is one of those times you need to think how you want to do this, because a curvature and a flat line, as you can see, you're going to have an overage here. So if you do an extrude now, well, let's do it real quick. I'll show you. So we place it here and we do an extrude. We can select the sketch first. We can say from the bottom, like I like to build up to the surface to here. And so we did it. We built our little pin. So we've got our peg in there. Small problem though, because we're building it on a circle. You can see the fact that because the circle transitions, it actually doesn't encompass the size here. So this has to slide forward. So what you're going to have to do in your design is figure out from the edge how far you need to come in, how far does this stick out. So you can actually do that in your extrusion part here when you actually edit this. You can say from here to here on your extrusion. For me, the easiest thing to do was to grab the part actually here in the sketch and move it to a different reference. And I'd say from, actually, we'll get rid of this dimension because we don't want to dimension it this way. All we know now is that from the face of this to the edge of our circle needs to be 2.5. And then we're back to the same problem again here. So we can't do that. So we're going to have to, we know that measuring our peg from the inside, that from here to here, I think I can get this to measure here. From here to this line here is going to be 1.5. And then so now we know this is going to stick out 1.5 from here. And there's other ways to do this. This is the quick, easy way of doing it. And so now you don't have the problem with the peg sticking out. And so that's our entire cap, right? I mean, literally, that's the whole cap. If you were to 3D print this right now, it would actually print and you could use it the way it is. But it's kind of ugly because we don't have nice fillet here and stuff. And so we want to put a fillet here. But we know, don't put your pretty stuff until the very end, because we need to make those little indent marks. And so if you take a look at the indent mark, where they go, and I will flip back to my regular camera here again. So they go on the notch side, and you can see them there. And they are not just a couple of circles. Basically, it's 2 circles and a rectangle. And so we need to reproduce that. So this is one of those things that we're doing a copy of something. And we'll go back to the SolidWorks sharing. And so how do we do that? Well, first of all, we need to make sure that it's done on the same side of this little notch, because putting them over here is going to be a problem. It's not going to be a good idea because the reference is for this here. So again, we're going to draw on this same surface. And we can see that if we tip this and look, that's the same side the notch is on. So we know that when we did our normal 2, which is when you do a sketch, so we're going to do all of our stuff up here. So we will first create, how about we do the circles first? So we know we've got to have 2 circles. So we know that their dimensions are 2 millimeters. And so you can either dimension this one and then dimension this one. But if you know you're going to have the same exact diameter of all your circles or all your squares or whatever line you're using, a nifty thing that SolidWorks lets you do is you can select the object, you can shift select the other object, and then there's neat little relationships you can add. And I can say equal. So anything that's defined from something that's not defined takes on its relationship. So I can say equal, and magically you can see that they're the same size now, which is great. Okay, so we also have got a rectangle that we've got to build. So let's go build a little rectangle here. And again, I'm going to use center lines because it's just good practice when you're starting out. Like this. Okay, so we know that with our micrometer, we measured this out, and this is a 2 millimeters by 2.5 millimeters. Okay, so we could just haphazardly place these up here and call it a day. That's our little symbols. And then what we'll do is we'll extrude cut those so they're recessed, and then basically that's it. That's not a very accurate way of doing things. So I took the liberty to figuring out exactly where all the stuff needs to go in advance for the video. And I know that we know this should be dead center. So we're going to add a coincident relationship. And we know that from the edge of this circle, to the center of this is 2.5 millimeters. And we know that these are a little more difficult to figure out because they are a reference to not only the center, if I can grab this thing, I can't grab it for whatever reason. We'll try again. We'll grab the, okay, there we go. So these can be placed anywhere. Now you can see when you get in line with the other circle that it actually draws a little virtual line for you. It's a snap grid line. So it shows you that this one's even with that, which is great, which is, it's a great thing. But we need to figure out the angle on this. Or if you don't care, if you just want to make it, you know, pretty close, then you can do that. I actually measured out everything on here. And so what I ended up doing was making some center lines from the center to the edge of the circle. And for each one of these. And the idea is that we're going to put the center of the hole in line with the edge here. And I actually need to do a center line too to make it easier to see. Okay, so ideally we want to have the distance between this line and the circle the same as this one, which is, you know, kind of critical. So we know from measuring with the mic that the center of the circle to the center line here is 3.5 millimeters. And this one is also 3.5 millimeters. And we also know that these circles are not connected together, but they need to be. And so we're going to say these have a relationship that is horizontal to each other. And if you want to get technical about where this actually goes, you can calculate the angle if you need to. Basically, that's what I ended up doing for the one that I built in advance. I knew that from here to here was the easiest way to figure this out was, let's see, by smart dimension, from here to the edge of the circle is 2.6 millimeters. And if you want to know the exact angle of that, you can actually snap this to here and it'll give you the angle. You really don't need these lines the way I did it because I measure everything out. So that's it. So these are placed in here, and that's what all we wanted to do is make these three little pieces in here. And so again, if we do an extrude cut on here, we can see how this is going to get cut. And obviously we don't want to cut clear through here. So if we take our mic and we use it as a pen gauge, we know that the depth on here was 0.25 was the depth, and presto. So now we have our little indicators that are in here, exact. So now it's time to make it pretty. So we simply select the edge and we do a fillet. And we go down here. There's no preview because the fillet's bigger than the part. So if we do a 0.5 millimeter fillet, that's it. So literally, this is the entire cap for the SX64 that we just made. And you can see it's a few steps doing this, but it's really not a lot going on. And we didn't name all these like we should have. So we can go back and do that really quick. So this is the let's say center cut. And this is the, let's call this a slot cut. And we'll call this the key, because this is a little key thing that we made for it. And the extrude cut is, we'll call these the indicators. Okay, so when we go back 10 years from now, trying to figure out what we were doing, we have an idea of at least what these were. So if I were to save this now as a file, I could save it as export as a SolidWorks file, export as different files. I could save to the 3D experience, which is a cloud, which you're going to be doing. But if I want to export this, which is what most people will end up doing, actually we got to save it as well. And so this is how it saves to the cloud. I'm going to call this SX64 end cap. You can also save to your PC locally on here as well, but the cloud is what makes it handy. So you can share with other people as well. So once this gets saved to your account, you can actually link it to other makers and they can use it and take it and pull it into whatever project they're using, and everybody can share everything together. Like I said, it's kind of like the GitHub of stuff. So here's the next dialog box that pops up is that you can save it as a particular part. So if you want to save it as a step file, which you would use for a solid model, you can do that. Most people are going to want to save it as an XTL for stereolithography, which is 3D printer stuff. So you go through here and you figure out where your STL part is, which is right here. And there's some options in here. You can set the number of triangles and such of how good it is. Basically, the defaults are fine. Make sure it's on millimeters for STL because that's what STLs are. And then so I can say, I'm going to save it to my temp directory, CRX 2021, Solidworks, and I'll save it to my SX64 cap, which I didn't have yet. I'm going to say SX64 cap, STL, and you can see the triangles that get generated by SolidWorks, and it says it look okay. Yeah, it looks good to me. And now I can take that STL file and I can share it, and anybody who has a 3D printer, they can print this, which is pretty nifty. So that in a nutshell is about how the SolidWorks actually, can develop a usable maker type of, product. You can do the same thing with a case. And I'll show you a couple of different things that I've done that some people have actually liked. So I'm a big pet nut. I started on a pet, and I love pets. So I had a pet in 1977 when they first came out. And so I decided to make the pet in SolidWorks. And let's see, that's the entire pet. I did it as a 100% scale, so I could reproduce a full-size case. And then I went back and I made another version by simply scaling it to 0.30%. And by doing that, this will fit a 2.2-inch TFT perfectly. And I actually have a pseudo working pet that is basically 1/3 scale. And it's something I've been playing with for a while now that I'd like to actually make as a product. So you can see this literally is the pet in all its glory. And SolidWorks lets you do things like this, where you can actually do pivots on an axis, and you can actually stop at a particular point. Like I can't go any further than this. If you turn and you can look inside, you can see the tape deck. So this is built as individual parts. And I kind of really quickly go over how that's done. You have what's called an assembly, and the assembly is the entire thing. So what you developed is called an assembly, and you can have sub-assemblies of assemblies as well. And so when I did something like the cassette deck, we'll go over to the cassette deck, and I can say, open this particular part. And so now it's going to open this particular part, and I can switch back anytime with the window. You can see your windows here. You can go back to the pet, and I can switch back to the cassette. And the cassette is made up of individual little components as well. So like the keycaps, wow, I got keycap on the brain. The keys here for play, record, all this. They're individual parts that I actually made in SolidWorks, much like I did the SX64 end cap just now. So those are individual parts, and they're all put together in the assembly, and they all have relationships to each other. And there's what's called mating, and it's a little more advanced, but you can actually put everything together this way. And so if you want to take a look at certain like assemblies, like let's look at this. So this is the upper part of the cassette deck, and you can look over here on this tree over here, and you can see that I was naughty and I didn't actually label all the stuff here because I don't do so much anymore like I used to. But if you take a look here, you can see like I actually put surface coating on this. So there's actually a texture. You can zoom in, you can see there's a texture on here. So I try to replicate the entire experience identical. And again, so I took my pet apart, literally everything, and I measured everything with a micrometer. So it's accurate to within probably a few thousandths of an inch. And then when you scale it down, it's even more accurate. The faceplate here, the nameplate, I actually scanned that off an original one, and SolidWorks lets you import any kind of a graphics data, and you can overlay it and it will insert it into your device or your drawing part. So literally you build this part and then you build the next part of your cassette deck, which would be the bottom. So we'll open the bottom of it, and the bottom is just pretty much, it's a shell. There's not much going on with this. There's still a texture that's on here as well. And so you can see all the holes that pass through and stuff. So it's not too exciting until you go and make an assembly. That's the wrong drawing. And you start putting things together. And so I'm not sure why the cassette deck lid doesn't open. It's supposed to. It actually opens in the 3D model. So you can lift this up. So you insert all these little pieces together and you mate them with relationship to each other. And so like when you do a two case halves, you're going to have one relationship of being the upper and lower half together surfaces. And another relationship might be the end piece. So you want to line up so they actually snap together in the mating process. And then once you do that, you can drag the whole thing together as one unit. So
hey, Jim.
Yeah.
Hey, it's Jim Happel. I'm jumping in here.
Yeah, go for it. Yeah, go for it.
Hey, I had a question. This is an awesome overview of the system. When you do the design of the multiple parts and you have them referenced together, is there a way to reference one part to the next parametrically so that if you change a mounting hole on one part, it will move on the other part?
Yeah, absolutely. So the mating process over here, you have your mates. And so actually, let's go pull up something. Let's see what's that would do that. The keys, I guess. So let's go take a look at the tape deck.
Yeah, and you probably know the reason I'm asking. I've been playing around with FreeCAD, which is great. It's completely free and it works, and you can do 3D models in it. But the whole paradigm of parts and assemblies is just bizarre.
Right. And so if you change a size of something, then there's going to be a problem with, like, let's say you change your keycat or your key size here. If it got too big for your case, it's not going to stretch your case out. It'll go over top of it. So it won't fix that kind of a problem. But if you reference the side of this key to the side of this, let's see what, let me blow this up a little more. So if you reference the size of the key to like the edge of this, and you decided to move this over 2 feet, the key will go with it.
Right.
Yeah. So,
and that can be really powerful in your design if you're tweaking mounting locations. Yeah.
It's a necessity.
If you move it too far, it might blow up your whole model, but that's acceptable.
That's true. I mean, you can see these are all the mate tree. So on the mate, you can mate by a distance. So like I did here, let's actually edit this mate, and you can edit everything, which is brilliant with this. So I said the distance is going to be 0.060. This is actually in US. So if I want to say as a reference, like I can change the mate, you can see it's moving.
Right.
And so that's great. But if I move this other part and like this direction, then those keys would move with that part. And the only time that changes is if you were to actually lock it. There's a lock function to prevent you from whatever else is attached to it in the mates from moving your item. But if it's unlocked, at that point, anything can affect anything. So sometimes you have to lock a part because you're like, oh, wait a minute, I don't want that to move, So at that point you say, oh, okay, that's got to stay here permanently. So for example, like in this case here, this is not going to change in width. I mean, Commodore's not going to magically start producing new cases that are wider, so that's going to stay the same. But you might want to make these keys a little bit different or something and reference. So you may have to, like if you made the key half the size, let's say you wanted to add an extra key for some reason. So your referencing point is going to be the same from here to here. You're just going to insert a new key at that point. So yeah, you're right. The mating thing is it's critical. You got to have the reference. And like I said, you can reference, let's go back to here to your mates. You can reference a distance, concentric. So if you're going to, this is really critical for like screw holes. And I really wanted to do, I'm out of time basically, but I wanted to talk about referencing screw holes, because let's say you've got something like circuit boards you made in KiCad. And actually, let's quickly pull this up. I'll say, no, don't make any changes. Actually, cancel. I'll just load the anyway as a separate item. Okay, here's a good example of what we're talking about. You'll need my Y modem. Okay. So this is an enclosure making for a new product called a Y modem 2. And I did the circuit board in KiCad. And KiCad is really nice. It's an open source, but it lets you generate a actual circuit board. And so as soon as SolidWorks gets done loading, because this is megs of data, I can take the board file and I can open this. And so this is what actually is generated by KiCad. So for this product that I was playing with. And so if you've got a hole here for your mounting holes and you're set in stone on your board here, then those are going to be something that's going to be locked. And then when you go back to here, you can use those holes as a reference in your case when you're putting in for your holes that are drilled in for your screws and the screws themselves. And so like you can see, I can actually spin this screw around because I don't have it referenced to lock in one place, but I do have it referenced to be in this hole at this particular point. Now, if I change the circuit board to make the hole over here, it's going to magically change everything for me, which is brilliant about SolidWorks. You don't have to go back and redo the hole where it's placed or redo the fillet or any of that stuff because they're all referenced together. And so, like I said, if you lock something like your circuit board to something and then everything else can be open, it'll move around if you need to change it. So if like in this board, like, oh crap, you know, I need to add another chip here. So I got to make the board longer. I don't have to redo a whole case. Literally, I just put the new board in place and I change the reference point maybe for one, and it fixes everything else for you automatically. So
yeah, this can be very powerful when you're making minor tweaks and moving things around. Because
absolutely, because that's what you do mostly. You make minor tweaks at the end.
Right, and it's so easy to like modify a mounting location on the bottom housing and forget to update the top housing or something like that if they're not referenced together like that.
Right. So for example, like you're saying here, like if you have upper and lower case, if you want to actually, we'll do a open parts. So like what Jim was just talking about here, if you do these together, like on the other side, you see these are separate pieces, but ideally your circuit board is going to be referenced, or your case halves are going to be referenced to your circuit board. So this one on the bottom side and that one on the top side will be referenced together. And when you do your mating for your case, this surface here would be mated to the top surface, and you might use this edge, or you might even use the holes really, but usually it's edge to edge, and then this edge to edge to edge, and then that references everything together so they stay in place together. And if you need to make a change to a screw hole or whatever, it just magically fixes itself. Now, this also holds true for like the pet that I did. If you build everything on the center origin, when you use the scale function, it'll scale everything proportionally together and keep all of your mates and everything else. And if you build it off center of the origin, it'll actually build whatever part that you build off center all skewed, and it's a mess. So you want to remember to keep it on the origin. So you got any other questions, Jim? Since you chimed in, that's great. I appreciate that.
Yeah, so on this pet, I mean, this is a pretty intense model you have here with a lot of subparts and sub-assemblies and full assemblies. It seems like you have no problem with speed. I know you got a beefy computer here, but...
Well, here's the funny thing. So this computer, as everyone knows in my little clan here, likes to crash on its own. And so its end of life cycle is near. I built this computer in 2012. So it's 2012 fast back then. It's not fast by today's standard at all. So yeah, you don't need much in the way of horsepower to actually run this. If you run high resolution, that's where the big difference is. Like that's when you get your great detail, like you saw the texture here and stuff.
Right.
That's when you start really slowing down. But it uses the different types of video cards, with the GPU. So that's really kind of where you need your speed to be, is on your GPU, your card, your video card. And that's really it. It doesn't need any kind of real CPU horsepower to do this up, because it's kind of stationary most of the time, just sitting here.
I did a lot of pro engineer work back in the day, and I remember having a model at work. It took me 15 minutes to open the model.
Oh yeah, I mean, I know. Don't get me wrong. SolidWorks can take a long time to open certain models. Like, I think this is probably the most elaborate thing that I've done. Most little individual pieces. No, actually, the key. Yeah, because each one of these keycaps is individual. It's not like done with a little magic of like trying to recess it. No, these are actual individual keycaps, and they're placed into this little piece here. And so you'll see, like, look, here's all the keycaps in the tree. There's all of them in here. So the nice thing about this is, so you make one keycap and you simply copy and paste it in, 60 times or whatever the heck this is, but 76 times into here. And then again, you reference this. And so a good example, you're talking about, Jim, when I did this, the border, the frame that it sits in originally, let me open up the lid so I can pull this part out. So this is a neat thing with SolidWorks too. You just grab your part and you can say open the part. So it'll actually open the part separately. So when I built this little chassis here, you can see it's a recessed tray, and all the keycaps fit in it. I built this wrong to start with. And so when I measured it out again on another pet that I had, actually, they can see, it's hard to see in black. By the way, don't colorize everything till you're all done, by the way. So you can see that this is the frame that it was in. This was actually wrong. And so I noticed that when I went to go put the keys over here, it was too short. But I had already referenced all the keys over here. I'm like, so luckily I was able to, just simply say, okay, then redo all these keys automatically here with the distance being the same. So it really helped me. And when you do things like the small tweaking at the very end, like you're talking about.
Right. Yeah,
So,
you were saying earlier, it was like 100 ways to do things, right?
Oh, yeah. I mean, literally,
when you were dimensioning that notch that you were putting in the SX cap,
yeah,
I was like, I totally wanted you to do it one way, and you ended up doing it another way, which is just as elegant. But I was like, oh, do it this way.
Right. So, I mean, there's like a lot of ways to do that notch. I mean, I could have done the notch before I actually did the recess too.
Sure.
Or you could have done the notch as you built the perimeter.
And the other thing that I love that I saw today is how you can do the math in the dimension boxes.
Oh, okay. So I didn't tell you something else you can do. You can also set global variables. So when you do a dimension, you can say let's say keycap equals 5. And that's going to be a reference for the word keycaps. You can say, when you go to dimension something, like let's say you're going to do in this little tray here, I'm going to reference here to here. And so the distance pops up and I say keycap, and that automatically inserts 5 millimeters in there. And you can also use that in a formula. You can say like 7.3 minus keycap.
Right, that's cool.
Yeah, and so you can do globals this way. And you can do literally like math, like high-speed math, complex math, multiply, divides, all that stuff. And I do that quite a bit, actually. I'll do like half dimensioning things. So let's say I'm going from one side to the other and I want to know what the center is, but I know it's like 35 millimeters from one side to the other. I'll say 35 divided by 2 plus 3.7, and it'll put it exactly where I want it to go.
And right. So and you don't have to think it through, right? You
right.
Just
No calculator
with
required.
The design process. You don't get sidetracked to calculating these numbers.
Right. And it's something that makes it very, very easy. It really reduces the amount of time that you're away from the model, where you have to go and pull up a calculator, or even like I do miking of things. I try to write down, your dimensions. I kind of make a little sketch on a notepad of what my dimensions are from, like this, from edge to edge. And then things like, the measuring part of this is pretty nifty too, where you can actually say from here to here is equal to this distance. So I know it's 2.7862 inches from this edge to this edge here. And so it's very accurate. And then you can do a little more advanced things like, let's go into, where am I at? My tools, wrong menu. Under, where the heck is it? Options. Oh, evaluate. There it is. Say maybe they don't have it. They do on the maker version too. So you can do things like interference detection. So after you build all your model and all your pieces, if you click on interference detection, it tells you where anything intersects where it shouldn't be. So this is handy, and I use this quite a bit actually. For example, those screw hole references. If you don't reference it to like a screw hole directly where it moves, and you moved your screw and you don't realize you did, I do the interference, and it shows you exactly in red what's interfering. So I had like screws that were off center. And I could have printed it that way and not known until after I was done. It's like, oh, crap. And so if you do the interference detection, it shows you, and it shows you exactly how much interference there is. So if you've got like surfaces that need to touch, like for like a seal for something where you know it's going to touch, it's okay. You can actually exclude those from the interference. It'll show you at first, and you can click on them to do exclude. That way they don't appear in your model as a problem again. So that's really handy. Again, they spent a lot of time trying to focus people on being productive as opposed to being outside of the model. And that's one thing I really like about the software. And I would imagine that Fusion 360 has a lot of this capability as well. But for me, this is way more intuitive. If you got, a top and a right side and a front side, anybody that comes from the old school 2D drawing, like I know you have, back in the day, it makes it much easier to understand, I think, when you extrapolate that into a 3D world.
Oh, I was muted. Sorry. Yeah, way back in the day, it was funny. The 2D CAD system that I used is now owned by Dassault.
Oh,
CAD.
yeah. So I've actually run over my time, which is okay because we're actually in lunch right now, which is fine. Right. Let's see, what else did I have in here that I wanted to show? Oh, so this is an actual product too. That I did, that Jim knows about. It's been tinkering with for some times. Open without this document. Oh, I'm missing something out of here. Okay. Oh, okay, open without, don't show me again. Oh, I guess I can't do it this way. I must have something. So that's one thing about SolidWorks, a little bit irritating, is that I've got all these different windows here. And if I've got anything with the same name, it has a fit about trying to use the same model. So if I could close all this up, I can reopen it. But I developed a little enclosure in it for a handheld little chip tester. So I use it for this. So if you're going to build something, Jim, what would you use it for? I mean, you could use it for like a cartridge case, and there's a lot of things in the Commodore realm we could actually make very simple models for. What do you think?
Yeah. I mean, I made a one-off modem case, remember, and 3D printed it. And I did it in FreeCAD, and I struggled with the mating of the two halves and getting that to work correctly. And I think there's an assembly workbench that somebody created secondarily that you can download and install, but I was just trying to use the tool right off the shelf.
Yeah, one thing about this is nice is you can do transparency, so like I can look through the case, and otherwise, it's not transparent, which this makes it handy too for looking at your circuit board for references. And like I was saying, that interference thing is amazing because you can also see if it interferes. Like here's the edge of the circuit board that's in here. Is that going to be touching the inside of the case? And so if you accidentally have the case hitting it, it shows you in the interference warning. And so you go, oh, I need to move the case over, or I need to move the board, either way, or cut the board edge off. And so a lot of times I base most everything I do around the actual hardware because it's a lot easier to change the outside than it is the inside. But I also try to build this to make sure that everything is referenced to it. So like I said, for example, actually when I did this particular board, I changed the switch to be a bigger switch. And so I had to move the circuit board over in order to be able to have this connector come out the proper depth. And so when I did that, the case fixed itself, which was great. I didn't have to do anything at all.
That's awesome.
Yeah, it's way awesome. It makes your life a lot easier that way. So referencing everything to everything, locking pieces that need to be locked. And that's really about the whole the gamut of doing the mating part. It's pretty simple, but I mean the quality you get out of this thing is amazing, and the fact that you can do texturing and stuff like that in real time, and it's an amazing product for sure. And for the maker realm, it's going to be something that's going to be really handy for doing like little cases and little projects that people want to do.
And for so many years, businesses were deciding between Pro Engineer and Solidworks, and Solidworks was always right there and being developed for years. So it's not like a brand new product. It's been developed over
long time,
probably decades. I'm not sure exactly. So that is a full-on high-class system. And
it is.
It is amazing that you can get it for $10 a month or $100 a year.
Yeah, absolutely. Stunning. So while we're here real quick, before I run out too much out of time, I want to share a screen real quick. I'm going to share this and that. Okay. So this is KiCad, and this is the circuit board that I did for that Y modem you saw. And KiCad has a 3D model output, and it's actually in real time. I can figure out where it went to. There it is. There. So this is what KiCad actually outputs, and then you can actually spin this around and look at it from different angles and stuff. And then you export this as a step file, and it keeps all the colors and everything else, and you import that step file into SolidWorks. And this is what I use as the main part of the tree. So you can actually have every single one of your parts that you build or subassemblies that you build either fixed or floating. And so I would import this part here and I would make it fixed. I'd make everything else floating at that point, because at that point, that stuff can move around. And so when your mating changes, that stuff moves around. You don't have to worry about it. But this is open source. This is KiCad. So you develop your circuit board, and then you export this as a step file. They import it into SolidWorks, and then you can just start working on your enclosure for it. So if you guys have got Arduino projects that you want to do something with, or you want to make the little brackets for the 64C to hold the keyboard in place, or basically a plethora of whatever kind of projects, you see a lot of stuff on Thingiverse and the other sites you can download those files. But I know a lot of people are like, gosh, I wish it would do this, or wish it had this. Well, now you have the opportunity as a maker, not as a commercial entity, because you got to use the full version for that. But as a maker, you can use this. And honestly, I mean, you saw everything today. I don't use anything any different in day-to-day work than that anyway. So it's full, full pawn, powerful. It's not restricted. And the neat thing about this too, Jim, is that it will actually, integrate with other makers. So the sharing capability now between people is going to be huge. And like I said, this released this version, I don't know, maybe a month ago, maybe a month and a half ago, something like that. They became available, and it's now becoming very, very popular among the makers, and everybody's starting to share all the designs. So it's pretty cool. So
cool.
Yeah. So that's my presentation. I ran over, which is okay. Our auctions are all ending or have ended, and so I'll have to check that out. Our schedule shows that we are going to be doing a presentation from Saj at 1 p.m. I believe. I need to look at our schedule. Yep, 1 p.m. today. And then after that presentation, Joeri, the builder, King Joeri, as he's known around here, will be building the ICS64S motherboard. And that is a replacement motherboard for the Commodore 64 with a ton of features. And I know because I'm the guy who designed it. So he's gonna be building that. So, hey, thanks, Jim, for popping in and asking questions. That was great. I appreciate that. And
Sure.
I guess we're going to take off, and we're going to Slay Radio for a bit, and we'll be back in probably 10 minutes or so, and we'll be back. So we'll see you in just a bit. right, we're back. Saj, are you there?
What's up, man? How's it
What's
going?
up? Oh, you know, same old, same old.
Day 3.
Day 3. We made it through, man.
We made it through, man. That's awesome. Just like last year.
Yeah, for real. So you're going to do a special presentation. Go ahead and talk about that.
Yeah. So unfortunately, our president from our Commodore Club in Vegas, we're called 5Cs. It's Clark County Commodore Computer Club. And man, that club's been running since the 80s. And from what Forrest told me years ago when I joined the club was there were like thousands of members. I mean, it was huge. I wish I was living in the States, like to experience those days, and there's no photos or videos of any of those meetings I had back in the day. I think in most of these meetings and clubs, there's not much footage, man. So I wish I could have seen, I have seen videos and footage on YouTube of like demo scene parties from the 80s. And yeah, those are massive as well. And so anyways, yeah, so when I moved to Vegas, I found out about I went to a Classic Gaming Expo, and I went into one of the ballrooms and I saw a booth with Commodore computers, and I'm like, oh, this is cool. I really didn't know that Commodore was still, because I was out of the whole retro computer scene for a while. I was DJing for many years. And then I went to that show. I'm like, wow, Commodore stuff. I haven't seen that in so long. And I still had my computers, but it was kind of boxed up. And I saw Forrest there. There was a couple other people, and I picked up a flyer, and I was like, "Oh my God, there's a group here in Las Vegas that meets up every month. I got to check this out." So I went to the group with a local friend, Keith. He's one of our members, and we went there, and I was like, "Oh wow, this is interesting." But I think we were the youngest ones there to join the meeting. Everybody else was like, you could tell they've been there for many years. And so we went in there and we kind of like added new ideas to the group and kind of made it, we started doing activities and we started moving to different locations. And yeah, the group really flourished, and we started building it, and it got really big. And then over the years, we started the CRX thing, and we combined all the forces and kind of put the whole thing together, which was really fun. So, but unfortunately in 2019, Forrest passed away. And so they were having, because of COVID, his wife, Ellen, was going to have like a celebration of life for him. But COVID hit, so, none of us could go to that. But then she had it she just had it in this summer. But that was the time I was relocating. So I felt bad I couldn't be there for it. So I told her, let me make a slideshow, I'll put a slideshow together of Forrest and what he did for the group and all that stuff. But so I started working on it, and I got so into it, it ended up being like a 23-minute mini documentary.
Hey, there's nothing wrong with that.
Yeah. So what I did was, because I was the one that was always shooting photos at the groups, taking video at our meetings. So I'm like, you know what? I always wanted to put together a video about what we did at 5Cs, but I just never got around to a project. And I'm like, this is a perfect time to put together what we created and to show the legacy of Forrest through the video of the vibe that he brought in. And he was a huge Commodore collector. He had an impressive collection. And on the video, you'll see scenes of CRX where he kind of showcases his collection. And there's some slides of his computer room at the house. Everything's laid out really nicely. You could see a lot of Amiga. I think he was more of an Amiga guy. He loved Commodore 64, but he was more of an Amiga gamer. He always talked about more Amiga stuff all the time.
Yeah.
And but he liked all machines, every micro, even all the way up to the old Pong machines. So yeah.
Do you know the history of how he met his wife? I mean, did he share that with you? Because he shared a little bit with me about it. I didn't know
tell us.
I mean, what I had gotten from it is back in the day with the Commodore 64, there was a online service called Q-Link, and that's how they actually met.
Oh
It's
yeah,
through
yeah,
Q-
I have
through
heard.
Q-Link.
Yeah, tell the story. This is pretty good.
So that's all Forrest had told me. It's like, yeah, they had
Yeah.
met through Q-Link, and they ended up, conversing quite a bit, and meeting finally, and dating, and getting married. So it's one of those. You want to talk about the first online dating thing?
Yeah, yeah.
That's really is. That's it. So I was
Yeah,
touched by that.
Q-Link was kind of like the CompuServe, right, of the 80s, kind of.
Well, for Commodore, yeah, it
Yeah.
was Commodore specific. I mean, you booted up on a Commodore 64 and you ran it, and so they spent a lot of time in the chat rooms, and that was the first online dating. Really, was that, and
Wow.
wasn't really designed for that per se, but it was used quite a bit for that. I actually know another lady, a good friend of mine back in the day. Her name is Sue, and same thing. She met the guy that she ended up being with through Q-Link. So
Wow.
it happened more than once. And obviously it happens now all the time with all the different
Yeah,
apps and
yeah.
stuff people give and such. So that was something that that Forrest shared with me, and I thought that was neat.
Yeah,
It's one
that's
of
a
those,
great story.
yeah, special moments for sure back in Commodore history for him.
That's a
And
true
so
8-bit connection right there.
absolutely. I mean, so his wife couldn't help but like the stuff because
Yeah.
that she was already on it doing it. So it was neat.
That's
So I was
cool.
happy.
That's really
So
cool.
what other stories about that Forrest can you share? I mean,
Well, I tell some of the story. There was like
Okay.
a really funny story. I tell it in the video. So
gotcha. Okay.
and you know about it. You probably don't remember, but we could talk a little bit about it if you want after the video.
Okay. Yeah, let's do that. So do you want to roll the
I know
video?
you
then?
were involved in that discussion.
Oh, okay.
We'll see. You'll see.
All right.
All right. Let's watch
So
it.
we'll roll it.
My name is Forrest Nettles, and I'm president of 5Cs, also known as the Clark County Commodore Computer Club. We promote Commodore and Amiga. We educate the public in any way we can. We're preparing for our first summer show, which will be at the Alexis Park, called the Commodore Retro Expo. And we just enjoy our machines and hardware and software and want to share our information with each other to learn and become more knowledgeable.
We have a lot of fun. We show off old machines, show that the technology is not as outdated as people tend to think it is, and it's fun get together.
A Gamer's Paradise and 5Cs have teamed up for a Commodore gaming tournament. 9 gamers will play 3 hot games on the Commodore 64. There will be 3 competitions, 3 teams of 3, and 3 lucky winners. Who will win? Will it be you? This will be taking place on Saturday, August 13th, 2016, at 12 noon. Location is at A Gamer's Paradise, 1550 East Tropicana, Las Vegas. Next to Pinball Hall of Fame. Join the Gamers Paradise community in welcoming 5Cs. Prizes include a Diamond Toys Classic Star Trek tricorder, a Funko Game of Thrones collectible 6-inch Jamie Lannister statue, and a $25 Gamers Paradise gift certificate. The competition will be the following 3 games: Demon Attack, Montezuma's Revenge, and R-Type.
Game on, and good luck. Commodore 64 rules.
Yes, game on. And good luck. And the Commodore 64 does rule.
down, go down.
Hey.
Hey. So
Yeah.
that's quite the production.
Yeah. So yeah, I just wanted to showcase and show like how important it is to have a community in your local town with the passions of the hobbies that you enjoy the most. And I didn't even know these clubs existed anymore. So when I joined the club, I was like amazed how cool it was to have other people in all age groups, still using these computers again.
Yeah, actually, I belong to the club by proxy. Forrest actually sent me. You guys had DVDs, or actually with CDs.
Oh yeah, yeah.
And so I still have all of the stuff that Forrest sent me.
Oh wow, yeah. He used to do the newsletter on the DVD.
Yep. So I've got all of the ones that he sent me, and little notes like Happy Thanksgiving.
Oh yeah, that's awesome.
And Merry Christmas. So
That's
yeah, he was
cool.
always thinking about people for sure.
Yeah, he even did raffle prizes, and he mailed them to people out of state all the time. It was like a big thing for him.
Yeah.
And yeah, so it was just awesome, all the activities we were doing, and then just wanted to bring it all together. And then that story I told you about that you got involved in, it was the cat coalition of Clark County.
I forgot about that.
When he found out, it's funny because he's always on eBay like sniping stuff.
Yeah.
And he emailed me one day, and he's like, he was all stressed out. He's like, oh my God, we just changed our our logo to C5, and there's another local organization here with the same logo, or similar symbol, right?
Yeah.
Except theirs had a cat with a long tail across it, and I was like, oh my God, this is hilarious. I got to tease Forrest about this. Because he's a big cat lover. He's got cats at home.
Yeah.
So, and then I remember you chimed in, because you know a lot about copyright and all that stuff. And I think Forrest wanted to copyright it. He was all stressed out about it. We're like, dude, don't worry about it. It's just a Commodore Club. Like, we don't have to like copyright anything.
So can we trademark the name? It's like, well, we can, but I mean, it's like, it's not going to do much good, because I doubt that the cat people are going to be upset about, I remember he emailed me. He's like, what can we do?
Yeah, exactly. Yeah, I remember that. He reached out to you.
Yeah. It's like, well, I mean, here's what you could do, but,
So that was I thought was that still was really funny. So I thought I'd put it in there.
But you know what? That just really is a testament to how passionate he was about the whole thing. He's
exactly.
He wanted to really, protect the club and.
Exactly.
Yeah.
And yeah, the newsletters. Because when I joined, I think he was still doing them on floppy diskettes. The 5
I have floppies from Forrest.
Yeah, I was getting the floppies, and
besides
then he moved,
having the CDs.
The CDs came like in 2016, I think. The second year I was with the group, and then he moved on, and then we just I don't think we had it anymore, because I think the planning for CRX and our clubs got more intense.
Right.
So he didn't have enough time to do the newsletter like he did before. So we kind of shifted more towards those activities. But yeah, I kind of also added that event that he had an idea of having a gaming competition, which I thought was a great idea. But we didn't know the demographics of Vegas. Like, okay, do these young kids, local kids, even know anything about these machines?
Right.
And we realized that if it's not a console, they don't really care. I think the furthest they'll go back is maybe Atari 2600, because it's a cartridge console.
Cartridge based, sure.
But I don't think they really care much about disk drive, microcomputers, any of that stuff. I think they just jump straight to Nintendo after the Atari. Maybe Coleco and Odyssey, maybe a little bit. I know the Atari is very popular. But yeah, we realized after that event that it's going to be really hard to get young generation to get into the Commodore stuff.
Yeah.
I think the whole thing of turning it on, and it's a basic screen, and they're like, okay, so how do you play games?
Where do I select the game?
Yeah, it's just too much work, And then the joysticks, they can't handle the old joysticks. They're like, what it, my
isn't it funny? Yeah, it's totally different. The controllers are totally different.
The controllers are different. And I'm not used to the new controllers, so I have a difficulty with the new ones.
Right.
So yeah, it's interesting, the generation gap between the technologies.
Definitely. And, but at the same time, CRX, we had children there.
Yeah,
The guy
yeah,
that
we
brought
did.
his son with the VIC 20.
Yep,
He
yep,
always came to the CRX. So I mean, we did have younger people coming,
yeah,
and so we made an attempt at least to try to bring in the younger crowd.
yeah, yeah.
But it's it's difficult to do that.
Yeah, and then I think we were also growing at the same time, right? We had a Lexus Park. Lexus Park was the first location. I think it was across the Hard Rock at the time, and then we moved to the Plaza Hotel, which we had. I worked there at the time, so we had access to like bigger spaces and stuff, and we had more freedom, right? Remember how Lexus was so strict with us?
Oh man, yeah.
Everything was nickel and dime there,
Oh,
right?
it
What
was
was
horrible.
it like a
And
water? How much was water?
yeah, internet, everything, I mean, everything. Which is it's pretty typical for convention center, but not so much for Las Vegas in general. Well,
Yeah,
we got we got all the perks at the plaza for sure. I
yeah.
mean, you were responsible for a lot of that, and then the staff there was great. So
I loved how we were able to stay there until we like passed out, really, because there
right, well, that
really
was the
no
whole premise of CRX is that
right.
the last person locks the door.
Yeah,
You better be up at 8 o'clock because that's when the first person is coming in.
exactly.
Yeah,
Yeah,
it
I
was a lot
love
of
that.
fun. PJ nights, and in
Yeah,
fact, David Yob mentioned last night he's got his PJs on, and he was watching the stream. So, so
yeah, and
it's
then so one thing I learned about Forrest after Hank, because in some photos you could see me like we went to a restaurant, and at the last photo that you see of me and him, it was at a car show.
right.
That was literally, I think, 1 week before he passed away.
Oh,
And I almost didn't go to that show because I think I had to go to work, but I told him I could probably show up to work like 2 hours late and I'll go with you. So it was me, Cindy, and Forrest that went. And oh my God, he was in his zone, like his world. I didn't know he was such a huge car
car
collector.
buff, yeah, for sure.
Yeah, because he had like a Thunderbird, like a beautiful Thunderbird. I don't know what year it was, but it was like a vintage car.
Yep, it was vintage. Yeah,
And it was beautiful. And I didn't know much history about him and cars. And I'm like, oh, okay, I see where you get your collection hobbies from.
sure.
Because he's into cars, he's into computers. Okay, so I started to understand more like his hobbies and things like that.
Yeah,
And but he wasn't just the kind of guy that just bought something. He liked to trick it out. Like he would get it modified. He would send stuff to Poland, or he would buy stuff from Poland, have it shipped over, because they do a lot of modification stuff over there.
yeah,
And yeah, he because that comes from like the car world, like tricking out your car, right?
sure.
Modifying stuff. So
I mean, you could tell. You look at like Forrest's setup they had for CRX. It wasn't just like here's a 64 and here's a Amiga. If you take a look at the video again, you can see that he has a sign for every single item on the table, the full length of the whole table,
yeah,
with the description of what it was. I mean, everything was just top-notch professional. We had it laid
yeah,
out.
he had the casings around the objects like a
Yeah.
museum would, with
exactly. It
lasers
was
and everything.
museum quality stuff. Yeah.
I mean, it was great. He even had that Signosis poster that was signed. Like
Yep.
I was like, wow, that's just so cool.
Yeah.
And I mean, that's a true Amiga buff right there, Signosis. I mean, that's like the elite, one of the elite software
Yep.
companies at the time. And yeah, there was photos of his room, and you can see all the box software. He had it all organized. And yeah, he was just really into it. That one year, 2016 CRX, we had the Las Vegas Review Journal do a segment on our 5Cs group, and they came to CRX.
Yep.
And they did, and we were written up in 2 editions of the local newspaper there. And that was exciting because like we were, in Las Vegas, we were on a newspaper talking about computers from the 80s. Like, that's just
Right.
cool enough right there to get those props. So
Yeah, it's interesting. So the girl that came from that, she ended up, because I contacted her again the next year. She ended up, because of all of her journalism skills, working for some big outfit in Los Angeles for like, I don't know, it was like LA Times or something like that, because of how her writing skills were. And so we were fortunate to have that kind of a person to do the write-up. And so that's, it was great to get the kind of publicity for it. Very surprising that, a computer club would get that kind of a press, but it was great for everybody.
yeah, I mean, so many people come through that town, Vegas, for entertainment. And to even have a retro show there is kind of interesting, right? Because that's
Right.
usually not a common thing people go to Vegas for.
So people that are watching right now, this events that Forrest attend, which is the CRX event live, you can kind of see what, Forrest had probably 5-6 tables, 8-foot tables.
Yeah, he had one of the
full.
biggest.
Yeah. And so that whole room is, I think it's like 7,800 square feet for the front part, and there was some more square feet for the back part. It's a big facility.
Yeah.
And so we could fill that up. And you notice Chris's monitor
the
collection was
miles
in there.
and miles of monitors.
Miles of monitors, which I thought was great.
Now he brought a big truck to bring all that stuff that year. I was
but
like,
wow.
wow.
Forrest too. I remember helping Forrest load stuff in and out of the loading dock, especially like at Alexis Park. That was a nightmare. Forrest had a lot of stuff too.
Yeah, he had a lot of stuff, and
very passionate about it.
Well, what was great about me working at a plaza, I was able to transport stuff a week before, and just leave it there, and then I could help other people, when they get there, and then I could set myself later because I could be there all night setting my stuff up.
Right. Yeah.
So that helped a lot. But yeah, his collection started growing and growing, and the eBay bill got bigger and bigger. And I know Ellen knows what I'm talking about. I think Ellen started restricting Forrest with maybe an allowance. I don't know if that's true, but maybe. I think she did mention that one time that
maybe
they can only spend a certain amount of money on. And I think he spent it all, like all of it. Like every month he spent all of that amount.
Like every month on the first, it was gone.
I remember Ellen saying, every other day there was shipments coming in. I was like, oh, that's Forrest. All right. And then what was exciting was every time we had a meeting, there was an excitement of something new coming in to showcase, like a show and tell thing.
Right.
And that was awesome. That was great because he always had something new to show us all the time. So
I remember that I went to a couple of meetings. I went to the one at the place next to the pinball machine museum. So
okay, yeah, that's when we had it.
And I remember there was
our first location.
Show and tell for things that were done there. That was cool. That was a great group of people for sure. So yeah, it's a sad state for that, but
well, now the memory will live on in that video.
For sure, it's good.
And I hope people watch it and see how important it is to have a local community of Commodore clubs in your community. And it's almost like having our CRX is our, once a year event, but we do meet every Friday. So it's kind of like our own club, right? We meet on Discord every Friday. We meet up.
Yeah.
And I'm sure there's other cities in Europe. I'm sure they do it as well, but it's really important to have that, that bond.
Well, especially right now, since the lockdowns occurred, for the last year and a half now.
Oh yeah, that helped all of us a lot when we were meeting.
The mental aspect of it.
Mm-hmm.
When you can't reach out and shake hands with somebody, so it's been helpful for everybody.
Oh yeah, I think we looked forward to it. And I think we started Fridays, and then we'd go, okay, let's do Saturdays too.
Right. Yeah. I think we're a little carried away sometimes.
Yeah, but we could have done 5 days a week, but we had to
gotta throttle it back a little
boundaries. Bit. Our rest of our loved ones are like, okay, you can't have the whole week.
Right. Well, that's very true. So
we probably would if we could,
We probably could. So my wife is like, I'm like, oh, I gotta go do this. Oh, that's right. You're with the boys tonight.
Yeah.
She always calls our group
that's
the boys.
Right. It's boys night.
Tonight. It's like, yep. So I guess we don't get too much trouble, being virtual and do anything. But
it's a safe hobby. It's a safe hobby,
Yeah. I do look forward to being able to have a live event again. And
I mean,
new people, and
it'd be great if things, settle down and get more controlled out there, and then we can have a safe environment to have these again. And but everything's kind of weird in Vegas, entertainment's not 100% yet.
I was so surprised that you can't even book a room. So we looked into it in I think April, and I reached out to the plaza, and they're like, man, we're not booking anything.
Yeah,
because we have no idea what's going to happen, come in October or November, or they thought, well, maybe we'll be open, but they won't even schedule anything. So I think when they start scheduling stuff for next year, maybe that's gonna be a good sign, and we can kind of get back to that. However, I think with the success of CRX being virtual, as well as like the World of Commodore and VCF and all these different events that have happened, it's shown one thing for sure. You reach a wider audience for sure, because obviously the people in Germany, like Gideon, he's probably not going to come to the US. Well, he might now, but before he wouldn't come, or anybody who's watching in different countries, they may not come because of the fact that there's a big distance. And so we've reached that audience, and we've actually enticed those people now. So Gideon's like, yeah, I'd like to go to Vegas. And Citrix last night, you know, we were chatting with him. They're like, yeah, I'd like to head over. And so, you know, it's, and, you know, like last year, Sally Ann with Paula Power.
Oh, yeah.
There's a lot of people that, you know, would like to come out and come to the event. So I think when we get to have a live event, I think it's going to be pretty spectacular. But I really think we need to keep an online component so people can see what we are doing. I think that's going to be an important way to go in the future.
Yeah, and it's a great destination. If you've never been to the U.S. or in Vegas,
geez. So
you can make a little holiday out of it. You know,
Yuri's chiming in. It's Holland, not Germany. People from Holland do not like to be called German. They said.
Okay.
So, sorry, Yuri. So all your Dutch people out there, we love you out there. We love our local Dutch guy.
I also mentioned an idea to you about, hey, maybe we should do one CRX maybe in the East Coast, maybe Orlando, because that's a big hub too.
Yeah, you know, it's not a bad idea. I thought that we could branch out and have a biannual event, so that we have two of them. You know, East Coast, West Coast.
Yeah.
So I guess you could host CRX Miami.
Yeah. Well, no, Orlando. We'll do Orlando.
Orlando? Oh yeah, Disney.
Yeah, that's the hub where all the parks. There's Universal.
Right.
Everything's over there. That'd be a really good spot to do it. You know,
yeah.
I'll be going to Orlando a lot in the next, couple months, because I'm going up there with Wagner Folco to produce music and stuff. So we can start, scoping out the areas and just get a little information,
Right. So that's one of those things that, CRX was a good draw for families that were attending, because wives and kids that didn't want to go hang out in our event while we were all being a bunch of nerds, they could go to, Las Vegas shopping malls and the Fremont Street Experience. So maybe the same thing for here, where, if we go to Orlando, send the kids off to Mickey Mouse Land or Universal, and we can.
Yeah, and 45 minutes away, you got Cape Canaveral, you got the NASA Space Center, Kennedy Space Center.
Yeah, I've been there.
There's a lot. There's so much. You go to the left, you got Busch Gardens in Tampa. I mean, there's so much stuff up there.
Right. Plenty of stuff for people to do. It's a great draw. And just like Las Vegas, when the people come in, like we have the guy that we deal with, our club. He's not deal with. He's a good guy. So we don't deal with him, but Tony, he actually came to CRX in 2018, I think. 2018.
18.
And so he made his vacation. And so he went all around the US and he worked us in as part of his vacation. And it could be a vacation destination for a family to hit up Orlando, do the CRX thing, and it'd be nice.
He won an award that year, right? What award was it?
The furthest traveled.
The furthest traveled.
Yeah.
That was awesome. Number one.
Yeah.
Sure. So,
yeah, you won an award that year too.
Yeah.
Yeah, so being the right hand man.
I got the
so Saj is like the lights and sound and liaison for the Plaza Hotel and everything. I mean, he did an amazing job. It's like every event, you do an amazing job, and all the guys. I mean, everybody does CRX. I can't thank them enough. So it's a cool little clique we've got.
Yeah, it's every year. It's a lot of fun up there, and hopefully we can do it again soon.
Yeah. So do you want to say anything else about Forrest? I mean.
No, that's about it. I think just you never know how long you're going to be here, so always stay in touch with your buddies, and just do stuff together, meet up once a week or once a month, and even if you can do it over the phone, it's actually cooler to meet up and do it.
Yeah, absolutely. Yeah, like I say, these times are not ideal for situations like this where you can't meet in person and such. So.
Yeah. Oh, I know Joeri. He's been meeting up in his garage with some of our other CRX people, which is great.
Local.
Yeah, so he's having a little meetup.
Joeri's like, "Hey, lovebirds, let's go."
Yeah, you guys are ready to do some action.
Yeah, he wants to. He's all anxious to get stuff built. So, well, thanks for the presentation. That was great.
Yeah,
I
man.
mean, I know that was probably rough to do. And
Yeah, it was tough. And then
yeah.
the last part always brings me some tears, man.
Yeah, for sure. Yeah.
And I don't know much programming, but I do remember some of the poke commands.
Yeah.
So I didn't
for
know
doing screen
like
colors and that. Yeah.
Yeah. So I did do a last
cool.
poke, the final poke for Forrest right there.
All right. So Joeri, why don't you just go ahead and chime in because you're here.
Yep. All right. I'll be
Let's do
popping
that.
out.
Okay, man.
All right.
Take care.
see you
Thanks,
guys.
Saj.
All right. Bye-bye.
Hey, let's see.
Hey.
Somewhat prepared. So what we're going to do, which we thought would be a nice closure. We've seen that on the Discord as well. There's been quite a bit of action on people building stuff. The original Commodore community was very much a maker community. People building stuff, opening up their machine. People were not shy to do that, and sometimes out of necessity, sometimes to get an extra cool factor in. And it's maybe one of the fondest memories of the whole Commodore period that all of us grew up with. In the last few years, what we've started seeing is people starting to recreate some of these original Commodore 64 boards. And Jim chimed in as well, taking an original PAL release-only KU board as an inspiration to create a reimagined board. Staying close to the original, making minimal modifications when it comes to functionality as such. There's a couple of things that did get added to that, and Jim can talk to that. But mostly focused on how do I create a board given the current technology available that protects us for ESD. One of the big issues that we had as kids with a big fat rug carpets, and we blast our machine with just touching the cassette port or one of the user ports, blasting the CIAs. Also some layout, power distribution layout, so that some of the more challenging cartridges that we may remember, the IAU or the EEPROM programmers, whether the European or the US versions, could be operated as well. And what we thought, well, maybe what we do to celebrate the announced last year of the board and the actual release this year of the board, why don't we see if we can just start building one? Likelihood that we're going to be finishing that in this live call is minimal because we really start from scratch. But it makes for a good view of some of what comes to bear when you start putting these together. We'll talk a little bit about components that you'll need to salvage, new components that you'll be using, and just some learnings in this. I've invited for this my friend Bruce from Canada as well, who also obtained one of Jim's boards. He must be in the top 10, I would say. He was a pretty early bird on these and took a while to get to Canada.
Yeah.
I'll be putting together board number 3 for our Australian friend Tony. What I did is I put a little bit of tape on the board as well, so the signature that Jim put on it is not going to be wiped away while me working on this. And I hope you'll enjoy the build. We'll keep an eye on Discord as well if people have questions or otherwise. And, it can be relating to this board or any of these boards. The 60 clone, 64 clone is a very popular one as well. Thomas in Germany has made some really interesting boards as well. There's quite a few people that have some. The intent of this board, because I got, I'd say probably eight or nine different new old boards, if you will. The intent of this board was really taking a very unique board, a PAL KU board, and kind of seeing, given that that was the first board, how can we upgrade that a little bit so it's a little bit more robust. Jim had some nice ideas to boost the video output a little bit in a nice way, but otherwise stay component-wise very close to the original. So this is not a board with a 78 or an 8701 replacement setup or anything like that. No, this is a high count board, and that was really the design goal as well. That it has a certain charm to it. And again, those people that have been building these boards, I've seen people on Facebook that built more than 10 of these boards now, wondering what on earth they're going to do with that. I know your pain. I love building these. I run out of broken C64s all the time. If you got one and you want to, get rid of it, I always need more of these boards to salvage components from. I'll show some of that as well on salvaging some of these components, and hopefully you'll enjoy the build and maybe you'll learn something as well. Bruce, you want to say something? I see you brought the cat. Uh-oh, cat is moving out.
Let me chime in real quick and talk about the board itself. I mean, so this board was in development in our little CRX group basically for probably almost a year, right? Something like that.
Right.
And so every time I would get so my goal really was to build a board of my own and add some features for it. So I looked at the KU board and I looked at there's open source files for it. And I started editing that board, and it became such a nightmare for editing all the traces I wanted to do, because that was scanned from the original board. And I was like, I literally just grabbed everything and threw it in the trash and started over. So I went and I placed all the chips where I wanted them to go, which is basically where they are on the KU. And then I evenly spaced everything out. And so my goal was to make it very low noise, because that's one of the problems you've got with Commodore, why they had to have RF shield in there. So I used modern build technology that we use for doing high-speed RF in a 1 megahertz board, so overkill, but it really dramatically minimized the amount of noise. I ran this through a little. I have a mock FCC lab here, and so I put a spectrum analyzer on it, and it will pass without any problem at all without a shield. So it's very noise free as a result of that. And then I started adding some features to the board that I wanted. And then Joeri chimes in and says, oh, well, you should probably add this. And then Tony chimes in and said, oh, you should add this. So I spin a board version, and then they're like, you know what, we should do this instead. We should add this. So that took 6 months, I think, Joeri, of feature.
Probably,
yeah. Yeah, probably 6 months. So as a punishment to both Joeri and Tony, their names are on the board as accomplices in this whole thing. So I tried to make it easy to build, but like Joeri said, it's the original parts, really. I think there's only 6 different parts that are different from the original.
Right, yeah, very minimal amount of parts.
Yeah, I tried to keep just a handful of parts that were different, and those were to fix little nuances with the board, like the restore key and things like this, and like to make the power better. So that was my design goal in this whole thing. But Joeri and Tony had a huge amount of feedback in it, and then actually, believe it or not, Ray Manta had some influence in this board too, because from CRX last year with all of his knobs and stuff on the 64 for doing all the pot controls, that's how we ended up getting the internal pot ports inside the computer. So there's influence by a lot of different people. So shout out to Ray Manta. And so that's really why this board was created. I wanted something that would drive an OLED display. It would drive LEDs that are RGB. It'll drive an RGB LED matrix panel, so you can have scrolling messages, all kinds of really crazy things like that. But reliability, something you can use as a daily driver, literally. So in my development process, I had one of the boards on for, I think, 95 days straight. Was on the counter. There's actually an uptime counter on the display as well. And so that was my thing, was if you want to run a BBS with it or something, a real piece of hardware, running something like that, it's a reliable board. So that's really the background on that. So, and then Joeri had to
I think what's been nice, Jim, is while you go through this, and you can go many ways. So you could go completely crazy on this. One of the interesting design goals that was available is some test points. One of the things that's always finicky when you work with these old machines, and where you kind of use a base machine, a known good machine, as a swap board. This is a really nice one. It's got 8 nice test points on them at the outer edges of the voltages that allow you to kind of pinpoint where you may have a draw that's too low as a result of components failing or otherwise. And it's really the other piece that really is a nice standout. It's very well documented. I'll be using, and Jim, I hope in the Discord you can pull a couple of links in the interactive bomb link, for instance.
Oh yeah, so
that's a very nice thing to work on.
Yeah, once again, Joeri, kudos to him for pointing out the fact that you can do an interactive bomb off of KiCad. I didn't know you could do that, so I was able to create that. But the manual is the build manual is 100 and 7 pages, I think, something like that.
Yeah.
Plus, I have a complete gallery of a couple hundred photos of the build process. So the manual is a walkthrough. Literally, here's where we do this, here's where we do that, and so lots of pictures. I'm a big fan of pictures over text because it's a lot easier to build something that way.
Yeah.
And but so I'll go ahead and go into the Discord and I'll pull up some links and let you and Bruce get at it.
Okay. Hey, Bruce, you want to just do a quick intro?
Sure thing. Yep. I don't know if I don't have the exact ideal setup here for streaming. So
Oh, you come through loud and clear and in beautiful picture.
kind of jury rigged my webcam, and I hope it comes through okay. I've just unboxed the board, and it's very well packed, I must say. And I ordered 2 sets of the connectors, which I gotta say, I think he charges. Jim charges, what is it, $13 or $14 for all of the connectors, which you can't beat.
Right. Yeah.
So yeah, if you're worried about sourcing some obscure parts, then he's got everything on the bill of materials, and the connectors are all available on his website. So if you're worried about that, then there's nothing to worry about.
Yeah, I think that's a good point. The other thing is the manual. I really do like the manual. I'm very big on that. I have one of the best memories of the whole Commodores was the fact that we had such great documentation. At Doug's presentation yesterday, I thought it's probably one of the best presentations I've seen in a long time, where he just is just lyrical about the beautiful manuals that came with some of these products. This is a great manual, went totally overboard. I really like that. From some of the products used to kind of put it together. It has my beloved Blue Tech even mentioned in there, which you'll see is used while building this. A little bend tool that you can 3D print. I think you can get those on Amazon as well if you don't happen to have a 3D printer. Very, very useful. And then what components that you need, and kind of what you need to burn yourself. You'll need to burn some EEPROM or EEPROM, and then a story about are you going to socket this or not. And we've had it's interesting. I've built I've built so many different boards now, quite a few boards, and I love working with machine tooled sockets. The problem with that is for any average person that is going to salvage components from other boards, it's going to be really, really hard to fit those into those type of sockets. So a suggestion is, and I think the manual even specifically states, hey, do yourself a favor, don't get machine tooled sockets. They look really, really nice, but just get the regular sockets, and it will make it a lot easier to put in some of the components. So in any case, before you start any of this, just download the manual and just read through that first and kind of see if you're still with the program from there. Then you're gonna have quite a few components. Now, I got a pretty good library of components here. Bruce, I think you went ahead and you bought quite a few of the components, kind of from a bomb via DigiKey or Mouser or one of those guys.
He has everything listed on. I don't know if you can see this well.
Yeah.
Everything is listed on the bill of materials from various different sources. There's DigiKey, there's Mouser, there's Arrow. Everything's listed. Now, I had to be, because of the crazy situation that's going on with the chip shortage, and not just the chip shortage, but everything that's associated with it, did have to make a few substitutions, and some of the chips are indeed out of stock. So won't be able to test it, even if we did magically were able to stuff all the components on the board in the time allotted. But yeah, everything's there, is sourced for you, and I just go ahead and order from DigiKey. It's easy, and it's usually on your doorstep within 2 days, but I had to wait a little longer because as I said, yeah, things are not so normal right now, but
right.
we'll see how this goes.
Right. I agree. And you know, it's I got a bag here. I don't like running out of components. So just to give you, so to build this board, I had to order some parts as well. I'm going to change my camera, guys. I'm going to be off camera. I'm going to be much more, I'm going to turn off my background.
I don't know if
here, guys.
This is the board. I don't know if you can see it well, but I've got to say that is pretty slick.
Yeah.
So
it gives a good view. Gives a good view, Bruce.
And that's real gold, folks.
Okay, so I printed out the bill of materials, and I'll just be stuffing things in as it's listed. Just makes it easier. I just have to find things first.
Right. So I think the manual uses a guide. It's got a tick box sheet. I really like the tick box sheet, which just allows you to kind of go through all the resistors and other components, and you just tick when you've put them all in. Jim's got a recommended way of doing it. Let me be very clear. You should follow the manual. And then from then on, you won't see me using the manual anymore, but you should use the manual because it actually makes a lot of sense. The reason why I am not doing that is because I hate going through all of my resistors first, because I've got to get them one by one. And I just, you know, that's I don't feel like that right now. So what I'm going to do is I'm going to do some sockets first. That makes me always motivated to go start to do a whole bunch of stuff. But by all means, use the manual, and especially use the tick box sheet, because it will help you with, if you got 100 components on your table, to kind of say, okay, what am I going to do? You know, where do I even start? It will also help you. Inevitably, you may mix up a resistor or something. Once you start getting to the end, it will become very clear quickly where you probably want to start looking for which resistor you may have mixed up. What is nice, the manual's got all the nice pictures in that. So for instance, if you have to install a diode like a CR1, it will have a clear marking on it. There's a little black line that will show you where the negative side goes. You know, it will help both with how the board was laid out, and a lot of time was spent on making sure that the mask of the board was readable. We went through in a couple of revisions, even, Jim, I don't know if you remember, where we made sure that, you know, that was legible.
Yep.
And could be used like that.
Yeah, let me chime in real quick about the build order. The reason why I built the way it is, as far as the build guide is concerned, is that when you build something like this with through-hole parts, topography matters. So you want to do the shortest height part first, because when you flip it over to solder the leads, you want to be able to have that sit flat on your build surface. And then so as you get to taller and taller parts, they will evenly sit. Otherwise, it's a lot more difficult unless you're experienced like Joeri and other builders that use the blue tack and stuff. It's hard to install sockets and then go install resistors, because if you flip the board over, the resistors actually pull out of the board and they don't touch. I mean, they touch the surface by extending themselves to the surface. And if you use blue tack, that fixes that issue. But if you're one of these people that don't want to do that method, then you need to follow the build guide, because I build everything in the order the topography. That way, you can build it easy.
Right. Yeah, and you know, there's two things you really should get. If you haven't got it yet, you need to order that blue tech stuff. The link is in the manual, so it's got a link. I call it blue tech. It's got 1,000 names, putty, whatever you want to call it. And the other one you really need to get yourself is one of these benders for components. It just saves so much time. Oh, and the other one I really do like is, and I think you linked it in the manual, is the solder. Eh?
Yep. Yeah,
did you link that organic?
Yep. It's in the manual. I've been soldering for probably almost 50 years. That's sad. Think about
a long time.
So I've used like every kind of solder you can ever imagine, every kind of solder paste you can imagine for doing surface mount. And so organic solder, especially for this application, is the holy grail, because the organic solder is water soluble. And if you've got a nice matte finish black board like this, you're going to see just handling the board, you're going to see fingerprints on it anyway. It's going to drive you nuts if you're really like me, you're detail oriented. But when you make this, you solder the leads and you clip them, you leave a little bit of residue. And a lot of guys don't want to, take the time to go clean up because it's not a lot of residue. But as you work with the board and you handle it, that residue gets in your fingers and then gets all over the board. But being water soluble, you'd simply just take a microfiber cloth and wet it and then wipe it off, and it's crystal clear. It's done. You can't do that with any kind of solder, and it has a lot of flux in the solder that's water soluble, so it makes it really easy to solder the connection, which is also very important. But from aesthetics reason, it's great. From solderability, is great as well. So to me, it's like a win-win. It's great solder. Okay.
Yeah, you'd think that I will be very prepared for this, but I'm not. So let's be clear, I'm not a Chris who comes in real prepared with all of this. I just, and typically, I do a lot of these stuff on Fridays. I think Saj mentioned as a result of CRX, I've made some real good local friends, and we've got some get-togethers here that I organize at the house. And we typically then just, spend time, making something, and, we always have big plans of what the project for the evening is going to be, but often it just ends up to be something else that we'll work on instead, but it's pretty productive.
So if you look at the picture of Joeri's board there, actually I should probably, I won't spotlight you, that way you and Bruce can go back and forth. But if you look at Joeri's board, when I get done talking, you'll see that the user port and the cassette port are taped with Kapton tape. Don't remove that until you're completely done with your board, because that prevents solder splash from getting on those contacts. And if they get on the contacts, then it's a nightmare to try to remove the solder off of that. You'll never get the gold finish ever again.
Yeah, and that's a good point that you make there, because it's very easy. It's very easy to touch that or have it go there, and then and then you'll never get it cleaned up the same way again. It's just it's sad. I got to say, I'm really not. These sockets truly now just come out of the packaging. I cannot remember the last time I've used regular sockets, which is an experience. So we're all on the same experience here. The other thing is the equipment that you use, the soldering, and we spoke about that last year as well when we did the project. Yeah. Don't go out and buy yourself a $500 soldering station. There's no need for that. No. Personally, if you can get something, you set yourself a budget and try and see first if you can get something secondhand. You may be able to pick up like a beautiful Weller for the same price as you would have been setting up some mediocre brand. But these days, there's not really a lot of bad equipment like that anymore. Just make sure that you don't use the same soldering iron that you've also used for the plumbing project last week. Just be clear about that.
Yeah, so the soldering iron that Joeri has here, I basically forced him to get because he does a lot of building, and didn't really force him. It's a good soldering iron. It's JBC. The tips are interchangeable, literally just by extracting through a little base. You put the tip in and you pull it, and you move to the next tip and you push it in, and by the time you go to use it, within seconds the tip is hot and it stays hot. So it's a professional soldering iron. And I think they're literally, you can spend $1,000 on it. And I think I did back in the day. I bought my JVC sets. I bought several of them for manufacturing because that's what they're designed for, heavy use. I bought those in 2001, and they are all still working flawless today. So like Joeri said, if you can pick up a used one, like on eBay, the tips are what you're buying. The handle and the base unit, as long as they work, they're going to work forever. I mean, I've had mine forever. The tip's the only thing that's expendable at that point. So you don't have those sections, wear out of the temperature gauge and the base and all that. And you can get them for, pretty inexpensive at this point for those units. But they're professional grade. They're great. So if you do a lot of soldering, you might want to consider that as an option for you because they are good. But like Joeri said, there's stuff nowadays, I mean, compared to, the old, 500-watt Weller, twin tip style guns that would just burn holes in things.
The Home Depot special.
Right. Yeah, literally for doing plumbing and such. I mean, the stuff we have nowadays for, makers is much better stuff. So you don't need a high-end anything. But if you are going to do this a lot, it's something that you might want to look into, a used unit. I don't think it's necessary to buy anything that's brand new, unless you're, that's what you do and you can write it off at the end of the year or something. So let's spotlight over to Bruce and see what he's doing here.
So, and it's interesting, I think we got a good contrast working here as well. I've known Bruce for quite a long time. Him and I work on some things like these. We just, in a weekday, we'll just say, hey, you're working on something, and we'll just go online and like basically just work on whatever our individual or alike project is. Bruce is hyper meticulous. So, I often learn from his, very thorough way of planning and going through things, where I will just, I'm a little bit more Texas, if you will.
Yeah, my obsessive compulsive nature is shines through sometimes. So
it's all good. I've learned quite a bit from it.
I did invest in a JBC myself. If you're, I'm of the, it's my own personal opinion, but if you're really going to invest in a hobby, and you found that it really appeals to you. I personally don't like faffing around with tools, or things that are halfway. So I like things that make it easy and enjoyable, and if this is just going to be a one-off thing, then by all means, make sure you're using a halfway decent soldering iron, because that makes all the difference.
Yeah, it will also encourage you to do more. What was it? You helped someone on the Discord earlier today with just pointing out something that he may have been perusing over for a longer period of time, and it worked. The satisfaction of the first time that you get a unit like this to boot up and it works, it's often a great way to say, oh, now I can try something else. It's a great accomplishment, a sense of accomplishment.
Yeah, that was Tron's diagnosis, I think, that saved the day there. But yeah, no, it was really great detective work. So that's done.
One of the things with these sockets, if you're going to buy these sockets, and if you only need a handful of them or something, let me zoom in one of these. Oh no, let me do that in the right way. This camera is supposed to be able to zoom. So now I just need to find where it's at. There we go.
Yeah, that's nice.
That was one thing that I wasn't aware of, was the machine tooled sockets are a potential problem with the larger boards like these that don't hold the chips in as well as the dual, the cheaper.
Well, there's a couple of reasons for that.
Yeah.
One
I did not know that.
Yeah, the biggest reason, of course, is if you're using reusing a IC that's been soldered into a socket, the last step of the reflow process when a board like this is done. So for mass production, a board like this, or Commodore's original boards, will have all the parts stuffed in, typically by hand, and then they will be run through what's called a wave solder machine. And so it's a big floating vat of hot solder, and so the boards are quickly whisked through this machine, and just to basically saturate the bottom side of the board, and it pulls out, and then it goes through another machine that does clipping. And so there's a fixture, and it's a router. And so the router makes passes on the board, and that will actually trim all the leads and of the like the resistors and stuff that hang. Like you can see what Bruce has been doing. He's been putting resistors in the board and then clipping the leads on the back side of the board. So those are about 1 inch to 1.5 inches long. And so those get trimmed off. But in the same process, they set the height of the router very close to the board, and it trims also the IC pin leads off. And so when you desolder those to reuse them, the legs are shorter than they were originally from the factory. And sockets were designed, regular dual leaf or single leaf sockets, like Joeri's picture right now here is a dual leaf socket. They're designed so that it can hold a pin on each side when it's inserted in that socket. A standard machine tool socket is a round peg hole with the connector down inside of it, and those need to have the full length pin. If you don't have the full length pin, they may or may not make good connection, and I can guarantee you if you flex the board, the chip will pop out of socket. And because it's a long board, it has a lot of flex potential. When you put the chips in there, you can actually just move the board, twist it back and forth, and you can hear all the legs trying to move out. It's like a crinkle noise to it. And you get the same thing out of the regular sockets, the dual leaf style, but you know they're not coming out. And so it was a little bit irritating. I only had, like, when I was doing this originally for testing, I didn't have brand new chips in yet. So I had desoldered some, and I ran into some issues during my debugging that when I apply pressure on the board, certain places, it would work or it wouldn't work. And so I finally narrowed it down because I had machine tool sockets in. I'm like, okay, mental note, don't recommend those for anybody that's going to reuse the existing chips because it's problematic at best.
Yeah, it's a good point. And then talk a little bit about single leaf and double leaf as well.
Yeah, the single leaf, like Joeri had a double leaf socket there, and he just took it away and took his camera away as well. So if you want,
I did. Oh,
out,
shoot.
Yeah, you might want to zoom out.
Double leaf. So double leaf basically.
Yeah, it grabs the pin on each side. Basically, there's the front side, the back side, or inside, outside, how you want to look at it. So each side of the pin leg itself has contact with metal, and that's also spring loaded. So there's pressure applied to both sides of it. And a single leaf socket, which we used to have back in the day, didn't have the outside part. It only had the inside. So we only had one surface that was a contact. And those were much like the machine tooled, where they were very problematic. So they went to the dual leaf style socket, and that solves all the problems. You can have bad leads, and we could have like solder on legs, which is another problem too, is if you've got like a little tiny blob of solder, it may make the pen distort and not fit correctly for a single leaf socket, or it won't fit at all usually in a machine tool socket, because those have to be super clean even to fit in at all. Any excess solder and it won't fit. So that's the difference between the dual leaf and the single leaf. For these projects, for the your retro stuff, I always recommend the dual leaf sockets because it eliminates all your potential headache in the future trying to debug things by one less thing to have to worry about. Like I said, mine, I literally could put pressure on the board and it would make connection or break connection, and so I spent a lot of time actually.
Yeah, super frustrating.
Yeah, frustrating because it's right. Obviously, if it works once, it's applying pressure. There's a bad contact somewhere, and typically you don't get a bad solder joint. It's something else, and it's the socket. And if anybody that knows the PET, this is a very common problem with the PET because they use a lot of single leaf sockets in the PET as well, and oxidation, and they made very small holes typically for that. So you notice on the ICS64 board, I tried to keep the hole size pretty much like the original. I did shrink some of the holes so they're easier to actually get the pins in and solder in some cases for holding parts in. But you don't want to have a big gap, too big a gap, but too small a gap is a problem if you can't get the stuff out. So we were with, was it Bill Minch? It was, I forgot, maybe Saj remember this. So we were at Convex, which was before CRX. That was the event that we all went to. And one of the engineers from Commodore was there. And we had a PET that we were debugging because you lost your signal.
Yeah.
That's right.
Put my camera. There you go.
So they were trying to debug this pet. So he was over there, and it turned out that the problem was that somebody had replaced the socket, and when they desoldered it, it ripped up the trace on the top side of the board, which was underneath the socket. So there was no way to know it was there. You couldn't see it. And so one of the things about the sockets, when you go to desolder them, the stock bread bin, if you're going to reuse the parts, just be extremely careful if you want to keep the bread bin board for some reason, that you apply enough heat and suck the solder out of the full circumference of the hole. Don't do it on one side, because at that point, when you go to pull the part out, there'll be some tension, and you can rip the trace up off of the board, the pad on the top. So that's what this was. And so after, gosh, it was probably 2 days of toning that thing out, we finally figured out that was what it was. It was one single top side pad had been ripped away, and he didn't know it until he pulled the socket out. So we found out by toning that pin out on it. And you could tone the pin itself and it was fine, but where the pin went to on the top side of the board wasn't connected anymore. So use the right sockets. And so
yeah, I think that's really another thing to just consider. Get the right components, pay a little extra if you need to. Like the way that Bruce does it, it's a really good. He just makes he buys from one of the 3 Mauser DigiKey or
Arrow.
Or Arrow. You're gonna generally you're gonna get really, really good components.
Right. Yeah.
Well, the components that he suggested are all VJ for the resistors and Panasonic for the electrolytics, and those are all top notch.
Right. Well, we don't want to have to do, the recap project 20 years from now.
Exactly.
Yeah, they're gonna 20 years from now. They're still gonna call Jim. It's gonna be Jim and Jim, really. And both Drew and Brain are still gonna be there as the, remember how in 2021 we created that board that we built by maybe.
So the soldering technique that Joeri is doing for the sockets is something that is relatively new to him. And it's something that I learned, probably, well, let's see. I did it on the implant board. I did it before then. So I made the implant board in 92. So I probably learned this maybe when I was a
You were still a wee boy.
Yeah, maybe about at the service department in Commodore, I think, because we did soldering the chips back in after soldering the sockets in there after pulling a chip. So I think I learned it from Henry, who was, shout out to Henry, Commodore, back in 1983 or late 83 or 84, I think. It's, I always learned it as zip soldering. I don't know why it's called that, but it's drag soldering technique. And basically, you'll see what Joeri is going to do here. You just feed solder into, and you move the tip down. And you can only do this with a wedge tip. You can't use a round tip to do this. But that's how quickly you can solder. And so once you get the hang of this, the difference in time frame for assembling a board compared to doing the onesie soldering is huge. So if you're doing a whole bunch of projects and you like this one where there's, I don't know how many solder joints there is. I've actually counted, I guess. You can solder an entire chip in just a few seconds, as opposed to like what Bruce is doing over there when he puts a resistor in. I'll spotlight over on Bruce. Put a resistor in and you solder it. You've got to flip it over. And you solder the one lead and you solder the next lead. So it takes a little bit of time to do that. And as a result, it takes a lot longer if you're doing a socket with 16 pins or 20 pins on a socket, or 40 pins like the VIA or the CIA chips are. It takes a long time. So you can see Bruce just put a resistor in, puts it over, and you can see the lead sticking up there. And so now he's got to take some solder.
Yeah, I think the other thing, a good thing to mention is, everybody starts to panic when two of the little pins that you soldered start like gluing together, if you will.
Bridging, yeah.
They start bridging, and that's one, first thing you should do is just clean, which you should do after every solder action, kind of quickly clean the tip. You either do that with a little wet sponge or one of these things, whatever works best for you. And then you just go over it again, a little wedge, and then it typically just sucks it back up and it opens up. You don't need to hold it on long. You just go over it and it will just get it back. Once you've done that a few times, you'll feel a lot more confident. And where it will help most is with the initial soldering, because you can fix it. That's the big thing. Once you know you can fix something, it's kind of like with woodworking as well. Jim Happel demonstrated working with his router where he made a template. Mm-hmm. Once you know you can fix something, you're going to feel much more confident doing the initial pass, and you probably don't even need to fix things. So Jim, talk a little bit about these, about the U3, U4, and U5, and the masking for 24 versus 28 pins.
Okay, so when I did the board, one of the things I wanted to be able to do is to use EPROMs, because Commodore used 24-pin ROMs, and the board is designed to allow to have multiple kernels selected. So, selection of multiple kernels, not at the same time. So you can have up to 8 different kernels, and you control the board. You control all the functions of the board through the restore key. There's no switches or anything you've got to put in. Everything's done through the restore key, and programming the board features itself is done through the restore key with the display. So nothing else is required. So I wanted to be able to use the original Commodore ROM for the character ROM and the basic ROM if you wanted to. You'll see on like Joeri's, you'll see that there's actually masked like little position points, because the original Commodore ROMs were 24-pin. You can see Joeri's pointing to there. And a regular traditional EPROM is 28-pin. And if you watched Jim Brain's presentation yesterday, he talked about that very same thing, that you need to have an adapter board to go from one to the other typically. And so I designed this board so you don't need an adapter board. You've got jumper pads on the backside you can set if you want to. So I use on my boards, I use 24-pin, the standard character ROM and the basic ROM. And then the EPROM that has to be a 28-pin, the kernel ROM, it's got to be a 28-pin. You don't have a choice in that matter. So you'll have to burn your own EPROM for this. You won't be able to use Commodore stock ROM to do it. But having the flexibility to be using either all EPROMs or a mixture of the two is nice, because you already have a couple of Commodore stock ROMs for the character and the basic ROM. You can do it. So what Joeri has done, which I recommend to everybody, is that just use a 28-pin socket, because you can always put a 24-pin chip in a 28-pin socket. You cannot put a 28-pin in a 24-pin socket without a bunch of wires everywhere to fix that problem. So I would recommend that you always use 28-pin sockets for the ROMs, and then you can choose later on which route you want to go by putting little solder jumpers on the back side of the board. It's right actually where Joeri's soldering right now. You can see on each side of where that row of pins is going through are the solder jumpers for selecting what type of ROM you've got.
Let's see if we can actually look at that at all.
Okay. Yeah. So you can see little bridge jumpers there on each side. You can see it says care, kernel, and basic. Oh, wow, that really zooms in.
Yeah, I'm going to try and get it all in. Okay, give me a second.
Oh, nice. So I have a silk screening on the board, and this is something that, like Joeri talked about before, we went through a couple different versions of the silk screen because it was important to be able to have this right there. Again, I like to have usability, kind of like the SolidWorks presentation I did. The more time you can spend directly on the model without having to go reference everything, the better you are as far as productivity goes. And so by having silk screening on here, this is what you're going to use for a 2332 or 2764. And your camera out must be just like moving under weight.
Yeah, I'm trying to see the camera arm I got is
a little weak.
It's too weak for
That's a heavy camera though.
Yeah.
This reminds me of watching the moon through the telescope.
Which I could hang up as well, indeed. And at some point in time, maybe we'll do that. I got that one out here, so I'll just hold it up.
Yeah.
So
Okay.
basically it has the bank configuration here. It's
Right.
much better in the manual, by the way. You copy paste in the manual.
Okay.
This is the hardest part of the board, because you can see Jim's put some components here in between that aid in that kernel selection.
Yep.
So this is just where you want to make sure that where you position your soldering iron, do it on the side where you're least likely to hit these components.
Yep. The inside of that.
And again,
So-
just do this one last. Do a couple of the other ones so you kind of feel the solder is attracted to the pins that you put in. So you'll just see that it kind of like, it's almost like a magnet. It's very nice to watch. Soldering is a very calming experience.
Yeah, it jumps into the hole. So you see IC6 there, that's actually a 32 megahertz microcontroller. So that's actually 32 times faster than the 64 is itself. And so I put it on the back side of the board because I want to try to keep the board itself on the front side looking like the purest way. So there's no, other than the video part, which is I had to do on the front side there because of clearance issues. That's the only one that I did on the front side, but the rest of the board all looks like a normal, kind of like the KU layout. So I linked the manual, the BOM, the build guide, the gallery, and the gallery is great too. So while you're building this, if you got a question about anything about you really can't tell from the manual picture, like you can't blow it up far enough, if you go to the gallery, those pictures are huge resolution, and you can actually click on those and look at them. So there shouldn't be much in the way of guessing. I think there's 200 some pictures in the gallery total.
Oh yeah, it's pretty extensive.
And I took that with some of it with my iPhone, and I think most of it was my old Nikon 5 megapixel camera that's got a pretty good macro. So Joeri, once again, we seem to always in our little clique get the same hardware, and so Joeri got this this new cam that he's using right now, and so I got one, and now I have to get the macro lens. I actually ordered one for it. It's not here yet, so I can take nice 24 megapixel pictures for future projects. So the documentation should be even better for future things that I do. So it's one of those tools that you have to have, like what Bruce was saying, you need the right tool for the job. That's why this whole SolidWorks thing to me, Joeri, is like crazy, because that's an expensive package to be a developer and use. And
I thought that was an excellent presentation, by the way. I had to step
Thanks.
out for a little bit, but I like that it's recorded because I can go back to it, and it's a part that I would want to create. I really think that that's something, and it deserves a follow-up as well. I think
it's a great program, but the fact, like what Bruce was saying, you go get the tools that you need, because that's really going to assist you in the future and
Right.
reduce a huge amount of frustration. It's like you have a JVC as well. That package, it's thousands of dollars to. I know it's thousands of dollars to buy it, the license, and then every year if you want to upgrade your seat, it's $1,800, I think is what it is now, and so it's an expensive proposition. So that really puts it out of the budget of a maker completely. It's too expensive. But the new version, it's $99 a year, and it's the same thing. It's the full-on version. You just can't use it for commercial purposes. But you know what? If you're a maker and you're building this board that you're building right now, you're probably not a commercial designer, and so $99 is pretty cheap for something that you can use, to build whatever you want. And there's a huge community. I mean, the community is crazy. And so I want to make a Commodore community on there, because there isn't one. And so we can start actually sharing designs with the Commodore community, which would be great. Like I'll upload the keycap or the end cap to the community to start with, and I can build other things as well. But it's a good way for everybody to that are designers, or want to be designers, to stay in touch and share some designs.
Chris asked a good question. What tip do you recommend? Chris, basically for anything that we do and anything on this board is I will only use a single tip.
Yep.
And it will be
the wedge.
It will be wedge.
And then Joeri burns his hand.
Yeah, I'm going to try not to, but you get the feeling.
There you
See
go.
this?
It's just a
It looks
small
like a
wedge.
wedge.
It's like a 1/4 inch wedge. I think that's what 8mm.
Yeah.
Yeah, 8mm wedge.
Yeah. Yeah, but a 5mm would be good as well. But that type of wedge is you're gonna be able to use that for this entire board. There's no need to get anything else.
Yeah. And the nice thing about that wedge, that angle on it's the 45, and the way JBC works with their, their great quality. The very tip of that is a very nice tip, so you can flip it upside down, and you can use it as like a regular point tip as well. If you need a point solder, on something, instead of using it in wedge action like for the drag solder technique. So it's a very versatile tip as well, which is why you can use it for everything like on this board.
Yeah, and again, solder using the instructions, it is a lot easier unless you're used to work with this tack. There's people that I have one of these big solder board holders as well. A lot of people like that as well. This tack is great if you got a board holder where you can just flip these boards around. Those are nice as well. I've got an ESD safe surface here. So that's nice because I pull up so many items, and I don't have to wear. I do have, but I don't have to wear this. And it just makes it easier for building this board. You don't have to worry. This board, while you're building it, until you're going to start putting in the components, you're completely, you can do it on the kitchen table if you want to.
Right. So you'll see Bruce is up there, and one thing that Bruce is doing that Joeri is not doing is he's actually using quite a bit of flux. So the reason for that, well, telling people why you're using all the flux on there, Bruce.
I just find that it makes the solder flow much easier, makes a much more even joint, and you have to clean it off afterwards, obviously, because I don't know if you can see it in the shot, but it does leave residue afterwards. But just get some isopropyl alcohol after, and a couple of these anti-static brushes, and just go to town afterwards. And I think it just makes the solder flow much easier, I think. So I just go what works.
Right, that's standard non-organic solder then, right? You look like you got a Kester.
Yeah, I don't know if it's in the holder, so you can't see the edge of it. I'm just using the eutectic lead solder.
Yep, 60-40 or something like this, or 63, or is this 67-33 or whatever the percentages. They make different percentages. So Joeri is using the other solder, right? Joeri using organic solder. Yeah. So the organic solder has a gazillion gallons of flux in it. That's all I can explain it, because I was a little bit stunned when I started soldering with it. It's like, holy mackerel, this thing is just bleeding flux out. Where's all this flux coming from? And that's the nature of organic solder, and that's why it's a water soluble material. So if you don't want to have to add flux to the board like what Bruce is doing, and a lot of people do that instinctively if they're using, they're building boards ever. That used to be the only way we could get something to flow well, was having excess flux in it. But this new solder that I linked to in the manual, and that Joeri is using, I use it now exclusively for everything. It gets rid of the flux requirement and makes it even faster and less cleanup. The cleanup literally is with a wet microfiber, and you're done. So it's a good solder for that.
I'll definitely have to check that out, because that sounds love anything that's labor saving, that's for sure.
Yeah, I didn't believe it either. Like I've got a policy in my life that I believe nothing I hear and only half of what I see. So I got the solder in and I started soldering. It's like, first of all, my first comment was like, wow, there is a ton of flux in this. And I thought, oh, this is going to be a nightmare to clean up, really. And like, well, we're going to see. I got a microfiber out, and I have a bottle of water next to my stand there that I use to replenish the water I've got in my little sponge block that I use for cleaning my tip. And I wiped that down and then dried it off with the other side of the microfiber. And I was pleasantly surprised that it yields a very nice result. And it's, if you solder like what Joeri's doing right now, that little drag solder technique, you can see there's not a lot of residue required when you do that. So I'm a stickler on aesthetics wise, and I want mine always cleaned all the time. Joeri just flies through this stuff now, but because he's done, like you said, probably 8 or 10 of these boards of different types. Plus, how many other projects, Joeri? You've done dozens and dozens of other projects as well.
Miles of soldering.
Yeah, you know what? That's funny is you should mention that. I was looking at like how much solder I buy, and I'm going through, you know, a couple of rolls a month at least, just doing prototyping stuff. And I'm like, oh my gosh, that is like a lot of solder.
Wow.
So things like that, and like, you know, tape, various little tiny things that you don't think much about. You just end up going through a lot of that stuff when you're, you know, in this hobby, and this is a kind of a side business for me. And I thought, wow, I need to like buy bulk quantity. It's like buying bulk quantities of toilet paper and paper towels during the lockdown.
Marco, I'm using a JVC. I think they have now these hacks to use these TS100s on those, or people use a TS100 as a replacement or a cheap alternative to a JVC. I've got a couple of sets. I've got a Pace set as well. I got a love-hate relationship with those guys. I got some equipment that's fantastic, and then I've got some equipment that's just very expensive and not so fantastic. I think it's important to repeat that buy the solder and buy an iron that fits in your budget, and if at all possible, try and use that budget for a second-hand one that comes out of pro environment. A soldering iron, especially the pro brands, they can run 24/7, and they can do that for many, many years. And you just change the tip and it will run for another 10 years. But they're so good at keeping the heat. You know, that's money well spent, but don't go overboard. Your soldering at the end will look no better if you don't apply the right technique.
Yep, practice makes perfect.
Yes, and practice on old boards. You know, practice on. David was over the other day. No, it's not a Weller; it's a JVC, Chris. David was over, and he had brought a board with him, and that was, that had some, needed some love. But you could just see within 10 minutes time how much his soldering skill improved. It was like pretty amazing to see. That's really cool to see how quickly, once you get it, it's kind of like riding the bike. Right. It seems like utterly impossible. And with my kids, I remember trying to teach them how to ride a bike. I'm like, how am I going to teach them? And they're never going to learn. And then all of a sudden they know. And then you're like, I don't know what happened, but it worked. So just do more of that.
Sure.
Also, I don't know if you've noticed, but I'm always ending up with one part left. That's always because I always order one extra for everything that I need, just in case, a lead breaks off or something, and then you're without you're missing a part at the end. So just they're what, 15 cents each. So it doesn't really add up to much.
I need to write that lesson down.
Yeah, that's a good point too, Bruce, because
I'm
the
always
electronic
one
companies
short.
like Arrow and DigiKey and Mauser and Newark, all the other companies you can buy parts from, they typically do not hand count anything. It's almost always based on weight. And so they'll throw parts into a bin that weigh this much based on their knowledge of what the weight is. And sometimes you get one part short, sometimes you get one part extra. Sometimes well, most of the time you get on right on point. But I have had orders where I didn't order an extra one. I was like, I'll be fine. I'm like, I'm nuts. They shorted me one part. And like I said, it actually on the packaging slips, and a lot of packages themselves, you'll see this product was counted by weight.
Right.
So they do a weight on it, and that's how they figure out how many is actually in there, especially when you're doing quite a few things. Like I just got in all the ferrite beads for these. I got in, oh geez, I think I got 10,000 of them. So they're going to go on the website, because I tried to put the things on the website that are hard for people to get typically, like the connectors. To get good connectors, like you said it earlier, like they're $5 a piece on eBay for a lot of these connectors. I just saw 8-pin video connector somebody had, and it was used, and they wanted $12.95 for it or something. And I thought, wow, that's like really expensive. So I was able to get the connectors and put them in a package to make them affordable for people. So it's important to have things that are hard to get, like the ferrite beads are typically harder to get. Some of the coils and stuff, I'm gonna try to have them on the website as well.
Yeah, I think that's, you make a really, really good point. When we're going through this board, to kind of saying, okay, let's be clear. All of these boards, every single one of them, the tuning board, the 60 clone, the ICS, all of them need an original C64. People should get over that. Of course, stop crybabying. There were millions of these things made. They're not museum pieces. Do with it what you want to do. So you're going to have to reuse certain components. There are certain components, though, if you can get them new, you really should. And Jim, you did a great job in getting some of the hard ones. The video one that's a 262 DIN, 8-pin DIN. Terrible availability. These, you should get a new one for this. You should get a new one for the IEC, the video port, the cartridge port.
Yep.
The power, the on and off switch. If yours looks okay, works okay, use that. Those are expensive, hard to get. The DB9s, they're hard to get off clean, because the pins are often on the original ones heavily corroded. I don't know why, but it seems that the Coca-Cola always drip there. So get these. And the good thing is, and you can see it here, what Jim did, and we spoke about that during the design. This is one of those things, is put in 2-pin layouts. Put in for the normal, for the easily available, even Amazon has them, DB9s.
Yep.
The males or the original ones.
There's actually fits 3 different types of DB9 connectors will fit into that. So you've got your choices, but the inexpensive ones, like you're saying, Amazon has them. You get them off on, new off of eBay. They're really inexpensive, and they literally snap in place to make it easy for soldering. And those are the things that really should be new, like you said. Like the cartridge port connector can be new. Now you can buy every single part new and build new. None of my boards, actually I have one board that has one used component, but all my other boards have all brand new parts in the whole thing. And so you can do it, but yeah, obviously it's much cheaper and easier to just to find a Rec 64 board, and everybody has them. You got one. If you're a 64 enthusiast, you have one board somewhere in your collection that didn't work, can't figure out what's wrong with it. So you can start pulling, parts off that are going to always be good, like the transformer is going to be good, and the other things that are good off of it. But no need to reuse the DB9 connectors.
Right.
Yeah, you can do it, but yeah, they're $1 or something like that. They're like really inexpensive. Actually, my set, so like what Bruce was saying, to get a connector set, in my connector set, you get both DB9 connectors, the 7-pin power connector, the cartridge port connector, the IEC connector, and the video connector, and all of the headers for the board, all the through-hole header pins, and it's $12.95. So
that's amazing.
So that's basically,
I don't know how you do it.
That's cost plus 5% or something like that. It's really not a lot of money in that, but to me it was important to have that available. I'd rather push people to do that than go through the frustration of trying to remove these bigger connectors that are hard to remove. It makes more sense to get new at that point, whether you get it from me or from anybody off eBay or whatever. I would prefer people did that, just because it is difficult to remove, to try to desolder a big connector. Desoldering a resistor is a far cry from desoldering the transformer.
Right.
But what else is really hard to desolder on there? I think the connectors, the DB connectors are fine.
The
but
regulator?
the regulator, the IEC connector and the video connector, those have got 8 pins on the video connector if you got the 8-pin version, and which is what this supports. That's a lot of pins. Plus, it's got 2 guide pins, and you got to be able to suck all the solder out of the holes and pull them with. You're better off spending the money for sure. Labor time, that's a huge difference if you look at that, because you spend half hour, 45 minutes just desoldering those little connectors properly.
Yeah, Marco. I know you're in Serbia, and I would look for the Wella ones as well. Maybe get one of the Wella digital ones. Get one of the second-hand ones if you can. The availability of fantastic tips for those is really good at that side of the world, and those units, they're industrial level strength, and they can provide a lot of heat on a lot of surface. Speaking of heat, so Joeri, what you have your iron set on for heat? Pretty high. I tend to keep it at about 650 Fahrenheit.
Oh, that's about average especially if you're gonna do drag soldering, because you need to have the high temperatures of the
and this is really where the heat cannot deliver sustained heat. That's really where a good iron comes in.
Yes.
You need good iron that doesn't drop the heat immediately. You can feel it because it starts getting sticky. It's almost like it gets magnetic.
Yep.
You'll immediately notice it if it's too low.
Yep. And that's basically, it's slag. We call it slag. And so it's just like welding. When you have the wrong temperature, you get slag built up that it's hard to remove. So Bruce, what temperature are you running on yours?
It says it's 350 Celsius.
350 Celsius is exactly the same. That's okay. We're very, very close in temperature.
Yep. So I run on mine for doing drag soldering. I run 640, and for everything else, I run 590. That's Fahrenheit.
So, 590, which is about 300 or so.
Yeah, so it's a little bit lower because typically when you're doing single point soldering, you've got a long duration of transfer of heat. So a little bit lower temperature, it seems to work better because of the fact that, well, it's safer for damaging the board because you don't want to damage the board. And so last year, I mean, Marco can attest to this. When we did the hardware build project, we had a couple of people that were following along, and they must have been using really big irons. And so you apply too much heat to a board for too long and you start damaging the board. So we had to do some jumper mods on a couple of boards, which worked great. But you can get rid of that kind of a problem by simply lowering the temperature a little bit and have a little longer duration. And that averages things out really well, so you don't have a problem at all.
Yeah, I can't imagine the heartbreak of, going through all the work of soldering a board only to lift a trace because you accidentally had your tip temperature too high.
Right, and so that's the deal is that when you've got too high a temperature, the copper the substrate will separate from the FR4.
Yeah.
And so the entire ring around a pen will lift up in the air, suspended by the remaining copper of the lead itself going out to wherever it's going on the board. So you end up with basically an antenna. So you got this lead, and then at that point, if it's on the front side of the board and a socket goes over top of it, you could probably salvage it. But on the back side of the board, it's a pain in the butt to try to fix it either way. It's just not a good thing. And you can get rid of that problem by simply don't overheating it. You could heat the board at, maybe 300 degrees Celsius for, 590, whatever, for 10 days, and it won't be a problem. But if you heated it 50 degrees higher, it may destroy the board instantly. So there's a threshold there you have to be wary of. So it's always better to start a little low and then work your way up a little bit. If you're finding that, like Joeri was saying, it's like magnetic where it kind of clumps up, you can turn up your temperature a little bit at that point.
Right. I think I think you'll see that with the desoldering as well. When you're going to start taking parts off a board that you're going to need, you're going to get impatient. You're going to start pulling things, and you're going to start, that's where you're going to start lifting trays. Now, it's good if it's a board that you're going to like dump anyways, because you're taking parts off, that's okay. But when you're trying to, like, say, for instance, replace a soldered CIA in a board that you're fixing, that's a lot of extra work that you don't need, and a lot of extra risk if you don't have a lot of experience of having to repair as well. With start with a simple thing of a CIA that died from static energy, to now you're gonna have to do a lifted trace repair.
Right. Question came up through Discord is that it's not sure if this is possible. It'd be really cool if someone could use SMT LEDs on the board of some kind, or integrated diagnostics, or a cool light
That'd be
show.
cool.
So this has that actually built in. So there's a RGB LED support. There's 3 pins on the board that will drive a RGB LED strip, and also drive a 32x8 pixel matrix display. So when you power up the board with the little LED strip, and there's 4 RGB LEDs in a row, there's the first one's the status. So it tells you, well, if it starts flashing either red or green, it's going to tell you that your voltage is either, there you go. So Bruce has them. So that's the OLED display on the left-hand side, and and the right side is the 4 RGB LED strip. And both of those will give you diagnostic information. The display is great because it shows you the voltage of the board, and shows you which ROM you're using, and shows you how long your board's been on for uptimer. And then you can use the restore key to program the settings. If you hold down the restore key for 10 seconds, it goes into a menu. At that point, you can program how the ROMs work, for XROM and game lines for the reset, and various things like that. And you can turn on and off the statuses for certain things. You can see with XROM state, you can see what else is in there. I got a bunch of things for diagnostics and for just knowing how the operation of the computer is going, which ROM is used. So there's quite a bit of neat little things like that, all courtesy of that little tiny microcontroller in there. So
I like flashing lights and cool.
Well, it's funny. So on the Discord, they're like 32x8 display. Oh wow, what drives that? Well, it's the microcontroller. So let me let's see if I can flip on my
share a
machine
pic
here.
maybe. Maybe do a picture. Do a share screen on the picture for the manual. Kind of go through the.
Actually, let's do this. I will spotlight. By the way, I just figured out under Zoom how to spotlight both of you side by side.
Nice. What is it? Control or Shift or something?
Oh, it's actually in the menu. It's called Add Another Spotlight.
Oh well.
Yeah, who knows? Go figure, huh? Let's see if I can add myself to here too.
Right. This is the care kit or whatever. What was this called? The connector kit? What is this?
Connector kit.
Called?
Yep.
It's the connector kit. So connector kit comes with the IEC, the power, and the always unobtainium video connector. Those are, it's amazing how many originals T64s got put in the wrong ones as well, where people over time have changed them, and that's why you always see these video cables so crooked. And then the cartridge connector. I don't know what Jim said about the cartridge connector, but get yourself one. These are always terrible. Like, it's unbelievable what people have been trying to put in that cartridge board. Don't reuse those. They're hard to desolder anyway, so most people wouldn't even dare to.
Yes, that's true.
Try and reuse.
Okay, so I'm seeing my cameras in here. So this is the ICS 64 board that's assembled, and you can see I've got a display here for it. Actually, I'll set the display up here so people can see it. So in the back here, so I've got a RGB LED strip. I don't know if you can see that. There it is. So that's the little strip that Bruce just showed. And this is a 32x8 pixel, basically array. And
Very nice.
I'll power this up so you can see how this actually works. So you turn it on, and so I've got a message across here. Actually, I want to hide this, and I'll explain that in a second of why it's flashing. So, and I have PC software, and you use a standard FTDI to serial interface plugged into the board, and you can program all the ROM settings, all the colors for all the LEDs, what the matrix says. So this was a very simple little demo of like text characters. And I have the brightness turned way down on the LEDs too, because it can blind you. So when I was doing this in my office, I'm like, yeah, I probably don't need to get blinded. So I don't know how well it's showing up on the camera. It's not too good because I'm not holding this very steady. If I can hold it steady. Oh yeah, look at their CRX is October 1st, 2021. So yeah, it'll drive this panel. So if you notice over here, there's an LED that's flashing. This is actually the status LED. And the reason why it's flashing green means that there's a low voltage to the board. And so here's why that occurs. I have one of these power supplies that's got the display and stuff in it, and it's built from a company in Poland. And the voltage on it is 4.69 coming out of the power supply on their display. And on here, if I can get this to focus in, maybe. I guess not. Yeah, 4.66, 4.67. So it's below the threshold, and you can program what the threshold is with the PC software of what will trigger the alerts, either over voltage or under voltage. So if you want to have it, and my default setting is 4.75 volts. So anything below that, it'll flash. Anything above 5.25 volts, it will flash as well to let you know that there's a problem with your power supply. So, which is pretty handy when you're doing your debugging. So startled me the first time I saw it come on, because I had to deliberately change my power supply. I have a desktop power supply, and I had to change it during the testing of the code just to see that actually occur. And then when I plugged this in for the first time, it started flashing, and I'm like, whoa. So I didn't even realize it because that power supply is back behind my monitor. So I never noticed the fact that that power supply's got problems. Got to replace it. The board still works fine at low voltage, but just warning you. So how are we doing, kids?
Pretty good. Pretty good, I think. I wonder where the parts board is that I had.
Did you contact your acquisition department?
Yeah, I did, but.
So I have board number 1, Joeri has board number 2, and I've saved board number 3 for Tony. And if you look at Joeri's display over here, actually I can actually spotlight. I should remove Bruce real quick so it's larger. There we go. So Joeri and Tony got their names over here in the corner of the board, and I signed this one for Tony. So these two guys, they get signed boards. They're the only ones that got signed. And we were well past 3, obviously, but so special thanks for Joeri and Tony for all the feedback and the long nights that we sat around arguing about feature set.
Debating indeed. Miracle that friendship survived.
Yeah, for real. And I think I did what, 3 spins of the board. 2 were because of feature creep, and one of them was because
great IDs, called great IDs, not feature.
Oh, right,
great
right,
IDs.
Right. Great ideas that we had. And I think a lot of that had to do with we were talking about things in our childhood that we had to mod on our boards. Remember that about the restore key and stuff?
Yeah.
So the restore key was notorious for not working correctly. You have to beat on it to get it to work, like run, stop, restore. It didn't work like when you just press run, stop, and restore, and then that's it. I remember you had to like beat on the restore key, and it would finally break. And so that was a little bit of a timing oversight on Commodore's part, I think. And so that was fixed in the board. That's one of the reasons why you need some parts that were not on the original board to fix that. And a few other things in there, like the audio filtering thing for Messiah and not audio filtering, but audio input for the pots. So
Yeah, the
Messiah
pots,
uses
the pots,
that.
pot connect, nice pot connectors. Actually, for people that want to build what
Ray uses.
what Ray has, you can
Yeah.
easily just connect these in. You know, you can just plug it in. That's very, very nice solution. Also the easy switch between the SIDs.
Yep.
And the VIC.
And the VIC, you can do a 12-volt VIC or a 5-volt VIC.
Yeah.
You can do power and TSC.
Yeah.
By changing the chip out. You got to change the chip in the crystal.
Yeah.
But it's a lot better than having to desolder, a crystal and all that. So I made it ability to have a socket in place in the crystal, and you can just swap the two out. I'm not a PAL guy, but I just added that because Joeri is a PAL guy, and so is Tony. So.
And the rest of the world that takes this machine serious.
Well, that's true. Yeah, I mean, I know that PAL is very popular, so I'm very biased only because of the flicker. Drives me crazy in my eyes. So, I mean, there's a lot of great PAL games for sure because you've got so much extra time to do things. It's a little more vibrant in that result. Let's see how Bruce is doing here. Let's spotlight him back in. Oh, that's a DigiKey package.
Yep. I got everything off DigiKey.
Yeah, I recognize those. I have hundreds of thousands of parts here. Literally, I probably have millions of parts actually here.
Yeah.
I'm always missing one part.
Well, I think if I were to shove the screen hard enough over between you guys, I could probably shift a part over.
I have a few extra here.
You have a few extra.
One
That's
extra
really going to help me. Yeah. No, I think.
And you can see what Bruce is doing there. That's what I recommend in the manual. That's the lead bender, and it's so much better to do that than the old school method of like just bending them over and then putting them in the holes and then pulling them through.
Can you just imagine having to do that for a board like this?
Oh, well, yeah, it's hard to do for one thing, and the other is the amount of potential damage, because you can rip a pad up doing that if you pull hard enough. So having the lead bender eliminates all the potential for damage and sure makes it faster and easier to install the part because it's bent. It's kind of like Joeri had earlier.
Exactly the right distance apart, and there's less stress on the component and the pads when you solder it and when it hardens.
Right.
From what
and
I
so
understand.
Joeri had a device earlier that we didn't chat about, and it's a lead straightener for ICs. And so some of the sockets he was going to put into there had a couple of pins that were bent out a little bit. And so Joeri used that device and it straightened all the pins out instantly. Again, so your socket drops right into the holes. So question was, and Joeri will get a chuckle out of this, for the CIA, PLA, VIC2, etc., do they have modern day replacements for all of those, like a microcontroller based or something?
Yeah, lonely.
Yeah, there's PLA replacements already. There's VIC2 replacements that use FPGA, a couple different projects for it. And then I have a project for the CIA that we kind of talked about yesterday that actually we haven't talked in chat about that. I have a product that I have sitting here that's basically done that has run into an engineering snafu. Should we call it that, Joeri? Engineering snafu?
Yeah. Opportunity. It's run into an opportunity.
So, so I have a replacement drop-in chip, and it replaces the CIA, the VIA, the Commodore 6520, the 6530, the 8520 for the Amiga. I think there's like 9 or 10 different chips it can replace.
Mm-hmm.
And it's a one chip solution, can do all of those. And so I've got a race condition on my board somewhere, I think. And so I need a logic analyzer that can do 38 pins. And I have 32 pin or a 32 channel logic analyzer. Joeri has one, and we were just chatting one day about that. I need an extra, 6 channels to be able to look at all the signals together. And this is the first time I've done anything for Commodore. Actually, probably anything really needs to have that many all at one time. And so you really need to have that. And the option of having multiple different logic analyzers together and try to synchronize the signals on the screen together is almost impossible to do. And so we were just chatting, minding our own business, and then Jim Brain, Go for Retro, he chimes in and goes, "Oh, why don't you guys get these?" And they're Agilent, HP Agilent logic analyzers. And back in the day, when they came out in the early to mid 90s, these were $30,000 to buy, and they're full on, engineering grade. I knew about them back then. They're just way too expensive back then to buy for what I was doing. They're amazing, but you can buy them on eBay now, and they're like $500. And so Joeri and I both got we got one. Joeri has two actually now, and it turns out that the units themselves are great. And Joeri and I went crazy and put Noctua fans in to make them really quiet because they're really noisy, and clean them, and they're just beautiful. And it turns out that the cards that you plug in, because they've got plug-in cards for the functions, they don't work. They're all bad. I have one actually that kind of works, and the other ones are all bad. And it was kind of like, if you know the story of the Amiga 2000, the Amiga 500's trapdoor, anything with a Varta battery over a period of time leaches acid out. Well, this is kind of the same thing on these. On the bottom of the boards, there are 3 plexiglass rails, and they help the board be guided into one of the previous versions of the HP Agilent analyzers, not the ones that we have. Those are open frame, so we don't even need these little runners. But the runners were applied to the board with an adhesive that eats the board over a period of years. And so wherever there's rails crossing traces, it literally ate the board away. And you have to make bodges, jumper wires for all of these traces to fix them. So all of my attention on my little project to replace the CIA and the VIA was rerouted to fix the machine that was supposed to analyze its problem. So that's where we kind of stand in the whole thing at this particular moment, is we've got to still fix the machine, because without the logic analyzer, I can't really figure. I probably could have by now, figured out what it is and fixed it and maybe done, but it's kind of one of those things that it's now, it's a necessary evil just because of our own pride to fix these things as they work, that we've gone through all this trouble. And like I said, Joeri bought a second one. He's a glutton for punishment, worse than I am apparently. So yep, someday there'll be hopefully it'll come out. It's basically, so each package, somebody asked if it's a one chip solution. Every package is a different number of pins. So like this product called the XIA, it handles a 40 pin package replacement. And then the PLA replacements that are out there, those are a 28 pin, like a standard Commodore pin out. There's not one that does a 28 and a 40 and 48 for VIC or anything like that. So it says that ARMSID is nice. Yeah, I actually have ARMSID and 2 of my boards. ARMSID seems to work okay. So that was the other thing too in this development process. So between Joeri and I, we have every PLA probably ever made on the planet, and we were testing PLAs and the process of this. Well, it's got to support this PLA, it's got to support this, and so my board does support all the different PLAs correctly. But I think Joeri and I have come to the conclusion your best bet is probably to go with the GAL version, because it's open source, it works, it's guaranteed timing. I mean, it's really a good solution.
Yeah, it really is. And it works really in every board.
Yes.
Every board that supports that pin out. Obviously, there's the combined IC, the 64 high density IC that has built-in PLA. That's an entirely different board that doesn't have PLA issues. That's a last generation board, if you will. Yeah. All the ports PAL and you see the GAL PLA is the way to go.
Yeah, we found that the GAL PLA is as compatible as Commodore's original S100s.
Yeah, And we experimented with that a lot as well. Remember, we what we did is we obtained a number of PLS 100s, the Philips,
Yeah, you did.
Philips, and some Russian counterparts, and then we went back to the archives of what is the oldest programmer that we can find in our closets, and we happen to seem to be buying the same kit already for 20 plus years.
Yeah.
And then we jerry-rigged up a laptop. Remember, we loaded a whole new laptop just to connect it to a parallel port to then try and reprogram an absolute original PLA, which was a fun process to do as well.
Yeah. So I have a Dell laptop now identical to Joeri's because he's got the same kind of programmer I have, a BP Microsystem. So when I developed the implant board for the Amiga, I didn't want to use PALs or GALs. Well, GALs were like hardly available and very expensive, and a PAL is a one-time burn only, period. So you can imagine in your development cycle, if you've got a reflash your custom logic chip and it's a one-time burn and they're $5 a piece and there's 5 on a board, it's expensive to make a bunch of revisions of your logic. So I opted to go what was called a PEEL, which is PEEL, and it's programmable electrically erasable logic. And so you could erase it and reuse it, just like a flash ROM is. And it was brilliant, which turns into be what the GALs did later on. So you can reprogram a GAL over and over again. So there was only one program that supported ICT PEEL, and that was the BP Microsystems programmer. So just in passing, you and I were chatting. I'm like, yeah, I got this programmer. It's like, yeah, I got one of those too. Like, why do you have one of those? And how are you running it today? Because back in the day, actually we got on the subject because I was trying to figure out how to put together IBM 5150, because that's what we used originally on the BP Microsystems programmer. And Joeri's like, oh no, you can use a pseudo modern Dell laptop. And because it's got a parallel port and all this stuff. And so I ended up getting the same laptop that Joeri had, and we exchanged some files, and presto, we had, and ironically, I needed the BP Microsystems software support the Windows and later DOS versions, because I had like really old, I had the original floppy disk, the 5 1/4 floppies. And so I contacted BP Microsystems, and they're still in business. They actually sent me an email with a link where to go get the last version of the software that would work on it.
My hat off to them. I think it's amazing. Their customer service for stuff really, really old. It's clear they have a lot of original employees there still. They really are super.
Yeah, so we bought the programmer. I had the receipt was in the box, believe it or not. So the programmer was $2,400, and we bought it in late 1991. And so they were doing tech support for a 1991 product. So yeah, kudos to them for the support. So with that, I was able to, with Joeri's help, get the laptop set up and able to pull out the old programmer, and I burned a bunch of peels. So on my website, I actually offer the upgraded peels for the implant boards. If you've got an old implant board and you want the PC emulation compatibility, I have the peel you can actually buy from the website, and the latest and greatest custom logic that I did for the board. We did like 3 revisions of the custom logic to increase the speed for like the SCSI interface and things like that. So that's available. But yeah, it's amazing. You can just revamp this old stuff. I mean, who knew you could take a programmer from 20 some years ago? Well, geez, it's 30 years ago next year. Wow. 30 years ago at the end of this year that we got that. 30 years ago. Geez. So 30 years technical support. That's amazing.
That's crazy, huh?
Yeah. Yeah. But, we can use that stuff today, which is great.
Well, that thing lasted even longer than the Willenprog. Remember that one?
Oh, yeah.
We used to have those.
Yep, I have one of those.
Especially with the, that was a very popular unit to own back in the day.
So we're on the subject of programming. Let's chat about the ROMs, Joeri. What are you going to do about the kernel ROM?
Yeah, this unit obviously is gonna have to. It's a PAL unit. Well, let me think. What did Tony say? I think Tony wanted a NTSC unit. We'll have to see once he comes on what he wanted. Depending on what he's licensed, I can load up his license for Jiffy.
Right.
And then probably the stock one. We'll put in at least speed DOS as well, because he's going to run something parallel speeder at some point.
Right.
So we'll put that in as well. We're going to see what he all has used, and then we'll put that in.
So the board will support an 8K size ROM all the way up to the 512K size ROM. So you can have up to 8 different kernels you could switch between. And so like what Joeri's saying, you could have a stock ROM, you could have a Jiffy DOS ROM, a Speed DOS ROM, Magnum Load ROM. There's all kinds of different ROMs that were available back in the day. So what you want for the number of ROMs is based on the chip that you're going to be using. So I think you're going to use
512.
27512, right?
Yeah, 512. The 27512 at the end is the only ones I use, even if I only use less. So I use them as a 256. I'll just double them up,
right?
Because they're just they're the easiest to obtain.
So explain why you double them up. Why is it a benefit for you for debugging and save your frustration? Why do you do that?
Because that's what I'm used to.
But the reason for that is if you don't double them up and you select the wrong bank, what happens?
Yeah, nothing. Nothing happens. That's a big problem. You get in a fight with your friends.
So like you're saying, if you only use half of the ROM, you're better off taking both the halves and copying them to both halves of it. That way, if the address is wrong, as far as the bank select is wrong, it still works at that point.
Yeah.
Yes.
It actually takes the thinking. It takes the thinking out. You know.
Right.
We tend to get into fights over who produces the ROM and who does that in the right way. Ow.
Right.
Wait, that was odd.
Yeah, you had that recently, didn't you?
Yeah, with our friend David's project.
Yeah, the Runic.
Yes. And then at the end, Big David had to come in and basically save the day and say, why don't I write a quick tool so that you guys don't have to bicker about this anymore. He had to set us straight. So I typically use a program called I think it's called BinMan to Bin Wizard to put some together. But I at some point in time I'm going to try and see if David can write a bit of a revised GUI type of setup that does a much better job of that.
Yeah, because
I use this quite often, and it's easier to do it on a visual basis than loading it in Mini Pro. Someone said yesterday on Jim Brain's
I saw that supports it.
Mini Pro as well. But all of that to me is a subpar solution, because if you need to do a lot of these, it's much easier to kind of do it in a visual tool. Where you can just drag and drop them.
So let's talk about programmers for making your own EEPROM.
Mini Pro.
The Mini Pro, the TL866A is called the Mini Pro, and there's a bunch of originals and a bunch of knockoffs. And we probably should warn you that if you get a knockoff, do not be surprised if the software available does not work for it. Yeah.
Did you end up in the manual linking a Mini Pro?
No, actually, I didn't at all.
Oh, you may want to.
I probably should revise that for that as well. Yeah.
I have a link. I'll get you the link because I just had David buy one, and he ended up getting the original. And indeed, the software, the copycat software, did not work. He had to actually download the original software. So that was a good sign.
So for a programmer, and they're inexpensive too. So if you're ever going to program any more than even a handful of EEPROMs, you might as well go buy Mini Pro.
Yeah, buy
because they're inexpensive. You buy them on Amazon, different places, but you
can
want
dump
to try
your
to
own
get
ROMs
original
as
one.
well. Even though you can dump the ROMs in the C64 mode as well, but that's, you know, yes, you can do that, and that
Right.
works, but that's a little bit more work.
But you can't program them from 664.
Right, you can't.
Yeah.
So let's see. I've put in so far all of the sockets, all of the pin headers, and the reason the sockets I had to get. So just to give you, I don't like running out of components, so I bought a few sockets.
Okay.
That is a minimum of 100 per type. And I don't like running out of those things, so I'll never run out of those. Never say never. I then put in the connectors, the 3 DINs, the cartridge connector, and the 2 joystick connectors.
Yep.
The DB9s. I then put in the headers. Jim had kindly, is that a set, or had you created that? Is that a set? The header?
It's a set. Yeah, it actually comes with the connector set.
Is it something you sell on the site?
Yeah,
or not?
yeah,
Okay.
it comes with the connectors. So
Okay,
it's a whole
so
set.
that's the so that comes with the connector. So okay, so I put in the pin header. So the pin headers is for the keyboard.
Yep.
For the internal IEC, I haven't spoken about that one yet, or I missed it. The LED and auxiliary, the I/O port.
Yep.
Want to touch on as well. The pot A and pot B control. That's for the 500K. Was it 500K? Yeah, I think 500K variable resistor for mixing the. It's like the pedal. It's basically the pedal for the Messiah card.
Yep.
And the LED, obviously. And then lastly, and it comes with a little jumper, the PAL NTSC switch. So there was a gentleman earlier on, or a person earlier on, that had built the 60 clone board, wouldn't boot up, looked strange. He had to bridge a wire. That's the same on the KU board.
I just
kind of
made it a jumper.
rerouted that to just a jumper.
Yeah,
I think they ran out of tracing methods, because you were able to kind of realign the traces, so we could do it via jumper instead, I think.
Oh no, I redid the whole board. That's my layout. That's not even close to the original.
Yeah, on the original there was no space to do that. They kind of had into a corner.
Yeah, so when I redid this board, like I said originally, I looked at the one that was out there and I tried moving the traces, but that was scanned from the original traces, so the trace widths were all weird. And I guess the KU board's kind of that way as well.
KU board is as weird. So we later we later established that.
Yeah, it wasn't just from the scan.
Had done a great job of replicating a bad board.
Yeah, exactly. It was perfectly bad.
Yeah.
So I ripped all the traces up completely, and then I just ended up ripping the whole board up, and I actually ended up measuring the board out because I wanted to make sure it fit in all the cases. So here's an interesting tidbit. The stock 64 board, the KU board especially, does not fit in the 64C chassis. The holes are different between the 64C and the bread bend. They're not a lot different, but they are different enough. And so I ended up splitting the difference so that it does work in either one of the chassis correctly. I'm very surprised that there was that much difference between the cases, between the 64C and the bread bend, but there is. So I literally just started from scratch and used the KU as a reference. I like the KU layout. I like how the caps are, where they are, and all that stuff. So when I laid out each one of the main parts, I put the caps where they need to go. Obviously the joystick ports got to be perfect where they go. The connectors have got to be in the exact right spot. Then I worked on the VIC part, and so I knew there's a couple of bodges that are done on the KU board for resistors that go across different places and such, and then the problem you're mentioning there with that jumper. So I started with those first and fixed all those problems initially, and then worked around it for the rest of the circuitry on the board. And then I like the trace length. There's impedance matching for a lot of the traces. Actually, most of the traces are impedance matched where it can, and that all minimizes the amount of noise in the board.
Yeah, I think.
I was about to like the voltage regulator for the SID chip, and the VIC. Is it the SID? Just a SID, I think. The 9-volt, 12-volt regulator or 9-volt regulator, however you want to do it, down by your hand down there. I laid that down, instead of sticking up, because I noticed on the 64C that the keyboard's so close that it hits it. So I laid the regulator down instead of having it stand up. And so that was one thing I had done as well.
Oops.
Hey, tell us about the L3 and L5. This the L5 sits here, right by the power.
Yeah, so that's like the original one, but Commodore, for whatever reason, they use a really wimpy. I mean, if you're going to have robust power, you need to have a coil that can handle the current requirement for the board. And so that the one on the left-hand side of your screen right now, the top left corner there, where you'll be soldering next, that particular coil is, I think it's only like 300 milliamp or something like this max. And so I changed that. It's a big beefy one over there because that's the main power for the board that comes in. And then over on the coil there where you're pointing right there, so that coil and the cap next to it, those are actually separated off the bus, and that's an LC circuit that's designed to power just the user port. And if you don't want to have the big coil across there like Joeri's got, you could put a jumper wire across it, and you don't need the cap either. I would highly recommend that you put those parts on the board, because anything that pulsates power, like an EEPROM programmer or a Y modem or a relay switchboard for like the X10 relay board, anything that pulses power is going to zap the power rail on the 64. And by putting this on there, that eliminates that issue, reduces the noise on the port, and lets you can pull up to an amp out of that now successfully. And it's important that you do that. So Joeri was talking a little bit earlier about the test points in the board, and one of the test points for the 5-volt rail is over by the user port and by the keyboard connector as well.
Here.
That is right there. That's was it TP6 or something like that? Yep. That is the 5-volt rail coming from the power connector on the opposite side of the board. So when you look at that, it's going to tell you how good the power is coming through the entire board all the way to that pin, which is critical, because bad power, to the chips, because obviously right below that is, the CIA chip, and then all the discretes are down below that as well, the RAM chips and such. So it's really important, since the 5 volts located so far away from the power connector and the switch and such, that you need to make sure that you've got plenty of power. So the trace width on all the power rails is really, really thick. Commodore didn't do any kind of ground filling really at all on the board. And so this has filled ground planes, and that all makes the ground thicker and more robust, but it also minimizes the amount of noise greatly as a result of that.
So I think, I truly work upside down, and I think it makes it a little bit, it makes it a good variation to what we see with Bruce as well, because Bruce is working from a different end. So that makes it nice to kind of see the board being built up with different components, all hopefully leading to the same result of a working unit.
Sure. So Bruce, how far have you gotten through?
Almost all the resistors.
Wow.
I have to hunt for the numbers. I don't know where they are exactly.
Oh, so are you using the interactive bomb?
Use the interactive bomb.
Oh, well.
That's ideal for that, because it points it to the board. It's live.
Have you seen that, Bruce?
Oh, I have not.
Oh, well, this is like the holy grail that Joeri turned me on to.
Send him the link first before you start talking about it.
It is. It's in the build chat room, your build room. It's if you scroll up, I have 4 links in here, and one of them is the oh, maybe I didn't do that one. I have the image gallery, the bomb guide. Oh, my bad. I thought I had that one in there too.
Yeah, it's one of the most important ones.
Yeah, that was totally my mistake.
Well, while you're cut and pasting that, I'm gonna get the board that we're gonna salvage from.
Ah, okay.
I'm gonna get a couple of salvages out.
Let's see, edit this.
Like going there next.
Whoops.
Put this to the side. Get the
Crap.
salvage board.
So a feature of KiCad, and I use KiCad for this project. I use KiCad quite a bit. I've used Altium in the past for a lot of stuff, but I actually like KiCad It's really nice. It's got a huge parts library, Ultra Librarian, and Mauser and DigiKey all have links to the schematic part and the footprint and the 3D model. So it's kind of hard to go wrong with that. So having that ability in KiCad is really, you get the same thing with Altium, but you actually have to go hunt down, I think, more than KiCad for sure, because it's definitely not an open. It's one of those things like SolidWorks. It's an expensive product. And okay, so I opened this. I'm gonna actually go and open this, and I can share my screen. Maybe. Let's do a share screen.
Well, for those people that cannot stand original boards being dismantled, you're just gonna have to close your eyes, okay? Hopefully you'll sleep well tonight.
The horror, the horror.
It's, you know,
actually, maybe I can do
know.
a.
We're putting in here CR4.
There it is. Okay. All right. So now if I spotlight myself, let's see if this will actually look okay. Add spotlight. So I'll remove spotlight. Okay. Can you see that, Bruce?
Okay, yes, yes.
Okay.
The
So
problem
the neat
is,
thing about
like,
this is that you have the ability here, if I can switch my screen to get to it, actually, where is that? There we go. So if you want to like highlight on a resistor, it shows you over here on the right side where it's located.
very nice.
And then if you go over to the board with your mouse and you click on a part like a VIA or whatever, or 6510 in this case, it shows you in the BOM what it is.
Okay.
So it works both directions. So what resistor you're trying to find, you can like just go over here and say, okay, I need to do like R52, and I'm saying, okay, that's where it is.
Very nice.
Yeah, I was very surprised. I had no idea this existed. And it's a plugin module that somebody created for KiCad. And Joeri's like, hey, you need to do this. I'm like, hey, you're right. This makes life a lot easier. So I was doing the same thing you were doing before. And that's the reason why I created the BOM reference guide with the little checkbox. So
Yeah.
I could go step by step through it and figure out where everything was and then mark it off because I couldn't figure out on the board. I actually cheated. I had KiCad up on another computer and I'd turn around and I'd go and click on the part to figure out where it was. So this was a great substitution for that.
Well, I'm almost through the resistor, so that's
I hope that gets filtered.
42.
So Joeri is actually desoldering with a.
Yeah, I don't like that. What's going on there?
With what?
Oh, is he scavenging parts from the?
No. Close your ears.
Totally.
All
good.
Make a boo-boo.
Close your ears. All the purists are like, no.
There we go. R42.
So Joeri just salvaged a transformer. Basically, it's a coil that's you can buy brand new if you want to, but you can also do what Joeri's doing
And use that.
Yep.
Instead.
I think it only fits one way.
Yeah, you know, it will. But I'm always wondering why they didn't. Why didn't they?
Well, it'll fit. It'll work either direction.
Yeah, but it will only
fit in the socket one direction,
Yeah.
one way. Yeah, because of where the pins are. Oh, don't bend the pin. Oh, you got solder slag on it.
that may need to go a few times, but there we go.
So Joeri's building this like completely different than anybody else probably
Anybody
would.
else would.
Yeah.
Yeah. Anybody else should probably just start with the low components and then change up. But
Yeah,
you
do
know,
like what Bruce is. He's following the build guide correctly.
That's you know, it just tells you everything.
And so we flip that
Some
board
people
over.
that really appreciate all the hard work that you put in there.
Dude,
Just
you
like
flip the board
building
over,
by what component I feel doing next.
Right. I mean, I built the first one. I probably just like you, actually, sockets first, and then whatever else there was. I didn't much care. You could.
It's also this is the part I like most, and once I need to start paying attention with the resistors, that I don't like. You know,
That's true. There's no focus required for these parts.
Yeah,
really.
this you can just.
Yeah, just make sure the sockets are upright if you really care about the notch direction, and the connectors only go in one way. You can't put an IEC connector in backwards.
The other piece that I do like reusing is the resistor networks. If you can get them out, you know, in my case, I've got a desoldering station, so that's easy. The resistor networks over all revisions stay the same. IP 1, 2, 3, and 4. So those are easy to reuse. Just they have a little mark on them. They have a little dot. The little dot is pin 1, and the way you can see that on the board is you make sure that I don't knock myself out of Zoom here. See if we can do that. I'll just go here. See, this is a resistor network.
Yep.
See that little square? That's the one. That's where the dot of the resistor network will start.
Yeah, it's a pin 1 indicator.
Yeah. Everything is easy once you know what it is.
True.
First board is the hardest.
Yeah, I built I think 6 of these.
I know, yeah.
Yeah. Yeah. In fact, it's funny is that the board I just showed with the display of the scrolling message and everything, I actually built a couple different types of boards, and I was going to do this board originally, or actually make 2 different options available. And I'm not sure why I did. We chatted about this at one point. I wasn't sure why, but if you look, this board actually, this version has the 8701 and none of the regular components. And I think it had to do with the fact that the 8701 ended up costing more than all the other discrete components combined or something like that. And I think from the nostalgia point, it's having a full, you know, chassis of parts looks better than an empty space. So I think that's all it was on this one, different wise. Oh, let's talk about the voltage regulator.
Oh yeah, that's a special one on there.
Yeah, so one of the things that I had found is that Commodore used a bridge rectifier that was a pretty small package, and it really was only designed to handle like 1 amp max. And so you look at how much the board uses. So the stock 64 board uses about 750 milliamps or so when you look on a current meter, and the ICS 64 uses about 600 and I don't know, like 80 or something. It's a little bit less. It's a little more efficient. I don't know why, but maybe because of probably because the power and ground rails are better. So it uses a little less. But I didn't like, you couldn't get that size package really anymore and new. And I wanted to be able to have this something you could build brand new or as used. And so there was no possibility for doing brand new. I want a little bit better current. So instead of using just a single package bridge rectifier, I split it into a traditional full wave bridge rectifier using 4 diodes. And the diodes have got big separation between them, and you can use a bigger diodes. And I actually use, I think the BOM calls for 2 amp diodes, and you can actually get 3 amp diodes fit in the same slot if you want. So you can have a lot more current capability for your board if you want to. But I also designed it so that instead of using a standard 7805 stand-up regulator with a heatsink, you could also use a plug-in solution that's solid state. So it's a switching regulator instead of being a LDO type. And to do that, you had to reverse the direction of the pen out because they were backwards for whatever reason. So I ended up making it so it accepts either the 7805 or one of these stand-up little thing. This is one's made by CUI, I believe this one is. They're also made by what's the other company, Joeri, that makes them that you use on yours? Do you recall? Maybe let's see, CUI.
I'm using the is it the Recom?
Oh, that's it. Yeah, Recom. Thank you, Bruce. Yeah,
Yep,
so Recom makes
DC,
it.
I don't know if you can see that.
Hang on, let me spotlight you back in here. Okay. Yep.
Little replaces the TO22. It's a larger package. It looks like about two of them stacked together on a plastic package, but it's much more efficient than the old linear 7805s.
Yeah, and it requires no heat sink.
Exactly.
So, which is nice. There's no heat generated from that particular part. It works really well. I was using some really inexpensive, like 75-cent versions that we got out of China, and they do not work. So if you find those on eBay and stuff, now Joeri found a version of it that does work correctly, but the ones I found are horrible. They're disaster. They don't even. They're probably good for maybe 200 milliamps because they were stressed on just a boot up a regular 64, so they did not work. But using one of those packages like Bruce just showed makes a even cleaner video because you're going to have less, dropout issues and no heat. That was my biggest thing, was no heat sink required, and much easier for installation. But to put that package in the ICX64 board, the pen out's backwards from a 7805. So I had to make another set of pens on there to be able to insert that in there and have space. So you have the option to build it either way, the original or with like this.
Okay.
So again, this wasn't like an overnight thing. This was like many design iterations before a board was spun. Like we've talked about, we meet every weekend basically, and we do progress reports on everybody's little projects, and then we have group feedback. And so this was over a course of, well, I put it this way, I designed it in August of last year, and I started shipping these, what, a month ago, maybe?
Yeah, something like that.
Yeah, so maybe like it took a year finally to finally say no more, no more feature creep, and then finally get it out. So it's there's a lot of thought went into a lot of these little things that we find in here. It was a fun project though. I enjoyed it.
This was fun. This was good. It's good to kind of see, how far, because you can go all crazy, or you can kind of make it what will be a sensible mix that allows still some further hacking.
Well, this is what I'm planning on putting on here these are, I don't know if you can see this.
Yep.
Oh, nice.
Oh yeah, the low profile ZIFs.
They're made by Aries, and I swear by them. They are awesome. Now, I don't know. I'm going to have to test it out, but I may have to, some of the...
you know what I do on those? I flip them backwards, even though it's got...
Exact, yeah, the 0.1 microfarads I'm probably going to have to put on the back of the board. But
well, you can do that, or I flip the socket around, because I don't really care about orientation, and I just flip the socket around so that the latch is in the bottom of it.
Oh, okay, I see what you're saying. Ah, good point.
Yep, because it doesn't matter, because you know where you're putting the chip in there.
Right.
Yeah, just like that. So I actually built a board this way as well.
Interesting.
It's in the other room, and all of my 1541 disk drives have those, every one of them. And I've got a 64 here, so I'm a firm believer in those low profile sockets. Did you get those through Jameco?
Yeah, Jameco.
Yep.
Now, if anybody's thinking of ordering them, they only have maybe 50 on hand of the 40 pin and the 28 pin. So if you want them, get them quick because they may not last. And who knows how long these parts will last.
Right. Well, I think that's a pretty common part, though, still for some boards. But that's a great solution.
I'm really worried about the state of through-hole components with all this whole part shortage going on. That
yeah, you wonder how much is being
will
made.
just figure, oh, it's not worth it. We'll have to focus on SMD from now on, and it'll be really tough for the beginning hobbyist to.
So the difference with that socket that Bruce had, it's low profile, and a standard socket for zip socket looks like this, and you can see how tall that is. It's huge. And so they've got 40 pin versions and 8 and 28 pin versions as well of this. They have other, like, I think they've got 64 pin. They've got the one that'll work with the 68,000 and all that. And so it's the low profile is super nice because you don't have a huge clearance in the 64 because the keyboard sits over top of it. So you don't want to have things sticking out of the board too far. Like some of these PLA replacements that are really tall, they end up hitting the keyboard. And so you got to be aware of that. So this is my little retro repair station that I developed. So that's a pretty cool little box.
Which one is this? 2.7.
So it looks like Joeri had to go to the acquisition department.
I do, yeah. It's the local acquisition department. I just, you know, I get salvage crazy now. If this one of these boards has got to go, then, you know, I like make sure next it out. It's kind of like you go to the junkyard, and
the salvage yard.
Like I might as well get the remaining components.
Oh, right. Yeah, if you once you start it, you're kind of committed.
Right, and you get kind of like trigger happy on the missile. But that's my biggest issue is just boards. I definitely need more boards. I think Jim Happel was going to send me 2 boards, so that I'm only 2 boards short.
Gotcha.
Because those are already in projects. There's never enough boards on those. And the problem has been that I typically repair the board, and that's been too successful, frankly. That venture should have not been as successful, because then you're like, okay, now I'm going to replace a working board
with a working board
where it's yet to be determined.
Yeah. So everybody's watching this video, even if it's like 10 years from now, if you got a board that's bad and you can't fix it or something, Joeri could probably use it. So reach out to him.
Exactly. 10 years from now, they're gonna start sending me boards. Okay. That's good.
So as far as space is concerned, that's one of the things I liked about the KU board is it was really large. It's actually larger than the regular 64 board is as far as height wise.
Right.
And it's very spacious. And I was pretty good about actually moving things apart from each other and tried to make everything as symmetrical as possible. I'm kind of like into that kind of thing. So all the chips are exactly lined up, and I want as much space between the components as possible, like the resistors and such, so that it makes it easier to solder and easy to insert the part into the board in the first place.
Now, what did Tony say? He did send me a message on what he was going to do, because if I wasn't going to put this in a socket. Let me see.
So Michael and our clients, like anybody, or no, it was Zippy Zap, who was on Lemon. Did anybody find a supplier for the power switch? Yeah, we did. So we'll have power switches.
Yes, power switches we coming out of the wazoo.
Yeah, we're gonna have power switches
God, I
available.
wish I had consulted you before I pressed buy on those.
So Yuri and I end up contacting the same supplier and buying the same amount for the same amount of money. We both negotiated the exact same deal.
Oh my goodness. Unbelievable. Well, those are for sure will never run out. If I run out of those, then
yeah,
that'd be an issue. Right. It turns out he wants a power board, so
okay.
That one is not going to go in. That's going to stay here. That's so I need a 17.
What are you going to put in it? Are you going to solder? Or are you going to put a crystal or a socket in there?
I'm undecided. I think I put in a socket in. Let me put.
Yeah, I think that's a better way to go. So I designed this board so you could actually use a lay down crystal or a stand up crystal, but you can also put in a socket. And the socket's made by taking the easiest way to do it is to take a machine tooled socket and then just clip off 3 pins and pull the center pin out, or the center pin or center 2 pins, whatever fits in that.
Two pin.
It's 2 pin. Yeah. So whatever fits in there, and then you solder the socket in place, and then you just simply plug the crystal in.
Yeah.
And you can do a horizontal mount or a vertical mount, however you want to do it. If you do the lay down style crystal, then you want to probably put the socket on its side, bend the leads and put them in the holes so it all lays down. I actually use the vertical mount crystals, the short stubby ones, for my boards, and the sockets vertically mounted.
And if you're gonna salvage like I just did, so let's say you salvage, they'll typically come with 3 pins.
Right.
I think you'll. Am I focused? You're focused.
Hang on a second. Let me pull the spotlight for you. There you go.
You got the 3-pin one. This used to be a 3-pin. The middle one is ground. So what you do is you just cut it short. Just cut it short. And then if you really want to be like super gung-ho about it, what you'll see on the board here, you see this extra piece of copper. What you can do is you can put just a little lead on it or a little tip of solder and then just ground that. There's no need for it. It won't make any difference. But if you feel you want to, you can.
Yeah, you know what? I recommend you do it only if you're messing with your board, because I've seen cases where you drop something on your board and it shifts the crystal and breaks the lead off.
Right. You want to be careful with that. Yeah.
So if you solder that across it, there's no way the crystal's moving, no matter what.
Yeah.
So if you put a socket in that, like I said, you can do either a right angled socket and then plug that crystal straight in as a lay down, or do the vertical version of it. But usually in the vertical version,
the stubbies aren't. If you have a stubby, you can just have it point up there.
Yeah.
Let's see. Where was I? Where am I? Where is it?
I'm gonna go back to the Discord here and see what people are saying. Is ROM switching handled by the microcontroller? How do you change banks? Yes, it is handled by the microcontroller, and everything on the board, from the reset to the programming, ROM selection, is handled by the restore key. That's it. So if you tap the restore key, you'll actually see a little asterisk appear on the display, and the LED will change color to let you know you're touching the restore key. If you hold the restore key for 2 seconds, I think it's 1.75 seconds, and the LED will change to a different color to let you know you're in reset mode. And if you release the restore key at that point, the 64 will reset. And if you were to continue holding it down instead of resetting it, the LED will change color again when you're in ROM swap mode. And then if you release the restore key at that point, it will reset the computer with the next ROM in your bank automatically. And if you were to hold the restore key down for 10 seconds total, it goes into the menu for programming the board. And in the board programming, you can program like the LED colors and what the status LEDs are for. You can change the order of them and all kinds of things you can change in that. If you really want to get carried away, you can plug in an FTDI USB to serial interface into the programming port on the board. And I've got PC software, and you can literally control everything, including the matrix, what the scroll text says. I built a whole script language for it that you can do flashing and change the brightness of things. And I got a little carried away on that. Not that you'd ever probably use it, but to me, it's kind of funny because on my clear 64C case, I made 3D mounts to mount that display inside of the plastic lid. So it actually will fit in there perfectly in the top of the 64C, shining through, and you can do messages and stuff. So that's kind of one of those Saj things. Saj is like, that would be cool to have on my computer. So another thing of feature creep that we end up doing, supporting the matrix. So it all works.
And if you don't have one of those new cases, just start, dremeling in the existing one.
True. So I found out talking with people yesterday on the Discord that apparently Pixel Wizard is not doing any more of the 64C cases that iComp is, and they're not available currently. So that was interesting. I'm not sure what's going on there. I mean, they have the molds, so I think maybe it's a transition period or something with iComp or something. But those are great cases. So if you need a 64C case, it's the only place you can get a new one is through them, and the clear especially is really cool.
Yeah, that's a bit of a pity, really.
Yeah, I was
Let's
very
see,
surprised
what is
that we couldn't get it.
Nice switch.
So somebody asked us, well, can you do a buy it now button and just put the all components into my DigiKey shopping cart? Actually, I need to do that. I didn't realize it was even available as an option, because usually when I order parts, I'm ordering all kinds of parts for different projects and stuff. So I don't pay attention to these projects that you can actually put together. Mouser has it and DigiKey has it. So literally we could put all the parts out of that bomb that I've got into a cart, and then I can share that cart and would automatically add all the parts to the project into your shopping cart on DigiKey or Mouser. So, and then you could go back and you can delete what you didn't need or something.
Now he says that.
Yeah. So I need to do that. I didn't realize you could do that. And somebody had emailed me and said, hey, why don't you do this? I'm like, because I didn't know. I don't order parts that way. I don't order for a project because I literally am ordering, dozens of parts for different things at a time. So I just found out. So I'll do that. Kind of like finding out the thing that Joeri showed me with the interactive bomb. I didn't know they could do that.
That's a great suggestion. Yeah, whoever made that, kudos.
So Commodore Man wants to know, do I get my free pizza for watching now, or just
free
after
pizza?
You finish? Yeah.
Hey, Commodore Man, where is my pizza? I thought you were ordering.
Somebody said something about pizza.
See, 2 pizzas, one in Canada land.
SX64 Man asked a question. I missed this maybe. Is there a header or a solder point to get A5, A8, and IO1 and IO2 for stereo SID setups? So what I did with this is that if you take a look at the RF can, the RF part of the board where the modulator normally goes, what I did was, in fact, I'll switch screens and I can show you on my board here. Add the spotlight. Pull Joeri off for a second. So the RF module assembly here, if I get this to focus, the RF modulator, and you can see that I upgraded the RF. Basically, it's level. Well, it's buffered and filtered, so it's got a bandpass filter and stuff, and an amplifier for this. Come on, focus. Next to it, over here, you'll see a 3-pin plug, and there's a letter L and a pad below that. So this is the audio output, and so the right channel is the normal output from the SID, and then the L is connected to the pad. And so you can put in a 3-pin header to like a 3.5 millimeter stereo jack. And they actually sell these on eBay and Amazon. I probably should have them as well. So you can plug that in and you can run it out to your stereo speakers. To run stereo SID, you simply run the second SID output to that L pad. You solder a wire across to it. And that makes you a very convenient way of getting the audio out of your computer in stereo. Pop it in. That's
Okay.
so yeah, I don't know if the MOS chips run any cooler because they've got good power, or if they run hotter because they got good power. I've never really paid attention to that. The only thing I wanted to get rid of for heat wise was the 7805 voltage regulator, because that's notoriously hot and burns you, you know. So I wanted to have that option to replace that. Let's add Bruce back in here.
This thing's gonna look like new.
Nice. Yeah, thanks SX64 man. Yeah, it's a pretty cool board. You know, I wanted to something that was a daily driver, and that's a funny thing too for Joeri. Every time Joeri turns around, he's got a different board he's trying to use, and sometimes that's okay. He's like, oh, finally, I got something to fix. You know, so I'm hoping that people will have a board that can rely on literally every day for everyday driver. And I use it for testing everything that I produce. So every Y modem that's shipped from here is tested on the ICS64 board. What else do I test on here? That and I have some PLAs to replace like Joeri has. But everything that's associated with 64, and for development wise, I use it as well for developing stuff, like the Y modem 2 thing that freaked people out. I guess I forgot I hadn't told anybody about this yet. So my Y modem 2 is the actual product that's been done for a while, but I've just been so busy with my day job actually. And so for a lot of us at CRX, David Yao and myself and some other people, this particular time of the year is presentation, contract and renegotiation. It's the government's fiscal year, you know, that's so you have to go back and renegotiate everything you're doing. So it's a really busy time for us. So it's one of the worst times we could probably have CRX, but it's a nice distraction from what you're having to get done anyway. So it is what it is. We work through it. So I've got a bunch of different projects. So in my Discord, I have my own Discord for cbmstuff.com, and I have it linked, I think, in, oh, maybe I don't. I'll have to link it. So in my Discord, I have pictures and information about, I'd say probably maybe 75%, maybe a little less than that, of the projects that I'm either working on currently or finished. And there's a bunch that are finished in there that just haven't been produced. And so there's information in there about those, along with pictures and stuff. Like, for example, I've got the micro drive. I'll be finally getting it done and out to everybody. So I actually have plastic injection molded cases sitting here. So I have a bunch of costs wrapped up into this. This is the SX64 color scheme. You can see it's a nice little gray and the black, and there's a production boards. So I actually have things together that I need to do. That and let's see, the retro repair station, which is a chip tester. So it's got a nice TFT display, and it does chip testing, and it's got an oscilloscope, and all information is all in my Discord about it. And then this is the Y modem 2, which is with the little expansion module for it. So this has composite video output and 64 emulation actually in it that runs as fast as the 64 if you want to output. And it'll use the 64 keyboard and the ports for it if you want. It's got an SD card now, so you can have a limited amount of storage. And it's got Bluetooth now, so you can stream MPEG or MP3 files right to your 64 if you wanted to, and play it. So there's all kinds of things this thing will do, and the information is also in the Discord. Literally XIA pictures and such. So there's a ton of projects that I've worked on that are literally they're done. The boards are finished, ready for production. And what else? I did something. Oh, I did. This is a SCSI interface. It's a SCSI emulator. It's called Retro SCSI. This probably won't focus. Maybe it will. And so basically, it replaces the SCSI hard drive, like in your CMD HD40. So that's done. I've got another. It's a cartridge. This basically emulates to 6510, the 4 megahertz accelerator, and that's almost done. So there's all kinds of projects that I've got the problem, and Joeri can attest to this, that I get to a point of something and I get it to work, and then I lose interest in it because the challenge is over. Can you do it? Like, yeah, I can do it. So, why bother? Or, I don't really need it for myself. Things that I need for myself, they get done immediately because I have to have them for development purposes or whatever. Isn't that right, Joeri?
Yes.
Yes.
That's why we sometimes need to crack the whip to get certain things done.
Yep.
There's only so much you can do, and there's too many projects indeed. Like you said, it's almost like a challenge. It's just a challenge. Can I do it? And once you get to the proof of concept point and it's proven, okay, I can do this, and you kind of move on almost. You want to move on and kind of try something else. It's hard to kind of then bring it completely to finish. But lately, you've been working some projects in parallel that are getting close to completion. So that's good.
And a lot of things that I build end up being because I need something else. Like I have to build something in order to finish something else. And so those are the kind of the strain projects. I don't know why it happens that way, but like I needed to build the chip tester, the retro repair station. I really needed to build that to test the CIA chips. That's kind of how the whole thing started. And then, actually the VIA, really, because for the arcade guys. So the arcade stand-up community is really big. And as Joeri knows, he's an arcade guy. And having some kind of a portable, handheld testing unit that you can actually hold in your hand while you're inside of a cabinet is better than having a laptop trying to cram yourself in with it and some kind of a testing device. And so that really, in the focus on doing this XIA project, I needed a means to do debugging and testing of something, of the chip itself. And so that's how that one project, spawned another out of sheer necessity. And so those are the projects that are kind of weird to me. I don't expect to ever make things. There's a few projects, even the ICS64 board, that was kind of wasn't really a challenge, but it's something I needed. I needed a good, solid, reliable, everyday board I can use for testing of products. And with that, when you've got a problem with it, something won't boot, is it what you built doesn't boot the computer, or is it the computer itself? And so,
yeah, and this provided for some simple test points as well, that for product development can very quickly kind of tell you or point you to where to perhaps look at some resolution.
Right. So if you got like your voltage drop somewhere on the board,
right,
like the user port or something, you're like, okay, well, definitely a problem there.
Right.
Yeah,
I'm doing some extra work right now. The DB9 connectors that come with this, and you may want to look into that. If you have to reuse the bracket. So let's say you want to reuse the bracket. This bracket, that won't work because obviously the DB9 connect holders,
they should unscrew. Yeah,
they won't go through.
You should unscrew though.
If you unscrew those, this whole plate comes loose. So what you do is you put in screws with the same diameter.
Yeah, you can do that. What I did with mine is I actually put a drop of CA on them.
Yeah, that works as well.
Yep. Or if you want to go old school, because Commodore's original ones didn't have a metal shield around it, you just pull the shield off.
Yeah, you take them out. You can do that as well.
Yeah.
In this case, because I've got the other board, I'm going to pull them out. I'm going to pull the original ones in. I'm going to go the long way.
Oh, really?
Yeah. Might as well.
Well,
it's kind of like a bonus route.
Okay. Yeah, I was
CA
aware
glue
of that.
will be a great solution, or just put in some screws.
What I probably should do is just pull those out and then CA them, ship them that way.
You could do that, or just put 4 screws in, whatever is the easiest for you as well, obviously.
Well, I mean, the drop of CA and the pull on the shield is easy. I mean, the screws pop right out. I mean, those set screws. Yeah, you're right. Nobody's going to be screwing anything into it because it's a joystick connector, goes plugs into there.
Right.
But yeah, I looked at that originally, and I had one fall off, and I thought, well, that's kind of cool because now it's black plastic. It looks just like the original.
Right.
So, like on my board, like you remember when I first did this, I had one long stock one, and I had one short one in there. And I actually did, I think, the pictures of that way because you could mix and match if you wanted to. They look the same coming out of the porthole, so it doesn't really matter.
Well, and here's, since I'm taking that other board apart anyways, you know, it's easy enough to pull the connector out.
Getting the solder out of the big holes is going to be a task, I think.
Yeah, we'll see soon enough, eh? It's all live. Everything is happening live. There's no way to trick. There's no way to trick. So
yeah, to see if both sides get soldered. So it's a 4:19 our time, and we're about 19 minutes over what we expected. Basically, we're going to have a talk about. Well, that's my fault. We started like, as Joeri would say, way late.
say that.
Yeah, he said he sent me a message. He said, "Okay, you lovebirds, wrap it up."
That's true.
So I'm like, "Oh, okay." We started late in this whole process, so we started like a half hour late on this project anyway. But we can talk about the CRX stuff. I'm not sure how much longer you want to.
Yeah, no, I'm fine. We can drop this. I think people get a good flavor of what the process looks like. I would pull out. I think Bruce and I will just continue, but we're probably going to switch to public video chat. Is that what you?
No, actually, no. We're supposed to do it here. You and I and David and Saj, whoever wants to jump in from our little crew. We're going to talk about. Yes, this is what we're going to do. Basically, we jump in.
Then I'll just better put myself on mute and let's see what the rest is. And by all means.
Okay. Well, you need to be on this. You can't be on mute because you're a big part of this as well. So, if the guys are from CRX crew, you guys could jump on the Zoom. We could have a nice little. Oh, David's back. Okay, so I'm going to send out an admin to everybody. A note. Admin. Anyone who would like to join the Zoom, please do. So we've come a long ways here with the online virtual event. We learned that Discord's great for intercommunications with our little group for running the show in the background, and have a link. Oh, let's see. Do we pin the link for
it? Was pinned, yeah, but someone will need to read it again because.
Okay.
Of course. You're gonna get panic. How did we do this?
Yeah. Okay. It was pinned in the panic room.
We got the panic room.
Yep.
Never seen it. It wasn't there.
So yeah, it's the group of guys that basically run CRX. It's all of us. It's not just like me or anybody in particular. That I put together the event, and all these guys basically can make it run. Without them, there'd be no way we could do this. So we have a Discord with permission set for all of us, and we have the CRX. Like last year was 2020, but this year is 2021. The panic room, and when everything goes awry, people post in that, and we can see everything that's going bad. Like you don't have video, you don't have audio, Joeri's not spotlighted. I mean, whatever problems going on, it's the production of the events going on in the background. So it's actually, to me, that's one of the most enjoyable aspects of this whole thing is the putting this on and try to put out the fires in real time. And it's been quite a bit of fun. So we have a Discord room that's called, we don't have it this year. We need to put it in there. I thought we had a suggestions room for the event suggestions. Oh, we do. Event
I
room
do
suggestions.
remember
Well, that's
seeing
just
it,
for the
yeah.
rooms. That's just for the rooms, though. I actually go ahead and post it in there. If you've got any kind of comments about the event, good, bad, or indifferent, especially bad, I think I'd like to know more of those than anything. Post in that room and let us know what could have been done better, what maybe you expected you didn't see, or anything like that at all would be really helpful for us, because we look at honestly, we look at the comments that are bad better than the ones that are good for us. And oh, what is this one? That's true. Okay, so if you post in there, then we will know. Oh, Chris is here. Chuck is here. So guys, go ahead and unmute yourselves. So we like to.
Did you cut the link? The YouTube?
Yeah. No. No, this is actually, we do this publicly. We did it last year publicly as well. Okay. So that's the thing. We like to try to be open and honest about what's going on in the event, and this kind of helps us, figure out what we're going to do for next year. I think because we've got this nailed now, it's probably going to make COVID run away, and we'll all meet together and won't have to know this stuff really. But I think we should always have some kind of a virtual component for any of our future events anyway. So people can have like an update on the show, maybe just even a webcam that's like posted in a couple of corners of the room or something. Somebody walks around the room and does stuff. That'd be a really, helpful for us. So we got Chuck and we've got Chris, and maybe we get David down here as well. Oh, what was it? This link? Oh, from my Discord. Okay, it was posted. Michael did that for me. Great, appreciate that. So guys, are you there? Chris, Chuck?
I'm here.
Yeah,
can you hear me?
All right. Yep. So overall, good, bad, and I mean, we heard great comments. One thing that was good for sure was the presenters. The people we had were great.
Except for me.
No, you were great too, Chuck.
What?
Yeah, no. Chris was good. Chuck was good. They're all good. All our guys are great. But other people that came in that really surprised us. I think every year we get a surprise. So I think a lot of people could agree. I mean, Saj, obviously, he always stuns us with what he does.
Oh
with
man, that was amazing.
Yep.
Yeah, it was nuts. Oh, speaking of that, here's the man himself. Saj is chiming in.
Hey, what's up?
What's up? We're just giving you some kudos. So, and David Dowd's in now as well. So, yeah, Saj, I mean, you always, it's over the top. But for me, we have new presenters. And I think that Douglas Compton, in his presentation on the productivity software, was excellent and very surprising in a way. It was excellent. I've not watched his YouTube channels, and I took a peek a couple of things, and that's the way he always is. So who knew? I didn't have any clue. But I get people that contact me about, hey, I like to, do something for your show. I'm like, okay, great, that's awesome. And sometimes you might get somebody who's bad. I don't know, but we lucked out. We always luck out, I think, with our presenters. So I guess just go around the room and guys give your thoughts. Yeah, Chuck.
Joeri's still spotlighted on the stream.
Oh, you're absolutely
We're just looking
right.
at the top of his head.
Joeri, looking good there, buddy. Okay, there we go. So yeah, Chuck, what do you think? Now that you're drinking.
Good show, yeah. Last year I wasn't involved. I was just a spectator. But last year was a lot of fun. This year's a lot of fun.
So how do we rope you into that for this year?
I ran into a bunch of guys at VCF West.
Gotcha. Okay. Oh, that's right. Yeah, Joeri and those guys. Yeah. Yeah. And Chris.
Well, Chuck's edition was just absolutely awesome. I was just absolutely if I couldn't be glued watching my driving, then I was glued listening. It was absolutely fabulous that the information.
Keep your eyes on the road.
Got. So yeah. I would like to see a little countdown timer before the events start. I think that'd be kind of cool.
Like as far on the website, you mean?
Yeah, because I was listening through YouTube.
Gotcha.
And it would be nice, before the event start, it'd be pretty cool if like an hour before or a couple hours before, have a little countdown, whatever you're going to start up the pre-show.
Oh, I'm thinking that's going to be assigned to Chuck. And the
That's
reason
Chuck's.
being is that there's a program that comes with the pet when you get the pet. And one side of the cassette tape is called Squiggle, and the other one's called Big Time.
Big time, yeah.
Yep. And so we could turn that program into
That would be awesome.
the countdown
Yeah.
timer for
Yeah.
us.
Yep.
Yeah.
Yep. Big time
Yeah.
will do it.
Yep.
Yeah, see, I was really disappointed that I wasn't able to get the other part of my the assembly side of things in. You know, a lot of this is just the last minute that I got caught up in, and man, so that'll never happen again. If you know,
Yeah, unfortunately,
I'll have this ready weeks before. So yeah, it was kind of difficult because it was just, you know,
and a work conflict.
Dropped. Yeah, so I ended up having to work and scramble to try to get things done. So
right.
And this particular unit, I was surprised because it was something that turned out to be a little bit different than I was used to, and so it had its challenges.
Yeah.
You know, it just added to it. But
right.
you know, the show this is definitely the best one that we've had. You know, it's just awesome. The content, you know, we were just packed with stuff going.
What was the peak viewership on the stream? Do we know?
I don't know if we could ever figure that out. Somebody figured it out last year, what we did on some kind of media platform. I'm not sure how they did it. We'll have to look into it and see. I do know that the number of views for this year already is more than half we had all of last year. So
more than half of what we had
for the entire year.
Oh,
people restreaming it and viewing it. So
that's nice.
In 3 days, we've already exceeded that. So that's good, I guess. Yeah. So I expect over the next year we'll have, you know, double of whatever we've got now, at least, maybe more.
Well, you know, maybe we'll be able to have somebody who has a project that they want, and they'll contact us and say, hey, you know, I'd like to show something and not show how I do it. That'd be cool.
Yeah. So David Yout always brings something unique to the table. A few years ago, we had the Orchestra in live thing. Now we've got Runic, and last year, what'd you do last year?
The chiptune sack.
Oh yeah, chiptune sack. Yeah, duh. Yeah. So I mean, every year you've got something that's like over the top.
Awesome.
So
awesome.
When we do come back live, a live event, you got anything planned for the live event that's gonna blow us away? That you can talk about? Okay.
No, I don't.
All right.
But one of the things I think works well at the live event is the hardware projects. And I'm sure we can rope Dr. Knapp into helping organize one of those again.
Yes.
But I was under the impression that the participation was lower this year than last year, but I thought the talks were even stronger this year than last year. So that made it cozy. But I had far less time to help this year. Saj must have sensed that vacuum because he stepped up massively on all kinds of things. And again, I loved the Forrest tribute. That was very good.
Thank you.
Yeah.
Yeah.
Awesome.
I mean, I think I'm busy, but I know you were busy, yet you still pulled all this stuff off. So thank you very much.
Yeah.
Good show.
Yeah.
That was excellent.
Oh.
Saj, what do you think, man?
Yeah, everything was great this year. I was right before the show, I was kind of struggling with my internet connection. So
yes, we know.
I at the end just bailed on the whole idea and went to Electric Gypsy's studio and just I'm doing it from here. And so yeah, that's still in a work in progress. But as far as the format, yeah, the presenters, the content this year was so good. I really enjoyed it a lot. I'm gonna be ready to become a new pet owner again. So I like Chuck's video presentation very much because I learned a lot from the pets. I didn't know a lot of that info, so that was really helpful. And yeah, what I do like Joeri's idea of maybe doing a hardware segment for audio. So like maybe the Amiga sampler. So it'd be cool to do like hardware stuff in the audio realm of things. So I think that Amiga sampler is an awesome idea. So that'd be really cool.
I think our hardware project that we had a few years ago, that was great, because I like interactive things, and the way that it was all set up with you guys, and I have people that were there at the event. They know that. So we built this project called the CRX Saver, and it was a project that David did, and I made some plexiglass cases for these things. Brought some trays in, and we all brought soldering stations in, and everybody built this CRX Saver. And it was a device that plugs into your 64 and plugs into your power supply, and it basically saves your 64. So if your power supply has a tizzy and wants to kill your computer, this will intercept that and fix it. So it's a very practical, build that we did. But to me, it was kind of hysterical. I don't know. Do we have any pictures of
Yeah, I was just thinking, I don't have one within arm's reach of my desk. I can't believe it. I have one in the other room. I'll go dig one out before you get off this thought. It's been funny. Twice now I've seen on social media, one of the pictures of one of those appear, and people are like, what is the hell is this? They have no idea because it's this artifact outside of the context that birthed it. So yeah, we had to have those for the Orchestrion. So it was a natural hardware project.
Right, you couldn't afford to have a 64 die in the middle of your world record. Yeah. So
I think I'll be back.
Yeah, the picture he was going to dig up. So we set up soldering stations with these plastic trays because we didn't want to damage the cloth. So we're in a hotel casino. It's a ballroom, and so they bring in these really nice tables with these tablecloths and all this stuff for us. So we can't solder directly on the tablecloth, really, and damage the tablecloth. So we have these little plastic trays, and so the pictures are pretty funny, actually. Everybody's sitting there and soldering all these little things, and it was a great. It was a lot of fun, actually. It was a really good, fun, interactive experience with all of us. And that we wanted to do a hardware build this year, and what I wanted to do was a 5 1/4 inch and 3 1/2 inch floppy disk cleaner that was automated with an Arduino board. So we do 3D print the stand that the disk would slide into, and the component that screwed into the hub of the disk. And then there was a wiper arm that would clean the disk, and the stepper motor would rotate the disk. And it was a really neat project. It was pretty simple from a soldering standpoint, a few wires here and there and stuff. And it was more of a hands-on, putting screws and things. The problem was this year, because of the chip shortage, and the problem with fake Arduino boards, we couldn't reliably get enough boards to build a hardware project for it. So we'll probably end up doing that in one of these. I imagine maybe next year, along with maybe another one or two. They seem to be very popular. The hardware build projects were. They were popular with us for sure, because it was
they're great.
It was a fun time for all of us to laugh and. So
okay, I have one right here. I assume if I talk, I'll get
oh god, there you go.
So there's
yep.
There'd be, and let me get this in close to the camera. Oh, good, the camera's
really complexity
nice.
There.
Yep. Yeah, so I have a industrial laser cutter, and so I cut the little cases for it. They sent me the diagram for it, and I cut them, and then we got there. We put all pieces together for the first time. They turned out amazing. It's beautiful.
They're great.
Nice.
Yeah, my contribution to this was like this big. This is mostly Dr. Knapp's doing. Yeah, when Jim Brain was apologizing for his bunny slope talk, I was thinking, this is perfect. Because I'm hardware dumb, so yeah.
So, Joeri, you got any comments at all? I know you're busy. You're heading a soldering iron, and you've got goggles on, and
he's doing surgery.
Yeah, you're doing surgery.
I thought it was great. I thought it was nice to have some new names. Chuck, a lot of thanks for all your help outside in the prep as well. You've been like jumping in. You're brand new to all of this. We just met at VCF West. That was great, and you just thank you very much. And there's so much more that we can learn from you.
Oh, you're welcome.
I think Saj, it's so nice that we get thanks from the people that you wrote into to perform. That was cool. because you gave a podium to them. We got to enjoy their incredible skills, and then they were happy that they found people that enjoyed their skills. I thought that's the best combo that you
it's a win-win for everybody, really.
Absolutely, and we should definitely rope them in. There were a couple of more suggestions of people to connect to. Thanks for that as well. People that said, hey,
if anybody has any recommendations of some people they would like to hear play live.
I think that worked really well, and I think the pre-recorded element of that worked well as well, because they got to really showcase all of their abilities in their setup. So that was good. We got a lot more expectation now you're back home there as well, that you've got all of the local talent now so close by. They can't come up with any excuse anymore. I think we had the Friday pretty packed. That's a hard one. For me personally, Friday is a working day. I know for several others of us as well. We really should, if we're not live, we should probably focus more on Saturday, Sunday than Friday, because it's just hard to organize, I guess. That will be my only point of criticism. I think I thank goodness, hallelujah, we went back to Zoom.
Yeah.
Oh, I was getting really nervous about last minute changes on technology. Yes, it's not ideal. Fantastic. If there's anybody that's been watching us and that's in the Discord and that can demonstrate one of the events that they did where they had the piping and all of that fantastically set up, non-experimental, we are all ears. We want to learn.
Yeah.
Don't give us YouTube links and all of that, because man,
we tried them all.
Yeah, and it needs to be kept simple as well. You know, it needs to be something where we can kind of slip in and out. The focus should be on the content, not on the technology surrounding it. That just makes it almost sound like a job otherwise. Now, Chris, we miss you not being live.
Yeah,
I like those glasses, by the way.
Yeah,
You're looking cool, man.
Well, thank you.
But that.
Well, I'm just believe it or not, I am just unloading the truck now, headed home.
See, there you go. There you go.
So I'm looking at the Discord under the event suggestions, and I think the biggest comment here is I can't believe I didn't know about this before. Is it going to be streamed internationally so you can join? There's no awareness. The event is very low as far as people knowing about it. So you should advertise in the ZipZap 64 Mini magazine. I think that's going to be the biggest hurdle. And that was last year as well. But I think moving forward, even for the live event, of course, people coming live, they pretty much know about it, Las Vegas and such. But getting the word out is probably going to be a fundamental thing we're going to have to do.
Yeah. In a different way, not just Facebook, but in print and the blogs as well, whether that's the RGB blog or some of the German blogs, or we're going to have to kind of give that a lot more thought and start much sooner with that.
Sure. So last year I did advertise. I actually put an ad in. One of the guys that makes a retro magazine is on Kickstarter, and it's the 8-bit magazine that he does for all the different 8-bits. And I actually put in full page, I think backside cover, like 2 pages, I think total, about the CRX event. And I didn't do that for this one because we were kind of up in the air about what's going to happen, and the deadline passed for it on the new magazine. So I didn't do it. But I agree, Joeri, we're going to have to look at different avenues besides what we've done, because we can get the word out even more. Because last year we got the same kind of comments too. We didn't know about you until it was too late. So we need to figure out how to do that. Maybe more of a connection internationally. We can get a hold of your Dutch people, and they can get on working on the European community for letting people know. But I don't know. I mean, suggestions from anybody about how that can be done would be welcome. And the Zoom issues. So yesterday, I didn't tell you guys this because I was afraid at first. Yesterday, when the stream started and the camera switched off, I couldn't get it to come back, and I actually had to reset Zoom, and it came back magically. So that's one of those things that we're kind of at the mercy of the technology that we use, and So seriously, if somebody knows a better way of doing this, please let us know.
Yeah.
So I'm looking at Adrian's Digital Basement, YouTube channels like the Retro channel, like the 8-Bit Guy, recommended for those people. Yeah, I agree. We probably should reach out to all those people. What ends up happening is that we've got content on Friday, Saturday, and Sunday, and for the last 2 events now that we've done this, we've filled Friday, Saturday, and Sunday, and so we don't have any more people, and we can't really make a week-long event. I don't think that'd be something we could actually do, but we are packed, and so we kind of have to be, fortunately, selective about how people that come in and do it. But we like to have different people all the time, with the exception of like Ray Manta. He's kind of like here permanently with Saj. I think maybe Citrix might be as well, because we talked with Citrix for what, like 4 or 5 hours last night after the event. It was a long time. Yeah, that was fun. So maybe we'll get guys maybe they'll do things for us and permanent basis or whatever. But
well, next year is the 40th anniversary of the 64. We could make it a week-long event. Party on, right? Right, Dave?
Well, I mean, yeah,
we could party on. Yeah,
we could do maybe a nightly event up to the the 3-day event or something, from here to here.
Yeah, maybe
a lighter schedule on the days.
Yeah, exactly. Real life schedule, like maybe just one presenter or something.
Yep.
So
yeah, just something to
I'll break up my
time. Get people getting ready to go, and then everybody meet down there.
Maybe we could interview like Leonard or John Fagan or both, or different people.
Oh, that'd be great. Yeah,
that'd be awesome.
Yeah. So maybe we can twist our arm and do something like that, hopefully. So yeah, we'd like to have a suggestion. So it's important that we get feedback from everybody, because obviously the event's for everybody out there, not for us per se. We have our events every week as it is. So we're kind of spoiled in that regard, with our little group of people.
We just had a suggestion get posted. Post on usenetcomp.sys.cbm.
Does that still exist?
Oh, yeah.
What? No, Usenet. Is Usenet still around? I don't think Usenet's still around. I know it's Google archived it all.
Yeah.
Really? Is there?
Come on, experts. What's the answer? I don't think it's still around.
There's no Comp Sys Amiga still and things like that, is there?
Decoder made the suggestion. He's typing now. Maybe he'll answer this question. I really don't think Usenet's still around.
Oh,
somebody have to Wikipedia that. What can you do, right?
There is a Comp Sys Amiga still.
Well,
it moved to Google Groups.
Oh yeah, no, it's still there. It still gets used as well, and I think Jim Brain is still moderating it.
Oh, there's not a lot of comments in here.
He'll never leave that.
Huh.
Well, isn't there someone also running a 64 server somewhere that tap into?
And on IRC, and there's
IRC.
I think we just we need to continue to work on that. We need to continue that, and that starts with getting a date real early.
There's a good
I think that's the biggest thing, where we just need to say this is going to be the date. It's going to be physical if it's possible, and if it's not, then it's the date for virtual.
Right.
That way you can start planning your holiday months and months ahead.
Right.
I could have had that scheduled off way in advance. Yeah.
Yeah, this uncertainty thing was a downer for sure.
Yeah.
There's a good suggestion. How about the 40th anniversary in Orlando, which would make Saj happy?
Yeah, people all got excited about Orlando.
Or in the front lawn of Westchester, Pennsylvania.
Oh, that'd be cool.
Yeah.
That would be cool.
Or King of Prussia, because that's where a lot of the parts came from.
Too funny.
Yeah, so there's 24,000 users on the Commodore Facebook group. We do know that because that Commodore Facebook group was started by Rodolfo.
Mm-hmm.
And so he actually posts in there all the time about it. So just connect to Usenet via nntp.allo.org.
Didn't somebody make a Usenet client for the 64?
Yeah, Apple did, yeah.
Yeah.
I thought it was our IRC client. I think that was
IRC, yeah, that's what we're talking about.
Okay. Well, I think we
Usenet.
Usenet is text messaging.
Oh, Usenet. Oh no, Usenet is just, you can just mail to that.
Yeah. Somebody wanted to know if we do the this publicly. No.
Right. Any more words of wisdom?
Okay. So, auctions. I didn't even look at them. Did anybody look at the auctions to see if we sold anything?
Yeah, they all sold.
Yes, we did.
Okay,
we did.
I didn't look at the auctions. Let's see. How do you spell eBay?
Well, the links are in the Discord.
There you go. That's why I need to actually look because I don't even
We
know
got
where they are.
$70 for one of those quilts.
Really? Oh, that's good.
Oh, nice. Nice.
And I think the other quilt went for slightly less, $48.
Oh,
wow.
that was steel.
Yeah, I should have bought it for that.
And there were
was steel.
There were
Okay,
two of
so-
those Happel games.
Okay. Yep. Question for you guys. When you chatted with my wife last night, what did you guys talk about with the quilt? Because she wouldn't tell me.
Oh, that's true. We all forgot. What were we talking about?
I don't remember.
We'll never find out now.
Oh,
But a date for next year event will do a lot.
oh wow. Okay. Well, I see how you guys are. Yeah, y'all are my friends, right? Let's see.
Something about a Drew
Yes, we're-
dunking booth. I thought.
Oh,
We're protecting you, Jim. Trust us.
okay. Okay, so they're sold. Okay.
Wide went for 32.
Okay. Yeah. Holy mackerel.
That
So
was steel.
What about those disc notchers?
People love
$52.
them.
$52 for one of those disc notchers.
Wow.
I'm glad I
52
still
and
have-
48.
Wow.
That breaks the record because last year was 46 for a disc notcher I had.
Wow.
You might be able to use that as a proxy for testing how much retro computing is going up in price just by releasing one disk notcher at the same time each year on eBay.
Oh,
It's like the Big Mac's economy index that they use.
right. Nice. Okay. Well, we made some money for a good cause for sure. That's awesome. So next year, I'd like to have a lot more auction stuff. It just, my schedule was crammed too, like everybody else's because of what's going on. So I'm just hoping that we can all have a little less cramming. I was explaining to people, David, you're busy, this time of year. I'm busy this time of year because of the fiscal year and all that. And it's just one of those things that not good timing. And like in your case, your deadlines end up being the same time that CRX was, which is a month later than it was before, right?
Yeah, mine moved.
Followed
to
it.
match. Yeah, but by the end of this upcoming Tuesday, I'm home free.
Oh, that's good.
So, yeah.
Just in time for CRX to be over.
Yeah.
So let's check in on Bruce real quick and see how he's doing on his board.
Next
build.
year, pre-recorded videos need to be submitted 10 days in advance.
Yeah,
Absolutely.
I agree. Hey, Saj, start working.
Okay.
Hey,
So those that don't know, this is
music's
kind of a
little
running joke
different.
with us.
Music's
it's-
a little tough to be way in advance.
Yeah. So Saj, he sent me the last video to set up the scene at 1:26 in the morning before the event started. And so the event started the next morning. So that was already
Yeah.
Friday. So I got
Yeah,
him on
that's
the day that the event started. So
You
that was a
know,
little
these guys,
rough.
these guys are so good they could wing it, and we would never know.
Well, that's what's funny about to me is that I wish that the public had a little bit of insight to the panic room sometimes about all the stuff that's going on. It cracks me up.
The
So,
computer's on fire.
yeah, it's like there's no video, and then the responsive time out of this. I'll tell you what, if we could turn this into some kind of a security operation, we'd be golden. Because when there was no video or no audio, my phone rang and I had text messages instantly besides the Discord. So like John Farrell was calling me, there people were texting me, Chris, you texted me too. No video, no
I pulled
audio.
off to the side of the road and called.
Damn. Put your life in danger, man.
Yeah. Okay, well, I guess we're like 7 minutes away from our normal stop time, so I guess we can stop. But I just want to pull everybody in, get some feedback from the people that are watching. And you know, if you're watching this video 6 months from when the event happened, sorry you missed us. We'll be back again in some capacity next year, whether it's fully virtual, hopefully not, but partially virtual would be great. So you can see what we're doing live events. And
hey, we don't have to pack anything up.
Well, I have to admit that that's one of the things I actually like about the whole thing is that, you know, you're packing all your stuff up. It's great until we have to go home. That tear down part is thing. Yeah. But I have to tell you that the facility that we're in Las Vegas, they let us stay there overnight without having to tear stuff down, which is great. You know, they got security and the whole 9 yards. And so for us, that's a godsend because you look at the amount of equipment we roll into that place. You know.
Oh yeah. When I've got 60 monitors, and you know how heavy those are.
Yeah. So literally, Chris brought in
down every night.
So Chris's MO basically, when he comes to an event, he brings a theme, and so the theme that I met him originally with was disk drives, and so he brought in, I don't know how many disk drives, like every disk drive ever known to mankind was in his setup. And then he brought a display of monitors. In fact, if you saw on the video that Saj did, the tribute to Forrest, you'll see that event. You'll see
the miles of monitors.
Miles of monitors all the way around the room.
It was great. It was great. It was awesome.
And I was filming at high speed. I was fast forwarding, and it just kept going.
It was awesome.
I think he did printers the year before the monitors, right?
He did printers.
Yep. He did printers.
Same thing. I was reunited with my Star SG10.
Yep.
Yep.
And I gave Chris a printer, which he didn't have, which was great because he added to his collection.
Oh, it was awesome.
Yeah, I gave him a SparkJet, Olivetti SparkJet.
Ooh, was that the one without the ink? The one that uses electricity or something?
Yeah, it's carbon. Yep. Yeah, it shoots it out.
Oh, that's cool.
Yep.
Yeah, so
that's
I had
awesome.
one, and I used it for printing source code. And in fact, when I worked at Central Point Software doing copy 2, I printed out the entire source code listing on that printer just because I wanted to see how it would look. And within about probably 30 seconds, the smell of ozone filled the room. It was crazy. So that's fun.
Hey, maybe I'll just see how many systems I can set up next time. You know, I've got a trailer now, so.
Oh, you also did pets one year too.
Yes, I did.
You did pets. So you had a ton of pets.
I brought pets.
Pet collection.
Yep.
It wasn't much, but it was a nice display.
Pets and disk drives too. You brought all the disk drives for them. Yeah. So we'll have to see what you're going to come up with next for that. So a hardware build, better advertising for the event, solidifying the date. What else is there? Solidifying the cutoff date for the videos and, you know, for the presenters. So I have to second what Joeri said. Saj, you need to get on that probably tomorrow.
Oh, yeah. While we're here on this, I can finish up with a put together again and submit that for the end of the week. Can we tag that on the end of this so that people can see me putting this back?
What I'll do is through the magic of technology, I'll simply just insert it into the spot it was in. We should have gone behind it. Yeah.
Excellent.
So it could be a continuation, and that way,
because I know that we've had people requesting that.
Right.
They're interested in that. So
we should also try to. Since Jim Drew, you're recording this, right? Maybe we can upload a high 1080p version of the whole video.
Sure, I could do that, and then we could also, if you want, Saj, we could actually insert the regular videos into the stream directly.
Oh yeah, so
they're high res.
High res, and then we'll just put the interviews in between. Yeah, that's
right.
A great idea.
Yeah, so we can just edit that out. So it makes it easy that way. And that way, we've got nice high res content. Because we lose, if people are watching this, we lose some resolution going between the Windows machine and OBS and Zoom and back and forth between everything. There's a resolution drop as the codecs fight each other, I guess.
Yeah. I had that issue with mine. It's real hard to see all the little pieces on the
Yeah, there was some presentations with some slides that you couldn't even read the text very well. So maybe with the higher res, we could.
Yeah, we can replace that stuff.
Yeah,
people
replace it.
So.
Yep.
So what else, guys? Anything else you want to add? Joeri, I want you to have the final word, man.
I don't know. I think we need to continue to work on reusable content. I was thinking about that when we had Jim Brain on. You know, he was kind of apologetic of the basics of his presentation. It actually is super usable content. 10 years from now, that is still something that you can look up. You get the basics. We had several presentations that help with that. I think that's one of the with Forrest, he tried to kind of expose the old technology to a new generation and do some preservation in that. And he always made a big point out of making these nice plaques with it as well that would explain something about the product. I think a part of the role that we should have is kind of making sure that the content is something that's not just for the live stream, but throughout the year people will pull up and kind of read and learn from. Same with that tape drive disassembly. That's got a lot of replay value.
Yeah, that's something that people can use for a long time.
Yeah.
Right.
Just like the disk drive disassembly did last year.
Other than that, I thought this was an easier one than last time because we kind of have the technology down. So I'm if we're gonna switch technology, then let's switch early, get up to speed to it so that when we start it, everybody knows what to do, and we can just focus on the content rather than the technology inhibitors.
Yeah, agreed. So,
yep.
Anybody else? Okay, well, I guess we'll wrap it up then, huh? So, thank you for attending. It was good to have you here. And if you're watching this video in 2027 or whenever you might be watching this video, this is the events that happened, and hopefully we'll have an event next year. If you're watching this that late, you know we did. So I look forward to really having a live event. I think that'll be a way to go. But I think this video component will be something we'll always do, just because it reaches a broader audience. Our friends overseas and such that are able to join us and watch, it's great for them, and we do the same for other events over there as well when we get a chance to watch their stuff. So I guess it's 5 o'clock and we will sign off. So thank you, and we will see you